Hello everyone. Today we are going to start the new tutorial SQL Server. For the first video, we are going to learn about what is SQL. Before knowing about what is SQL, what is data? Data is the backbone of our digital world. It is the information we collect and store. Now, data can come in various formats, like it is a text or in a video or an audio or even in an image format. So think of that. Data is the raw material which we are going to store and use it. So we have learned about data, but where do we store these data? There where database comes in. A database is a digital format where we can store all our data neatly organizing and manageable format. It is more efficient than dealing with the scattered files. So how do we manage data in database? To manage these databases efficiently, we can use database management system or DBMS. DBMS is the concept where we can store and retrieve the data into the databases. Specifically, we are going to understand about the relational database management system. There are various types of database management systems. Relational database system management system is one of that in which the data is stored in structured format. Think of that data is structured or even in semi-structured or unstructured formats. Like for structured, it can be in a tabular format, and for semi-structured, it can be a JSON or XML format. And think about unstructured, we can talk like a audio format, video format, or an image. In later session, we will talk about the databases where we can handle these unstructured and semi-structured data. Now we will learn only about the relational database management system. So that's where we will introduce Microsoft SQL Server, which we are going to use throughout the series. And what is SQL? SQL is also known as structured query language, which is used to interact with our databases. So it bridges the gap between the database and us. So we can interact with the database and retrieve and modify and store our data into the database. So SSMS, we are going to use SQL Server Management Studio. It is a tool which is used to manage the SQL Server databases. So let's dive into the practical demos where we can analyze the basic TCL commands, and we can run few examples there. So we are now inside the SSMS. This is how it looks like when you open the SSMS. So I have connected to my local database server. See, there is no databases available for me. Let's create a new one. Click the new query, and we can create database. Let's name it as training DB. So the command executed successfully. Let's refresh the database. Yeah, here we got the database. So we can select the data, choose the database in two formats. One, we can use the use command in the query, or you can also pick it from here. So there is also some other databases available for us, like master, model, MSDB, Temp DB. We will discuss about that further. So now let's execute this command. Okay, so we are now in our training DB. Let's just create a schema. Schema is nothing. It is a logical grouping of tables or views together in a same format. So let's just create a table inside our demo schema. Let's keep ID column integer and name column as varchar and age column as integer. Okay, let's create this table. So now our table has been created. Let's select and see our table. So there is no records. We can insert records through the insert command. Let's give some values to this. So we are going to insert 3 rows inside this table. See, 3 rows has been affected. So let's select and see the records. So now it can be viewed in a table format where you can see the results. So let's see inside our database. Our table has been created under the tables folder. See, you can see the table employee got created under the schema demo. Okay, so what is the system databases? Where master database, it contains all the informations of all other databases you have in your server. And MSDB, it is a database which stores the data backup informations, SQL agent informations, and SQL Server jobs, and those stuffs. And in the TempDB database, you will find the temporary tables which are available for the DB. So let's try to create a temporary table. Temporary tables are referred with this hash sign. So let's create this. So it has been created. Let's see under the tables. Okay, temporary tables. Yeah, you got the table employee temporary table available for there under the temporary table folder. So you can see there are other things like programmabilities where you can find the stored procedures and functions you have created, and you can see the views inside the view folder. How to create a database. So after creating a database, how will you manage the data inside your database? There where tables comes in place. Tables is a structured format where you can store your organized data. So there are two main things in tables. One is fields and another is records. The fields are also known as columns, which is specified with data types, in which type you are going to store your data. And records are also known as rows, which is the actual data you are going to store inside your tables. So you will create a table to organizedly manage your data inside your database. You can have multiple tables, and you can have multiple keys to join those tables to manage the data efficiently inside your databases. So today we are going to learn how to create a table and manage it, like renaming a table, and also how to drop it and how to insert data. So now we are inside our SSMS SQL Server Management Studio. So we have created a database training DB in our last video. So let's open a new query window using the training DB. You can see there is currently no tables available for me inside this database. There is a table which we created in last video. There is no other tables. Quickly let's create a table. So right click on the table folder and click new, and you can click the table. This is a query designer window where you can actually specify the tables in a user friendly way. You can specify the column name as ID. You can choose the data types from this drop down. Let it be integer, and this column allow null values is to specify whether your column name need to allow null or to restrict the null values. As it is a ID column, I don't want to allow this as a null. So second column we can give as name, and for the name we can keep like varchar, and don't want to allow nulls. And age, which is also an integer, and I don't want to allow null values. So you can also change the capacity for your variables here itself. Let me give 255. So after giving this, you can simply right click on this and save as table, and give the table name as TBL underscore customer, and click OK. Now your table get saved. Let's refresh the table folder. There you get the table customer. So let's close this. Now we can see the structure of our table. You have ID column, name, and age. You can simply also see the columns and their data types here itself. So we have created a table using the designer in SSMS. How can we create a table in query? Let's create a table using the create command, create table, and you have to give the table name. Let's give us customer, and inside the circular brackets you have to specify the column names. Let's give ID as integer, comma, name varchar, and age integer, and also we can specify gender is varchar. So while seeing the name is in blue color, which specifies there is a built-in keywords. To avoid this, you can enclose this in a square bracket. And now let's create this table. Command got executed successfully. You can also refresh this and see whether the table got created. Let's see the columns. Here we get 4 columns. So we have seen like how to create tables using the designer window, also using the code. There is also another way to create tables using the existing tables. Let's say for example I want to create a table based on this schema structure. I want to create a table named as employee. So let me create that using the select star into command. I want to specify the new table name, say employee. From which schema you want to create this new table. I want to create it from customer table. So if you run the script, the table employee will get created based on the schema of customer. Also whatever the record inside the customer will be inserted into employees. Let me explain with an example. Let's quickly insert 2 rows inside the customer table. Insert into customer values, let's give some name and some age and another record. Let's insert these 2 rows. So I have inserted these rows inside the customer table. Let's see. Two rows got affected. While let's run this query, you will got the error, the table has not been created. So still we didn't create this table. Now let's create this, run the statement. 2 rows gets affected. Let's see. The table employee has been got created based on the same schema of the customer, and also that data which are present in the customer also get inserted into the table employee. So I don't want to insert any values inside my new table, but I want the same structure of this table. If you want, so use the select into statement, but specify top 0 rows from star into the, let's say, table employee from the customer. Now let's run the script. 0 rows got affected. Now let's see, select this table. So now the table got created with the same schema as customer, but there is no data get affected from the customer. Okay, so now we have learned how to create a table from the designer window, also using the query mode, even also from the existing tables. So now I need to rename the tables. To rename the table, you can use the SP command, or also you can use the designer also. You can click the rename and you can give like what is your table name, table customer. So now the table has been renamed to table customer. You can also use the SP rename command, execute SP rename, and you want to specify your old name, which is the table customer, comma your new name like customer. So it is renamed. Let's refresh and see. So it's got renamed again to customer. So there are 2 ways to rename. You can also use the script using the SP rename command, and you can also rename from here itself. So we have seen like how to create a table, how to rename. So now I don't want the table customer and table employee. Let's delete the tables. You can use drop command, drop table, and you can do specify the table name. So I have dropped the table, and also I don't want this. And I don't want this table. So I have dropped the tables. So now there are two tables present inside my database. So we have created a table, renamed it, and we have deleted some tables. So what is a temporary table and how can we create a temporary table? So temporary tables are tables which are present only for certain period of times. Let's say a temporary, let me create a temporary table. We can create a temporary table, table customer. Now my temporary table got created. So while creating a temporary table, it will available for the session. So this is one session. I can only access this temporary table inside the session. So let me open another window and let me try to access this here. Let me show this. I can access this here. So let me try to access this in another session. Remember, I was under the same database, but it shows there is no table as TBL customer. So the table will only available for only the session where you created it. So whenever you close this session, the table will got dropped automatically. So why we use a temporary table? In some cases, you need a table when you need to store some data, but you don't want to store it in your database. We just want to use it for some complex calculations, for some logics, but you don't want to store it actually. In such cases, you will use temporary tables, which are greatly useful for such process. And you can create temporary tables using this create command. You can also use the select into to create a table from the existing table. Select star into. You can specify the temporary table name, table employee from employee. So the table temporary employee got created and the two rows got affected inside the temporary table. Let's see. You can also see two rows got affected from the employee table inside the temporary employee table. But the temporary employee table cannot be get accessed inside the another session. It shows invalid object name. So we can use it inside our session itself. So there is also global temporary tables where you can access that table in all sessions also. So let me create table employee as a global temporary table. So I have created the global temporary table. Let me access the table here itself. So I can get access this. So if I want to access here, let me run this. So I can also access this here itself. If I open a new session, I can also access this here also. Select start from temporary table. I can also access here. So what is a global temporary table? Temporary table is one which you can use along all the sessions you have opened, but the global temporary table even does not get stored into the database as actual tables. Global temporary tables will be dropped once you will close all the sessions. So if you have 10 sessions, that global temporary table is accessed in all those 10 sessions. When you close the 10th session, the table get dropped automatically. So you can use the normal tables, also the temporary tables, and also the global temporary tables. Each one has its own advantages. So you can use the same SP command to rename the temporary tables as well. And you can also use the select into statement to create the global temporary table even itself from here. So in this video, you have learned how to create a table, how to rename it, how to delete a table. So what is a table, what is a temporary table, and also what is global temporary tables. So and also you can generate scripts for tables that you can use to create other tables. You can generate script to create a table, to drop a table, to drop and create a table. Let me show you how to create script for the create statement of a table. If you see, the script is generating, so it's got generated. So you can use this script to create any other tables based on the schema, or you can also add your desired schemas and create new tables. So we have learned to create tables, rename and delete table, what is SQL and what is databases and what is schema and all things. Today we are going to see the lab sessions where we can create and manage our databases and create schemas and manage schemas, create a user, and how to take a backup of the database and how to restore databases. So this is the agenda for today. So if you are new to this video, if you haven't seen my last video, what is database? Database is nothing but a place where you can store your data and you can manage, retrieve whenever you need that. So what is schema? Schema is a relational collection of particular tables, views, stored procedures into a particular namespace. So what is users? You can assign users for your logins, and you can grant access to select, update or delete, and you can revoke accesses through SQL commands. So let's see that in practical examples. So now I am inside my SSMS. I have connected to my server, and currently I have no databases. So let's just create a database. There are two ways to create a database. You can simply right click this and select the new database, and then you can give the name here. Let's say training DB, and you can click OK. This will automatically create a database for you. See, the database has been created. Or you can also create using the command create database training. Let's execute this. So it's got created. Let's refresh. So 2 DBs has been created now. So we have created a database. How can we rename these databases? Let's say I don't want this training database. I have to rename this training as a sample DB. So there are two ways. You can simply right click and you can click rename and you can give the desired name, or if you have to use the code, then you can use the alter command, alter database name, and then modify name, and you have to specify the new name. Let's say sample DB. Okay, and should remember that when renaming a database, we should have to be in the master database, so that will be no conflict. Let's rename this. So now the database has renamed to sample DB. So there is also another command, SP rename system procedure command. You can also rename the databases using those commands. Let's say execute SP rename, and you have to specify the old database name, sample DB, new database name, and then you have to specify this is a database. So you can use SP rename command for renaming a table, renaming a store procedure, and anything. So you have to specify it's a database. So let's refresh. The database name has been changed. So we have created databases and renamed the databases. So now I don't want the sample database, so I want to delete this. Let's right click and you can click the delete option. It will be dropped, or if you want to use that in the code, you can just use the drop command, drop database, and you have to specify the name. And you should remember that if you are in the sample database and you are trying to drop the database, it will show an error. Let's see that. So now, okay, let's get into training DB. You can select it from here, or you can use the use command. there is also another way. You can just click on this and click Ctrl N to open a new query using the Temp training DB. Let's run this command. See, it shows cannot drop database because it is currently in use. So remember, you have to be in the master database so you can drop any databases. So we have seen like creating the database and how to rename it, how can we delete the databases. So now I have to take a backup for this training DB and then I have to restore it. Why should we have to take a backup? If there is any situation where the database has dropped, then we can use this backup and we can recover the data. Let's see how to take the backup. You can right click the database and you can click the task, and in the task you can see backup option. Let's click on this. So now it shows where to back up the data. Let's remove this and I have to add a new path. So I'm going to browse this. So I'm going inside C drive data codex, and inside this I have going to select the backup, and I have to going to give the file name as training DB in the same naming convention, and clicking OK, and just click OK. See, the backup of the database training DB completed successfully. You can just close this. Now I'm going to drop the training DB. Let's say drop database training DB. So now the command has completed successfully. Let's refresh. There is no database available for me now. Okay, now how can we able to restore the database that we have taken backup earlier? Let's click on the database and you can restore databases. In the restore database pop-up, you can select from device and you can select browse, add, and in that you have to navigate to the path where you have saved the backup file. This is the path, and my file name is training DB. Let's click OK and then click OK. See, it shows training DB database backup fully. Let's click OK. So it shows database training DB restored successfully. So all my data and my database has been restored back. Click OK. Okay. So now we have seen like creating database, restoring, and back up the database. So what is schema and how to create a schema? Let's say create schema. Let's give a name, demo. So now the schema got created. How do we see the schema? It was got created inside master DB. So remember, you have selected the desired database before executing the command. So now inside the training DB, I have created the schema. So you can see the schema inside the security. There is a schema folder where you can see the demo schema I have created recently. So you can manage the schemas to create tables, store procedures, views, anything under the schema. Just create a table using the schema demo. Create table, and you have to specify the schema name. And we can view simply just two columns, ID integer and name as var. So it's got created, and that also create another table. It's also got created. So if you have to see what all are the database inside the server, you can use the system. You can use the system commands like select what all are the names, database names available inside the server. Let's start from sys databases. So there are master DB, Temp DB, model, MS DB, and training DB. You can use the sys command to see whatever the tables available inside our databases. Let's say select start from sys tables. This will show all the tables available in my database. We have created recently the table employee and table customer, which are listed below. So I need to transfer the customer table to another schema. Let's create another schema. Name it a sample. Can use the alter command, alter schema with the new schema name, sample, transfer, and the old table name. So the command got executed successfully. So let's say select start from demo customers. It shows there is no table under the schema. Let's change the schema sample. So it's got created under the sample schema. We have transferred the control. So you can also drop the schema using the drop command. Drop schema sample. Before dropping the schema, it shows like there is a table referred with the schema. So you have to drop the table first to drop the schema, or you have to transfer the control to another schemas before dropping the schema. Let's drop this table and then you can drop the schema. Now the schema has dropped. So you can also use this sys command to list what all are the schemas available inside your database. Select start from information schema dot schemata. You can see DBO sys demo which we have created recently, and all other schemas which are present inside this database. Okay. So now we have understand how to create a schema and how to transfer the schema, also how to drop the schema. Now we can see how to create a user and assign roles to the users. You can use a command create. You should create a login before creating a user. You can use the command create login, and you have to specify the login name with the password and your password inside this. After creating this login, you can just create the user using command create user, your new username. Like you can use demo user. For the login name you have specified here, and you can use command like grant access to select, insert, and also update delete. Delete on for the table which you are going to give the access, and to the username that you have specified. This will give the demo user the select, insert, update, delete operations for the specified table. You can also revoke this access by using the same command by changing the command like grant to revoke. This will revoke the full accesses to demo user on the table you have specified. And also you can see what are the users available under this database using the command select start from sys dot database principals where type this equal to SQL user. This will show what are the users you are having under this database currently. So these are the things we are covering today. So let's just recap. We have learned about how to creating a database, how to renaming it and dropping the databases, how to back up the database to specific file path, and we can restore the database, how to create a schema, how to rename it, and how to drop the schema, how to assign a user with specific accesses. We have learned how to create database, how to create tables inside the database. If you haven't seen those videos, I recommend please watch those videos. It will helpful for you for today's video. Today we are going to see like how to insert the values into your tables in your database, and also we are going to learn what are the different data types we can use in SQL Server. So inserting values into tables plays the majority role, and data types specifically we need to specify what data type you have to store the records in your column. There are different data types available for you in SQL Server. You can specify those data types for your columns as per your requirements, and inserting the values into the table can be takes place in many different ways, and today we are going to learn both the things. So let's get into the SSMS and start our demo. So now I am inside my SQL Server Management Studio. I have connected to my server. Let's open the database and create a new query window, and let's see, I have dropped the tables. Currently I have no tables in my database. Let's just create something. Create table employee. ID. So specifying the data type integer, it says that the ID column is going to be an integer value like 1 2 3 4 5 6 as a numeric terms, and in the name I am going to specify like varchar. So this data type says to SQL Server that I am going to store the string value inside the name column. Also we can give age column, which is also integer, and also a gender column, which is also a varchar, and inside the bracket which specifies the size of the string you are going to declare for the record. So let's create this table, and let me create another table called customer, and here I am going to specify the identity column 1,1. We will learn what is identity constraint and different types of constraint in upcoming videos. Now let's just create this table. Let's refresh the tables. So now we got the table customer and table employees. So I have created the tables. How can I able to insert the values inside my tables? So you can also use the expression. Also you can use the designer. Click on the edit top 200 rows, and you can give the value here. Let's say ID 1 and name Anand, age is 20, and gender as male. And for the next row I am going to specify to Hari. Let's give age 22 and male. Let's give 3. Alias, let's give us age 21, male. So after giving these things, you can just close this. So now the 3 rows got affected into your table. Let's select and see the value. You can use the select statement. Select star from a table employees. So you can see there are 3 rows affected in my table using the designer window in SSMS. Also you can use the insert statement through which you can insert the values in your query. You can give insert into the table name and the values of, you have to specify the ID and the name and then age, then gender. So let me execute this statement. So one row get affected. See, there I got a 4th row in my table. So I can use this insert into my customer table. So let's say number 1, and when I try to execute this statement, I got an error like an explicit value for the identity column in the customer can only be specified when a column list is used as identity insert is on. So we are going to learn about identity in our later sessions. So just now we can fix this issue. We can specify the column names which you have to insert the value. Saying I want to insert the name, I have to insert the age, I have to insert the gender. I just want to insert the 3 values, so I will take the ID column. Now execute this statement. One row got affected. So now let's put this here. Let's select and see. One row got affected and the ID has been generated automatically. So let me insert another row. So let me execute this. Another row got affected. Let me select this. The ID is generating automatically. So what the identity is, starting from 1, it will increment 1 by 1 ID. So we don't want to insert the ID along with the statement. So specifying the column along with the insert statement is another way to insert your records into the table. You can also use the insert into customer select statement. Select what all are the columns you need to select: name, comma, age, comma, gender. From which table? Employees. Employee. So let's try to execute this. 4 rows got affected. Let us select this. You got all the records in the employee table inserted into the customer table using the insert into select statement. So these are the different ways you can insert the values inside your table. Okay, now let's see what is data types in SQL Server. Here I have created a table using the schema in which I have specified like integer, varchar, which all are the data types in SQL Server. Let us see what are the available data types in SQL Server. Let's just Google it. Let's type data types in SQL Server. You will find the first link of Microsoft Learn. You can open that. Here there are the data types categories. That can be a exact numeric, appropriate numeric, date time, or binary string, Unicode characters and characters. Let us explore all those things. Exact numeric. When it comes to a round integer number, then it can be a big int or bit or decimal, integer, money, numeric, small int, money, small money, and tiny int. What is the difference between integer, big int, and tiny int, small int? So if you see it further, you will get like what is the capacity for that for the data type. You can see like integer can only store the value up to the 4 bytes, that is minus 3 power 31 to 3 power 31, 2 power 31. So small int can store little less than that. Tiny int can store only 0 to 255. Big int is the largest integer data type which can store up to 8 bytes. So bit is nothing but the binary data. It can be a 0 or it can be a 1. So decimal and money are also of numeric data types. Appropriate numerics, when it comes to appropriate numerics, it can be a decimal numbers. It can be even a float number or a real number. Both has a capacity of different types. And when it comes to date time, date will only provide you the date, month and year, whereas date time can provide you date along with the time, and the timestamp also specify the same thing along with the date and date time. What is the character? Character, it can be a char, text and varchar, which we use the most in our queries. Unicode strings, which are specified with n varchar, n char and n text. There are also binary formats where we can use the image data types to store our data. So these all are the data types which are available in SQL Server. You can use all those data types in your hands-on, and you can practice all those data types and explore them. What is primary key, what is foreign key, and what is a default constraint in SQL Server. What is primary key and foreign key? Actually, we use primary key and foreign key to uniquely identify a row in a table. For example, whenever we insert records in tables, there must be an unique column which can be used to identify and eliminate the duplicate values. For example, if it is a college management system or a hospital management system, there will be a unique ID which can only allow unique values which can be used to eliminate the duplicates records insert into the table. So thereby we can perform database integrity in our tables. What is a default constraint? A default constraint is assigned to a column. If we didn't supply any values for our column, the default value is automatically assigned to those rows. And using primary keys and foreign keys, we can also perform various types of joins operations. So let's dive into the SQL Server. Now I am inside my SQL Server. I have connected to my server. Let's open the database, create a new query window. So let me create a table. Let's name it as students. Give an ID column, integer. Let me give it as primary key and a name column, varchar, and an age column, integer. Let me create this table. So I have added a primary key constraint inside the table students. So now let me try to insert some values inside this table. Insert to students values 1 comment, age 20, 1. So let me execute the first query. One row get affected in my table, and when I try to insert the second query, it shows an error that violating of primary key constraint, cannot insert duplicate values inside the table students. So after I have specified the ID as an primary key, it does not allows me to insert the null value inside the ID column. So thereby you can perform the data integrity by allowing only the unique values inside your column to uniquely identify your rows inside your table. So let me now change the value as 2 and now insert these 2 rows. Now the rows got affected. Let's see, select and see the table. So there are 3 rows inside my table. So in the first row, for the ID number 1, here is Anand, whose ID is 1. There is no other members with the ID 1. There can be duplicate names, but the ID can uniquely identify the students based on the primary key. We can do this. Let me create another table. Name it as courses. Let me create 2 columns. Course ID, which is an integer, and let me give us primary key and course name as varchar. So now let me create this table. So I have created a primary key for this course ID. So now I need a course ID column inside this students table. So thereby we can map these students to specific courses. To add a column inside the table, you can use the alter command. Alter table. You need to specify the table name, and then you can use the add command to specify the column name. I need course ID column and need to specify the data type integer, and you need to give the foreign key reference for this course ID column, reference to the courses table. In the courses table we are referring to the course ID column. So when I try to execute this query, now a new column got added into my students table. So let me execute this. So there is another column known as course ID and it is in null. Let me insert some values in my courses table. Insert into courses values, comma CSE 2, comma ECE 3, comma EE. So let me insert 3 values inside my courses table. So now let's select the course table. So there are 3 courses available for me. Now let's just edit the 3 rows which we inserted earlier in our students table. You can also use the update statement to insert this, or you can use the designer window where you can navigate to the tables and you can see the student table. Just like right click this, can you edit top 200 rows. In this designer you can edit the course ID. Let me give course ID as 1 and here course ID as 2, and for this row I just going to assign course ID as 10. Now it shows an error like no rows was updated. The data in the row 3 was not committed because of the foreign key constraint error. So as I referred my course ID column as foreign key for the course table primary key column. So if I referred a column as a foreign key into the primary key of courses, what all are the IDs present in the course can only be inserted into the course ID column in students. So it can also perform data integrity. So there it won't allows the duplicate records or even a false value inside the column course ID. So it can also provide a 2. It will accept a foreign key can allow say a duplicate value but not a primary key. Let me give it as 3. So now let's close this and select and see the students. Now the courses got assigned for the students. Let us join and see what are the students present in which courses. Let's use select statement, select star from students. Let give us this alias name yes, join courses C on S dot course ID equal to C dot course ID. So now you can see the ID number 1 belongs to CSC department, ID number 2 belongs to ECE, ID number 3 belongs to EEE. So you can also perform join operations using these primary and foreign key constraints. So it will be useful to perform multiple joins and other operations for you. Basically the primary key does not allow a duplicate value as it uniquely identifies the rows in each table. Every table can only contains only one primary key, but the table can contain more than one foreign keys. You can have 3 foreign keys in a table, but it will allows only one primary key in a table. So now let me try to delete a record from this course table. Delete from courses. Let's say I don't need the ECE department. Let me delete it by specifying where course ID ECE belongs to course ID 2. Let me give 2 and delete this course. It shows an error like there is a conflict while reference to the foreign key constraint in the database table students. So as this is a primary key and it is referred to the course ID in the students table, it does not allows me to delete the record in the course table as it is referred in the students table. Let's see in the select statement. So there is a student in the course ECE, so it does not allows me to delete the course. So if I delete the course 2, then what will be the student belongs to which group? So it won't allow you to delete the records from the primary key table while it is referred to as foreign key table in another table. So if you want to delete the course, first you need to delete the student record. So we can delete the student, delete it from students, where id equal to the student id is 2. So let's delete the student. So the row got deleted. Let's see, there are only 2 students available for me now. So if I try to delete this course, now the delete has been successfully completed, and you can see there are only 2 courses available for me now. One is CSE and another is Triple. The ECE course got deleted. So if you want to delete the record, you first need to delete the records which are belonging to the foreign key present in other tables. So basically the primary key and foreign keys are used to reference and perform joins. The primary key does not allow any null value, any duplicate values. It uniquely identify rows, and the foreign key can identify the values which are relevant to the primary key reference of those tables, and it will enforce the true values, not the false one. So now we have seen like how to use the primary key and foreign keys. Now if I haven't given like specified the primary key in this table, let's say let's drop the table. I have dropped the course table. So it says there is a foreign key constraint for the courses table. So as students table has referred to the course table, we just need to drop the students table to drop course table. So now the table got successfully dropped, and now I am going to drop the course table. So now if I have created the course table like this, and if I need to add the primary key constraint for this course table to this course ID, then I can use the alter command, alter table. You can use the add constraint. Add constraint, you have to specify the name. Let's say primary key of course ID, and primary key of which column? Course ID. Let's give this. And when I try to execute this statement, it shows the error. The primary key constraint on the column nullable value of the table course cannot create constraint. So it shows like we cannot create primary key constraint for the column which is a nullable value, because if we created the column like with not null constraint, then we can enforce the data integrity. So let's drop the table. So now let me create this table. So if I try to run this now, the primary key constraint has added successfully. Let's refresh this table and see the keys. You can see the primary key for the column course ID. So you need a not null constraint to enforce or add a primary key constraint to one table. So we need a unique value in the primary key column, so it must not be a null value. So now we have seen like what is a primary key and what is a foreign key and how it is used in SQL Server. Now let us see what is a default constraint. Let me clear all these things. Now let's drop all of the tables, courses, build. Okay, now let's refresh the table. Now, so I need a column like the entry date. I need to specify at which date the entry of the student has been submitted. Let me give as date time. So we need to specify the date time at which time the entry of the student has been recorded. So in this case, if we forget to note the entry time, it have to take the current date time of the entry. So we can use default constraint. In such cases, we can give default value as get date of. This is a inbuilt function. The get date of will give the current date time of the execution of the query. Let us see. Select get date as current date time. So now the current date and time is 13 February 24, 11:31. So you can use this default constraint while creating the table. Now let me insert some values to this table. Insert into students values. Let me give ID, name and age. If I am going to specify only 3 columns, I need to specify the columns, or it will shows number of supplied values does not matches the table's values. So let us provide ID, name and then age. So I am not going to specify the entry date column supply value. Now let's select and see. Select start from students. So the entry date has automatically generated. So whenever a student entry got affected in this table, if they didn't specify the entry date time for those records, this default constraint will automatically assign the execution time at which the query get affected. So we can use default constraints to specify the default values we can assign to those rows. You can specify anything for any data types, for any columns, a default value can be assigned. So if you want to specify a course, if the course ID has not been specified, you can also give course ID integer and default. You can specify, you can give, if none of the course ID has been assigned to the student, defaultly assign it as 3, and you can use such things using the default. This is a continuation video of our previous video. In our previous video, we have seen like what is a primary key and a foreign key, how to use primary key and foreign key in SQL Server, and also the default constraint in SQL Server. Today we are going to see about how we can delete rows of a table which is a primary key and it is referred as a foreign key in some other tables. We can see what are the alternate ways we can manage that, and also we have learned like what is a foreign key. It helps us to insert only the particular correct records and avoiding the false records to be inserted into that column. So also we have like check constraint in SQL Server, which can also perform the same operation as the foreign key. So let us explore these topics in our SQL Server. Let us get into our SSMS. So I am inside my SQL Server Management Studio. I have connected to my server. Today I have created the script rather than typing in our sessions. So I have created a table creation script for a student table. I have included an ID column and a name column, an age column. For the course ID column, we have given a default value as 1 for the department course ID, and we have referred a foreign key reference in the course table with course ID column. Let's see the course table schema. In course table, we have course ID and course name. Course ID is a primary key and course name. So let us create these two tables. So we just need to create the course table first. So it is referred as a foreign key in student table. Now we have created both the tables. First we need to insert into the primary key table. So 4 rows got affected into my course table, and let me insert 9 rows into student table. Let us select and view the records in our table. Select start from student, start from course. So there are 4 courses and we have 9 students who are referred to different courses in the course table using the course ID column. So now when I try to remove a course from the course table, we get an error because the course ID in the course table is referred as a foreign key in our student table that we seen in our last video session. If you are new, let us try to delete a record from the course table. Delete from course where course ID equal to 4. Let us delete the triple course from the course table. It shows an error that delete statement conflict with the reference of foreign key conflict in the table student. So when I try to delete the row triple E from the course, it says that it is referred to the student Jerry in the student table. So if I need to delete this course, I need to delete the records which is referred in this table, which we have seen in our last video. There are some other alternates where we can handle this. Let's refresh our tables folder where you can see the 2 tables, students and course, which we created just now. Expand the student table. You have keys where you can find the foreign key for the course ID column. So let's right click the foreign key and select the modify option. You will get a pop-up like this, in which you can navigate to the insert and update specification, where you can find that delete rule and update rule. Whenever you need to delete or update a row in the course table, what action should be taken inside the student table has need to be specified here. Defaultly it is set as no action. No action specifies that if we try to delete any records from the course table, then it shows like there is already some columns or rows referred to this course ID. So it will automatically stop the process and it will roll back to the normal state. We will see what is a transaction and what mean by the rollback actions in our upcoming sessions. Just now, rollback is the action which will revoke the statement which we have executed recently, which will not be committed and will not be updated in the table. So currently it is in no action. We can select either any of the option in the list. You can use cascade, set null, set default. Let us select any of this and just see what happens for selected one. So now I going to select set default value. This set default value will assign the default value which we specified for the course ID column. Let me show that. Let's just close this and can just save this to the student table. You can give yes and you can close this. So now you can see that I have given default constraint in the course ID column. So if I try to insert any rows from here without specifying the course ID, it will defaultly assign course ID 1 for those records which we seen in our last video. So now let me try to delete the course triple E, which is referred to student number with ID number 9. So now let me delete this. Let's see what happens. It shows 1 row affected. So now we didn't get any errors. In last we have set no activity, so it got an error like foreign key is referred to that table student. So the query running has been stopped and no rows has been affected. Now let's select and see what had changed. You can now see the student with ID number 9 is assigned to course ID 1. Why he is assigned to course ID 1? Because we have specified the default value for the course ID is 1, which is the course CSE. So whenever I try to delete any records from this course table, the mapped course ID will automatically get changed to the default value, which is course ID 1. So this is another way where you can handle this foreign key referred columns. Okay, let us see the other ways. Let's click the modify. Now we can select set default to null value. This will specify that whenever I try to delete any rows from this course table, we just need to delete that, and whatever the columns referred to this course ID, it has to be changed to null value. Let us delete the ECE department. So let me try to execute the statement. So now one row get affected. So the course ECE has been deleted from my course table. Let's see, there is two courses available for me, CSE and mechanical. Let us select the student table. So the ID number 5 and ID number 7, those two persons have been referred to the course ECE. Now it is assigned as a null value. So when you specify as a null to the foreign key referred ID, then it will automatically assign null value for those students in the records which is referred in the foreign key table. So there is we can also assign the default value for those deleted records. You can also assign nulls. There is also another option which is cascade, which will bind those rows which is referred to this course ID and delete the rows which all are referred tables to this course ID column. Let us see that. Now let's right click and click modify. You can now specify insert and update set null to cascade. So now let's save this. Yes. And then close this. So now there are ID number 2, 4 and 8. These three peoples are referred to the course mechanical. Now let me try to delete the course 2 mechanical. So there is only CSE course available for me in the course table. Now let's see the student table what happened. The course ID 2, 4 and 8 got deleted along with the course mechanical. So the cascade function deletes the record which are mapped to the course ID in all the tables where we have referred this course ID column as a foreign key. So there are three options which we have explored. The first thing will assign the default value which you have specified in your column. If you didn't specify any default value, you can use the alter statement, alter table, your table name, and add constraint default and your default value name, and then you can use the default one for the column name. So you can assign the default value by that way. And the other option is inserting null instead of the referred course ID. And the third option is cascade, which will delete the referred rows in all the tables which are referred as a foreign key. So also the no action will terminate the operation and roll back the activity without affecting any rows. So we have seen how we can handle these deleting operations if the key is referred as a foreign key in some other tables. So now we have seen in our last session, we are referring this foreign key to control the records which are inserted into course ID should be a true one. We should not allow the false value. Let's say that ID2 has deleted. Now let me try to insert 222 course ID for my second member. It shows like foreign key constraint error. So what all are the values present in the course can only be inserted into our student table. It shows that the student can only be in the courses which are available in our course table. Let's say for example, let me drop this. So now I have created the course table again and I have inserted the 4 rows. So here is only 4 records in my course table. It shows there are only 4 courses available for all those students. So when I try to insert the 222 record, it shows like foreign key error, that there is no course ID as 222. We can also handle this with using the check constraint instead of this foreign key. Let us give check course ID greater than 1 and course ID less than or equal to 4. This will specify that the course ID must be inside 1 and 4. Let's execute this. So now there is no foreign key reference for this table. Let me try to execute this first statement. One row got affected. Let me try to execute the second statement. It throws an error like the insert statement conflict with check constraint. The conflict occurred in database training DB for the student column ID course ID column. So it shows like you cannot insert 222 because there is a check constraint which will allow only the certain values. So now let me try to insert 3, which is inside 1 and 4. Let me execute this. It allows 3. So now let me insert 4. So now it allows me to insert 4. What if I insert null value inside my check constraint column? It allows null values because it is not even greater than or equal to 1 and not even greater than equal to 4. It is an unknown value. Let's say null is a blank value or an unknown value, which can be neither a 0 nor 1 nor a negative or a positive thing. So it will allows null values, and only the course ID can be inside 1 and 4. It can be a 1, 2, 3 and 4 because there is only 4 courses available for me. Rather than giving the foreign key constraint, I have specified the check constraint and made this. So this check constraint is also helpful, like checking the age. You can also check the age must to be inside age greater than or equal to 1 and age less than or equal to 100. So no people can live greater than or 150 and 1000. So by giving this check constraint, you can allow only the true values by avoiding the invalid values inserted into your columns. So we have seen like how we can manage to delete the rows in a table column which is referred as a foreign key in some other tables. There we have seen like no action, which will automatically terminate and roll back the activity, and there we have seen the default value, which will assign the default value for the columns when we delete the referred row, and there is a null option where if you delete the referred row, it will assign the null value, and also finally the cascade option, which will also delete whatever the tables which are referred to this course ID as a foreign key. And also we have seen what is a check constraint and how it can be used in what is unique constraint and what is identity constraint. In our previous videos, we have learned about what is primary key and how we can use it in SQL. What is the use of a primary key? We have seen like how we can use a primary key to uniquely identify a particular row in a table. So we can also use the unique constraint to perform the same operation by assigning unique constraint to your column. It can only allow only the unique values inside your column. It does not allow any duplicates to be entered inside the column. You can use this to uniquely identify your rows. Let's say for example, if you are a student, you will be assigned with a roll number or a register number in your college. Let's say that is a unique number which is permanently registered for you. No other people will have a duplicate number as your number. So in such cases, you can enforce the unique constraint to your columns. And what about, and talking about the identity column, it is used to increment the ID columns automatically. We don't need to supply any separate numbers to our columns. So let us see how to use the unique constraint and identity constraint in our tables. Let's get into the SSMS. So now I am inside my SSMS. I have connected to the server. Let's expand the database. Let's create a new query. You can simply click the Control M. So let us create a fresh table. Create table. table student, id integer, name varchar 255, and the age column, which is again an integer. So let's say for example I am going to specify the id as a unique column. You can just give the unique constraint after your data type specification. Let's run this statement. Just press Ctrl E or F5 to execute the statement. So the table has got created. Let's expand the database and tables. You can find the table student, and when you expand the table, and you can see the unique key constraint inside your table. So now let's try to insert some records. Set into let's say 1 comma for each 20. Now let's just execute this statement. Let's select students. Whenever you execute a single query, you just need to select and execute that. So now you can see there is a record inserted into the table. So now I am going to insert another record with the same id value, which shows there is a violation of unique key constraint. So by this way you can only allow the unique values inside your column, and you can restrict the duplicate values getting inserted into your columns. So we have seen like the primary key, which did the same thing. It also uniquely identify the rows in the table. So what is the difference between the primary key and the unique constraint? So the table can only contains only one primary key, but you can have multiple unique keys inside your table. Let's say for example, if I have a Aadhaar number column, let's say for example Aadhaar number will not be duplicated. So if you need to specify the Aadhaar column, you can also use the unique constraint there. So the table can contains multiple unique columns, but there must be only one primary key. So that is the primary difference between the primary key and also the unique key, but both the two did the same thing. Now let's insert another row. Let us create another column with the same unique constraint using the alter table student. Add, you need to specify the column name, Aadhaar id, and it is an integer. Let's say for begin, and it is unique. Let's select this and execute. There's an error like creating an unique index terminated because of the duplicate key value found at the object student. Okay, now let's see that duplicate key value is a null. Let's select this table. You have no null values, but when you try to insert a column in this table, basically you didn't supply the value for these two rows, so automatically a null get inserted into the column. So the unique constraint is a unique thing. So supplying two null values to that constraint must not allow the value. So there is another difference between the primary key and unique constraint. Let's say for example, in our last video we have seen like we cannot insert a null value inside the column which is a primary key, but you can supply a null value for a unique column. It will accept the null value, but it will accept only one null values. Now let me try to execute this another time. It shows an error, unique key constraint. So unique key can allows a null value, but it can allows only one time. Now let us truncate the table. So now the table got truncated, so there is no records inside this table now. So at this moment we can easily add the column inside the table. Now my column has been added to my table. Let's see, there is an author ID. So you can have multiple unique key columns in your table. Let us insert a row and see. Let's say for author number we can give like something, one row got affected, and when I try to insert another row, let me change the ID, but now it shows the unique constraint error because we are supplying the same other ID for the another student. Let's change this, and when I execute this, now the row got affected. So basically you can have a multiple unique constraint in your table columns, and the unique performs the same operations that which must not allows the null duplicate values inside your columns. It can allow a null value but only one time. So this is the primary difference between the primary key and a unique constraint. So you have created a column and specified the unique constraint for this. What if you need to specify for an existing value? Let's say for example, as of now we have a column age. I need a unique constraint for this age column. That age must not have to be an unique, but let's say for example you can use alter table, the table name, and add constraint and the constraint name. Let's say for example unique, and then table name underscore which column, age, and you can specify the unique constraint, unique of age, to apply to the age column. Let's execute this. So it shows that there is a duplicate of the age value in our table. Let's select this and see there is a duplicate, so it will not allow you to execute this statement and it is terminated. Let's again truncate the table. By truncating the table, all the rows will be deleted at once. Now let us go ahead and create the unique constraint for the each column. Let us execute this, and let us execute another value by specifying another number. Now by executing this, it shows error because we are supplying the same age for this column. So we have also add a unique constraint for the column which is existing in your table. You can use the drop command, drop constraint, the constraint name, so it's got deleted. Now let's see, you have constraints. You have two unique constraints. You can also delete it from here. Okay. So it's got dropped. Now let's. So I hope the unique constraint has been cleared for you. Let's drop this table and let us see what is an identity. So now let's use the same table to specify the identity column. You need to specify from where it need to be started and what number it had to be incremented. Let us also create a table using the designer with the identity column. Here we can give ID, and for data type it is an integer. Select integer, and it must not allow null values. And for the next column I need name, which need to be a varchar, okay, and this must not allow a null value. For this ID column I need to specify the identity value. So let's expand this, where you can find the identity specification. In this identity specification you can specify, yes, you can give yes, and it also asks for you at which id it has to be get started. You can specify any numbers that you need to be get started from, and what number it has to be incremented. You can give 2, then it will start from 1 and then insert 3 and then 5, like that. So like this you need to specify the identity, and you can save this as a table. So as of now we can close this without saving. We can use this identity using the query. So I have created the table now. Let's now insert a value into this table, insert into students values. So in our last videos we have seen like you need to specify the column names which you are going to specify the values for. But if it is an identity column, without specifying the identity, you can just give the name and age column. It will accept because the id gets generated automatically by the identity column. So now let's insert the name and the age. So let us execute this. One row got affected. You can select from the table. So it has generated id 1, and I need to insert another row. Another row got affected, so it has incremented the id with 1. So you can use the identity to increment the ids automatically. Let's insert another record. So there are 3 records in our student table. Now I need to delete the second member from the student table. Let me use the delete command. Delete from students where id equal to, I don't need the id2. Let me delete this. So I have deleted the id2. Let me execute this. I have id1 and id3. When I try to insert another row, it has executed. It got supplied with the value 4. So there is id1 and id4 and id3. I don't want like this. I want the id2 need to be filled in this gap. So how can I able to do this? So let us try to pass the value id and name and age, because we are going to specify all the 3 values. So I need the name in id2. When I try to execute this statement, it shows an error like cannot insert explicit value for identity column, as the identity is specified. So when you try to pass the id value explicitly, it will not allow you to pass that. It shows when it is identity insert is set to turned off. Identity insert is turned off basically. So when you want to pass the id column explicitly, you need to turn on the identity insert. How we can turn on the identity insert? Let's use the command set identity insert for the table as on. So when I try to execute this, command has executed successfully. When I try to execute this now, it shows one row affected. Let's see this. So I got 1, 2, 3 and 4. Now when I try to pass the value without specifying the id column, let me insert some value without specifying id column, which we done earlier. Now it shows an error that identity insert is set on. So as identity insert is set to on, you need to pass the id value explicitly. It will not generate the id automatically because identity is set to off, because identity insert is on. When you want to again enable the identity, you just need to turn off the identity insert. You can use the same command by turning off the identity insert. So now when I try to execute this statement, it will allows to insert the query and let me try to execute the select statement. It shows the student has affected in my table. So by specifying the identity, you can use it to automatically generate the ID values for your table. From the table, without specifying any IDs, let me going to delete all the students from the ID. So now let me select the students. There is no records in my table. Let me try to insert a record. One row got affected. So now when I try to select the table, it shows the ID has been affected from 2. Why it is not getting started with the ID 1? Let's insert another value. One row got affected. You can see it is 3. The table has been starting from 2, 3, and again if I delete all the records and try to insert a new record, it gets starting from the 4. So what if I need to reset the values to the identity column? You can use the command to reset the identity column and set the value back to generate from ID number 1. You can use the dbcc command, dbcc check ident of which table, and you need to use reseed, and from which number you need to reseed. If you want to start getting the ID started from 1, you need to specify 0. Now you can execute this statement. It shows dbcc execution completed, print error message, contact your administrator. Okay, now let me select this. There is no records. Let's delete and update. So when I try to insert this now and select this, the ID is starting from 1. Let me execute another value. Now the ID is starting 1, 2, 3 and so on. So to reset the identity count, you can reseed the starting value from specific number by using the dbcc command, and by using the truncate you can avoid these problems. While you use the truncate statement, it will automatically truncate all the values from the table, and it will automatically resets the identity value to the default one. So now I have 2 members. So if I use the delete command, it will generate the next value from the 3. But when I use the truncate statement, so command got executed successfully. There is no records in my table. Let me try to insert the first value. 1 row got affected. Let's select and see this. It is starting from 1 and execute this. Now it is in the correct order. So you can use the truncate statement to drop all the record at once, and it can also automatically reset the identity values to the default value which you have specified. So we have seen how you can use a unique key constraint in your table in SQL, and also the identity constraint, and how you can use this in SQL. You can also see what is the last identity number that got affected by using the scope identity constraint. So you can use this and select this and see what is the last ID that it has generated using the identity column. See about arithmetic operators and comparison operators in SQL Server. Just like in all other programming languages, there is also arithmetic and comparison operators available in SQL Server, and you can use this arithmetic operators to perform your calculations in SQL data, and also you can compare the data using the comparison operator. So let's just explore all those arithmetic and comparison operators present in SQL. Let us get inside the SSMS and let's see the demo. So I am inside my SSMS. I have connected to my server under my DB. So I have created a schema for my table product with a product ID and product name. I have given the price as a decimal value and a quantity column, and I have provided some insert statements. So in last class we have seen the constraints which are available in SQL. There are also 2 more constraints, which is a not null and null constraint. We can use those constraints in our table. The not null constraint is used to enforce that the column does not allows any null value. If we provide not null, then you cannot insert any null values inside the specific column. If you provide null, it will allows you to insert null values. It can have null values in the column. As we are given a primary key, it is automatically enforce the not null function because primary key does not allows any null values inside the column. So let's now create this product table. Let's press Ctrl E, and now we can insert these values inside our table. So what all are the arithmetic operations present in SQL Server? Just like in all other programming languages, you can use plus sign, minus, multiplication, division, and also the modulus. So see everything with an example. Let us just see with the select statement. You can give 1 plus 1 as result. Let's just try to execute this. It will show the result as 2, and let's give 54 minus 76. It will choose minus 22, and 154 minus 76, 78. And you can also use multiplication. It's 11,076. Can use divide operator. It is 2, and the modulus operator. It is also true. So those all are the arithmetic operators present in SQL Server. And for comparison operator, you can use equal to, less than, and greater than, less than or equal to, or greater than or equal to, and also not equal to. You can mention not equal to like this, or you can use not equal to with an exclamation and equal to. So let's see with some examples. So let's select and view my products table data. Select star from products. Let's execute this. You have 11 records in this table, in which you have several products and the price and quantity for all those products. Now I need the product ID, product name, price, quantity, and also the total price, which is the total price for the quantity specified. How can we achieve this? Using the arithmetic operator. You can use select star comma. You can specify price, and you can use the multiplication symbol, quantity from products. Let's execute this, and you can also give this as total price. So the as is used as alias name in SQL Server. Without specifying this, you can also even run this query, but it will display as no column names. So you can specify the relevant column names for your computational column. So now you can see that I have calculated the total price by multiplying the price and the quantity. So now let's just calculate some discounted value. Let's say, for example, if the customer buys 10 quantities for the price, I will give a discounted value of 20% from the total price. So now I need to calculate 20% from the total price. So I have selected the star whole columns, and we have calculated the total price in our previous query. So calculating 20%, going to divide by 100, and then again I can multiply this with 20, and let's give alias name as discounted 20 from table, from our products table. So let's execute this. So now you can see the discounted value for all the products with 20% off. So you can use all the arithmetic operators in your data of your table. And for comparison operator, you can also use, like, let's say, for example, I need the products which are above price 500. Let's say select star from products, you can use the var class, where which column price need to be greater than 500. If the product price is greater than 500, let's just display. So these are the products which have price value greater than 500. You can also include greater than or equal to. This will display if the product has price of 500. Now you have got the tablet value which is at 500. So now I need to display the products which are greater than the average cost of all the products. So here I got 11 products. Let's just calculate the average for all the products. You can use the average function to calculate this average value. You can use an AVG. You need to find the average for price column. Let's execute this. So 684 is the average price. Now I need to find what all are the products that are greater than this average price. So how can we achieve this? You can use subquery to achieve this. Let's say where price greater than select from the products. So by executing this, you got laptop, smartphone, monitor and hard disk are the products which have price greater than this average price of all the products. You can use the comparison operator in such a way to calculate some logics. Let us have some other examples so you can understand the operators well. Now I need to calculate the values of the products which are included in 500 to 1000. So how can we calculate this? You can use the select command from products where price. I need to specify price greater than or equal to 500 and also the price should be less than or equal to 1000. So let's execute this. So these are the products smartphone, tablet and hard disk are included within 500 and within 1000. So I need all the products details and I need to exclude the products whose value is or price is 500. How can we calculate this? We can use the not equals operator in this, price not equal to 500. So this command will display all the products, but it will exclude the product which has the price 500. So you can use all the arithmetic and comparison operators in your table, and you can compute all the comparisons and operations in your table for your data. Logical operators in SQL Server and also the built-in operators which are used in SQL Server for many computational purposes. We will see around like and or not in logical operators and some built-in operators like is null and any all case statements and some other built-in operators available in SQL Server. So let's get into the SSMS and see some live examples for all those operators. So here I have connected to my SQL Server under my training database. I had a table creation script and some insert script for today's explanation. Let me quickly create this employees table. Just connect to the server. So it is got created in the master DB. So let's drop this. So we can switch the database. So under my training database, let us create this employees table. So okay, let's insert all these records inside the table. Let us use the select statement and see what all are the records present in the table. Start from employees. So I have 20 records in my employees table, where I have employee ID, first name, last name, and the department and their salaries and hiring dates. And we are going to see about the not, or, and, any, or, like, in, is, null, between, case, union, intersect, and all those operations. Let us see one by one. So what is an AND operator? A logical AND operator will return a true value if the both conditions is a true one. Let us say for an example, I need all the records where the employee department is HR and should be the salary greater than 50,000. how we can achieve this? We can use the select statement, select star from employees, and we can use the var class where the department of the employee should be HR equal to HR. You can use the AND operator, and the salary must be greater than 50,000. We can also use greater than or equal to 50,000. So it will return all the employees who are under the HR department and whose salary is greater than or equal to 50,000. Let us execute this. So there are 4 employees who is under HR department and whose salary is greater than 50,000. So if I need all the employees whose department is HR or whose salary is greater than 50,000, we can use the OR statement. Now when we execute this, we get 19 rows. There are 19 employees whose department, either his department is HR or his salary is greater than 50,000. So this is the difference between the AND and OR. So we can use the NOT operator, which returns the opposite result for your query. Let's say, for example, here I have selected all the employees who are not in the HR department. So let me execute this. There are 15 employees other than the HR departments. So there are 5 employees from HR department. Let's say I don't need the employees who are in IT department. Now I get 12 employees. There are 7 employees in HR IT department. So this is the use of the logical NOT operator. So these are the logical operators you can use in SQL Server for your various operations. You can handle with these logical operators. And there is other built-in operators like any, all, like. So for this any operator, we can take some example, like you can use the select statement, start from employees where department is IT. So this query will returns all the employees details who are all in the IT department. So I just need this salary column from this. So let me include only the salary column in the select statement. So I got all the salary who all are in the IT department. So now I need the employee details who has salary greater than any one of this salary in the IT department. So I can use the any. In such case, I can use select star from employees where his or her salary need to be greater than any of this IT employee salary. So this will returns all the employees who all are having the salary rate greater than any of the IT employee salary. So let me find the least salary got by the IT department employee. You can find by using the min function, min of salary from the employee table where the department is IT. So this will return the minimum salary got by an IT department employee. So 52 is the minimum value. So the employees who are greater than this least salary of an IT employee will be listed in this query. So one of the IT employee gets salary of 52,000. So any of the employees in this table greater than this 52 will be listed here. If I make this as all, it will see that the employees who is greater than the salary of IT employee, it will check all the IT employee salary, and if the employee salary is greater than all of the IT employee salary, then it will return the value. So there is no employee greater than the IT employee's salary rate. So it shows that the highest pay is for that IT employee. Let us change this as HR department and see the result. So there are 4 employees who gets the salary rate higher than all the HR employee salary. Let us see the highest pay for a HR employee using the max salary statement. So 60,000 is the max salary for an HR employee. So the employees with 62, 63, 64, 65k, will be listed because they are paying greater salary rate than all the HR employees. So in this case, the any and all operator can be used in SQL Server, and you can use the like operator for many string functions. So say for an example, I need all the employee details whose name starts with the letter J. So I can select start from the employee where his first name needs to start with J. I can use like for this. To compare the string, we can use the like the starting with J and ending can be anything. So let us provide the percentage simple. So this will list all the employees whose names starts with J. So I need only the employees whose name starts with J and A. Let me put A. So this will list only two employees whose names starts with J and A, Jane and James. So we can use a like operator for string functions. We can specify n number of iterations for this string function. We can also even discuss this later about depth for this string functions. So in operator, we can use in operator in many cases to find whether the, let's say for example, we can use the department. We can check multiple departments using the in operator. Let's say for departments, I need all the employees who are in HR and also in IT. In such case, we can use in operator without specifying department in IT and department in HR like that. By specifying department in HR and IT, it will list all the employees who are in HR and IT. There are 11 employees. So you can also specify other departments. Even here, sales, I need employees who are present in these 3 departments. So there are 15 employees who are in these 3 departments. So this is the use of in operator. So is null operator can be used in for example, I need employees whose department is null. This will return the employees who has no departments. So here I got only one employee who has not assigned to any department. So in such cases, you can use this is null operator. There is also an is null operator, which is a different one. You can use the between operator for certain amount. Let's say for example, I need the employees who has a salary rate between 15,000 and 50,000 to 60,000. So let me provide between, the salary is between 50,000 and 60,000. So this will list all the employees who are paid between 50,000 and 60,000. So I got 15 employees who has a salary rate. Case statement, I can use a query to find the salary rate. I need to specify the employee as a highest paid employee if the salary is greater than 60,000, and I need to specify the employee as a mid-level employee if the salary is greater than 50,000, and if the salary is less than 50,000, I need to specify as low paid employee. Let us use the select statement. Select start from employee. I need the first name. Let me copy this. First name, last name, and the department. And I can specify the case statement. When the salary of the employee is greater than 60,000, then I need to specify high pay, and when the salary is greater than 50,000, I can specify they are mid pay, and if else they are low paid. And you can provide the end statement. End, you can give the alias name as salary rate. So let me execute this. You can see all the employees salary rate. The employee gets a salary less than 50,000, then he will be mentioned as low pay, and if his salary is 50,000 to 60,000, he is a mid pay, and if the salary is greater than 60,000, then he is an high paid employee. So we can use a case statement in some use cases like this, and we can achieve the same thing using the if class in the SQL Server. Let us see how we can use the if class to achieve this thing. You can specify if the salary is greater than 60. You need to provide three arguments in the if condition. First is the condition, and the second is the true statement, which is the command high paid, and last is the false statement, where you can provide another if statement. This is a nested if statement, so you can provide the condition and the true statement, which is a mid pay, and also the false statement, low pay. So you can close this and close the if statement, and let us give the alias name. Let us select and execute this. This will returns the same output as the case statement, so each has its own benefit. You can use any of this for your requirement. There are case and if statement in SQL Server to perform these condition operators, and there is is-null and coalesce operator in SQL Server. You can see how we can use those operators. So I need to provide the employee details along with the department names. If the employee has not assigned to any department, I need to specify there is no department for those employees. In the select statement, can provide the first name, last name, and department. First name, last name, and for the department, can provide is null. This will accept two arguments. One is the column name, and other is the string value, which need to provide for the replacement value. You can see the suggestion. No department, let me provide. Let's provide no department as department from the employees. So let us execute this. This shows all the employees in the respective department. So Jessica has no department and it is assigned as no department. Is-null and coalesce will play the same role. Let us use this coalesce operator here. Let me execute this. So this two returns the same thing, but the major difference between the is-null and coalesce operator is the is-null is specific to this TSQL, the SQL Server. Coalesce is used in most of the other SQL languages too, and the is-null operator only accepts two arguments. That means you can only provide only one column name and the replacement value, but the coalesce can accept as much as many columns and the replacement value. So there is a major difference. Is-null you can provide only one column, you can provide multiple columns in this coalesce operator. So these are some of the basic operators in basic and built-in operators present in SQL Server. Let me create some sample tables to explain about this union, intercept, and except operator. So these are more related to mathematical operations. Let me create a table, name it as sample 1. We can have two columns in it. One is an ID column, which is an integer, another is a value column, which is again an integer. Let me create this, and I need another table named sample 2. Let me create this too, and let's provide the insert statement. Insert into sample 1 values of 1, 1, and 2, 2, 3, 3, 4, 4. Let's execute this, and in the sample 2 table, let me provide 3, 4, 5, 6 as the values. So I have inserted 4 rows in both those tables. Let's select and see. Select start from sample 1. Let me copy this and paste here, and the sample 2. So here are 4 values 1 2 3 4, and here are 4 values 3 4 5 6. So the union operator will combine both the tables and returns the value. Let's see, it returns 1 2 3 4, 1 2 3 4 and 3 4 5 6, all the values. So just like in the mathematical function, union will return all the set. So let's say for you have two sets, A set A and set B. If you perform A union B, then it will returns the combination of A set and B set. The same thing happens here. The result will return by the combination of both the values of the table. So to perform this union operator, there must be equal number of columns in both those tables. So again, the intercept operator will perform if there are values which are equal in both the tables will be returned. So there is no equality because we have provided value from the select list. Just select the value from the each table. So 3 and 4 are identical in each the table. So the except operator will returns what all are the values present in sample 1 that are not present in sample 2. So execute, 1 and 2 are returned. So 3 4 are present in table sample 2. So those values are not returned in the except operator. So this is the difference between the union, intercept and the except operator. So all these are some of the inbuilt operators present in SQL Server, and other than 3 are the logical operators present in SQL Server. Built-in functions available in SQL Server. Last day we have seen what are the inbuilt operators in SQL Server. So today we are going to say about built-in functions which are available in SQL Server and how we can use those functions in various scenarios for our operations. Let us get into the SSMS and see the live examples. Here I have connected inside my SSMS under my database training DB. I have created a table creation script and some insert statements. Let me execute this and create our customer table. The customer table has been created, and let us insert all these records inside the table. So 25 rows got affected into the table. Let's select and view those records. Select start from customer. So in our table we have an ID column and the first name, last name of the customer. We have the date of birth, salary and joined it. Okay, let us make this so familiar. Let us keep this as an employee table. So this is more related to the employee data. Drop table employee if it is excluded. So there is no employee. So let us create this employee table. Let's create this employee table and insert all these 25 rows inside our employee table. So 25 rows got affected. Let's select and see all our employees. We have the ID, we have the first name and last name of the employees and the date of birth of those employees and their salary and their join date. Let us see all the built-in functions available in SQL Server. So in string function we have length, left, right, substring, char text, replace, upper, lower, ltrim, right trim, concat, format, and in mathematical functions we have absolute, random, ceil, floor, power, square root, rand and sign operator. And datetime format we have get date of, date add of, date diff, date part, date name, format, system date, date from parts and date diff big. And for aggregation function we have some average, count, max, min, and for conversions we have cast and convert. Let us see all those with some simple examples from our employee table. Just like this. First we can do all these string operations one by one. with the help of our employee table. Let's paste this here. Let us select all these functions and let us use this one by one. Let us paste this here. So we have the first name, last name. Let us find the length of the first name of all the employees. We can use the length operator to find the length of the string. So we can provide the first name here, first name. So this will list the first name length of all the employees. Let's see data. You select start from employees and run this together. So first employee has first name with four characters, so we have got 4, and second one 4. So it will return the length of the string present in that column. So it will return the string length of the column we have specified. So this is the use of the length function. And for the left operator, you can use the same first name thing. You can use the left operator. You need to pass 2 parameters for this left operator. Left function, you need to pass two parameters. First, we can give the first name column, and we need to specify from left how many characters you need. I need 2 characters from the left of each employee's first name. Let me execute this. This will return all the employees' first name. It will return only 2 characters from the left side. If I need the letters from the right, then it will return the characters from the right side. So let's say, for example, the first employee's name, first name is a John. So I have given right. It will returns H and N. So if I give the left, it returns the J and O. So this is a function left and right to separate the strings using the specified number. And for the substring, you can give any number of letters inside this as a parameter. So for a substring, you need to pass the column name first and where to start from and where to end. Let's say first name, I have passed the column name first, and I need the letter starts from 2 and ends with 4. This will returns the index starting from 2 to the 4, which means the first name of the employee, the second letter, third letter, and fourth letter, which will returns the 4 occurrence. This is so substring will takes the first parameter as the expression, and the second is the starting position, and third is the length of the characters. So when you hover this substring function, it shows it is a built-in function, and you need to pass the expression in the first parameter, and second the starting position, that is the index I need to start from 2, and third you need to specify the length. That means from the second index I need 4 characters. So this returns the first name of the employees from the second character to 4 letters. So this is the use of the substring function. So we have char impacts. Let's paste this here. So while you hover this, it says that it will accept 2 to 3 arguments, which means you need to specify which column you need to use in this operation. I need to take from the first name of the employee. I need to find the character A. If present in the first name of the employee, it will return the index value of that character, which means so 0 it specifies that there is no letter A present in employee 1. So while I execute this, the second employee has the first name as Jane, so A is present in Jane. So while I execute this query, it will returns 2 as a index value for me because A is present in the second index of the first name for Jane Smith. So while I execute this, you can see for the ID 2 I have got index number 2. So char index will returns the index value of the specified character inside the specified expression, that is the column name. So replace value will replace the value. You can hover this. Replace is a built-in function and you need to specify the expression first and the search character second, and you need to specify the replacement character at the last. So as a first parameter I have going to specify the first name, and I need to search is there any name as John. If it is present, I need to replace it as Joe. So when I execute this, first name, the employee with ID 1 has a first name as John. So while executing this, I got Joe. This replace value will not update the table because while selecting this table it is not got updated. It will only update the name or replace the name in the select statement. So in such cases you can use the replace statement to replace specific value inside your column, and you can use that for your computations. As usual, the upper will returns all the character as a uppercase value for the specified column. I need the last name of the employees all as a uppercase. When I try to execute this, you can see everything in this column is in a uppercase, and you can use the lower to get everything in a lowercase. You can specify lower. So I got all the letters in lower cases. So you can use this to compare the string values. And in LTrim and RTrim, you can use it to remove the unwanted space in your string. Let's say for example, I have inserted a row inside this table. Let's say for example, let me insert another one row inside this. Let me insert a row. Give the ID as 26. Leave everything as it is, and I'm going to leave some spaces here, and I'm going to leave some spaces here. So while I try to execute this statement, one row got affected, and when I try to select this from the employee table, it shows some spaces because I have inserted this as a character value with some spaces. So while I specifying as LTrim, let's select the first name from the employees. Control E. You can see it trims the unwanted space from the left side of the column in first name. So what if I give the last name for this query? Let's see, last name. So I have some unwanted space in the right side of the last name in the DOI. So while executing this, it will shows let's say for example, I need the length of the last name for the employee number 26. Let's use the length function. If I give this for the employee with ID equal to 26, you need to specify the length as a outside parameter value because you need to find the length after using the trim. So you can clear this. Need to specify the var class. While executing this, I got 3. So I have executor Can also proceed with rtrim. That's the same thing. So you can see there are 7 characters here. If I use the L trim, then you can see the changes. It only shows 4 characters. It says that using the L trim and R trim will remove the unwanted spaces present in your string value. So you can use the concat operation to concat 2 or more columns, string columns. If it is a string, you can concat your 2 or more columns into a single column. Let's say for example, I need the first name of the employee and last name of the employee as a full name. So I need some gap between both this. So let me give a space between this and end as full name. You can take this, and while executing this, you can see we got the full name with a gap between all the names. So you can use the concat operator to perform these operations. You can give n number of arguments for this concat operator. It will add all the columns and give you a single concatenated column. And we have the format, which is used to format the strings. Let me give an example. I need, let's say, I need this joining date as only the date format. I don't need this date time format, and this is a string value. So you can use this format operator, format function to format your string. You need to pass the joining date as a first argument. And how I need this? I need the year first, y, and you need to specify the month as mm, and you can specify the date as dd. So this will returns, okay, this is a joining date. While executing this will returns only the date in the specified format. That means I have specified the year, month and date, so it returned as year, month and date. You can specify any type of format that you need to display. So these all are the some of the string functions available in SQL Server. These are the built-in functions for strings in SQL Server. So here are some mathematical functions. Let's see all this with some example. So absolute function. This absolute function will returns the positive value. Even if you pass the negative value inside this, it will convert it as a positive thing. Let's say for example, I have given us select minus 2000 as absolute. When I press execute, it shows plus 2000 for me. Likewise, if you provide the salary column inside this will provide everything as a positive integer. In this case, it's a decimal. If it is a negative number, it will return only the positive number. It is the use of absolute function in SQL Server. And round, you can use this round function to round your decimal values to specific decimal points. Let's say for example, I need the salary with rounding value of 0. So this is the actual salary format. While I execute this, it will round the value to 0 precision. And the ceil, as it is in mathematical function, the ceil function will rounds the value to the nearest greater value, whereas the floor will returns the rounded value of the nearest smallest value. So let's say I need this ceil here. and for the seal you need to only pass only one argument. I'm going to pass the salary column inside the seal. While executing this rounds all the salary rate to the nearest highest integer, and the floor will round the value to the nearest lowest integer value. Let's say example. So this will rounds the value to the nearest smallest integer. So the power function is used to find the square, cube, and the power of the value. Let's say I need the power of 2. This will calculate the square of the salary rate. While I execute this, it performs the square operation. So I need the cube of number 2. You can perform this as 2 power 3. This will execute and give the result as 8. So you can use the power operation in such cases. And SQRT, this will returns the square root of the number specified, and I'm going to pass the column inside this. It returns the square root value for each salary present in the employee table. Let's say for example I need the square root value for 4. It will returns 2. You can provide any value, it will find the square root value using this SQRT built-in function. And rand function is used to generate random numbers. Say for example select rand. When I execute this, I get some random values from 0 to 1. While I execute this multiple times, you can see the number gets changed each time. A unique random number will be generated for each execution of this query. And this sign function will returns the sign of the value provided. If I provide 0, it will returns 0. If I provide this as 1000, it will returns 1, which is a positive 1. If I provide -1000, it will returns -1, which means it is if the value is negative, it will returns -1. If it is a 0, it will returns the 0, and if it is a positive number, it will returns 1. So these are some of the mathematical functions available in SQL Server. So now we are going to see about what all are the datetime functions available in SQL Server. So let's see about this one by one. We have already used getDate in some areas. You will remember that getDate will returns the date time, current date time. While I execute this returns the current date and the time. Currently it is 11:17. It returns the 11:17 time, and it is 21 March 24. So you can use the getDate function to get the current date time. So there are other date functions which are helpful you to find the date related values. You can use the date add function to add any dates. Let's say for example I need all the employees whose joining date. This will returns all the employees joining date. I need only the joining year. You can use the year function. This is also a built-in function which will returns the year value of the employees. I need to add 10 years to all this years. Let's say for example if the joining year of the employee is 2015, I need to give it as a 2025. If it is 2016, I need to give 2026. Like that I need to add 10 years to all those joining date year. Let's use the same query and use the date add function in it. Use this and provide the date add here. The date add will accepts 3 parameters. Let's over here. So the date add will accepts 3 parameters. That is, what is the thing you need to identify. I need to add the year, and how much year you need to add. I need to add 10 years to this joining date here. While executing this, we can combinedly execute this. Okay, we can take only the year from this. We can take this. So now while I execute this, if it is 2015, it shows 2025. If it is 2016, it shows 2026, and so on. It adds 10 years to all this year of joining. So you can use this date add function like these operations. You can also take the month using the month operator. This will slice all the month of this joining date. Let's say for example, this is a third month, this is the first month, second month. Like that, you can use this year and month built-in functions to slice from your dates. So what is the date difference? The date difference is like the date add. Here you have provided the addition, where in the date difference you can provide the subtraction. Let's say for example, I need how many years from the date of birth and joining date of each employee. We have the date of birth and the joining date of all the employees. I need to find how many years difference between this date of birth and joining year. Let us use this date difference to find that. Select start from employee. Here I need to perform the date difference operation where I need the year. So I pass this as a first parameter, and from birth date to join date. So let us copy this. So while I execute this, the employee 1 has started his job in 25 years, 31, 25. This returns the difference between the birth date and the joining date. If I provide this as a year, it will returns how many years. If I provide this as a month, then it will returns how many months difference for that. You can see it is a 298 months, 365 months, like that. You can use date difference operation built-in function for those operations. You can also use the date part to perform the slicing from your date from your dates. For example, we have used the year operator and month operator. You can use the same here. You need to pass two arguments. You need year, it will slice all the years from the date column you have specified. If you need month, you need to specify this as a month, and you can get all the month. If it is a March, it is 3, it is January, then 1. So you can also use the year of or month of function to slice this, or you can use the date part function to slice this. And there is another cool thing like date name. So if I pass this to this function, I need the date name. So this will returns, instead of the value, it will shows as a name. The first employee is joined us in the March and January, February. So you can use the date name such thing, and you can use the format where you have already seen in the string function. You can use the date format. Let's say for example, I need to use this to format my date. Let's say for example, I need to format the birth date. You can see it is currently in year, month, and then date. So I need the date, month, and year. So I need to format this using the format operator. You can pass the birth date column as the first argument, and for the second argument you need to specify the format. I need date, month, and year. I need the birth date in this format. So while executing this, it returns the date, month, and the year for the birth date of the employees. So sys date time, this will returns the current date time, while get date also returns the same thing, but the sys date time will returns the current date time with higher precision. That is, it can give even more precise value for the current date time value than the get date built-in function. So there is date from parts. We can use this to form dates from some part of your operations. Let's say for example I need 1990 and May month and also the 21st, this as a date format, in a date format. So it returns this values in a date format. I have provided just like in a string value, it has arranged this as a date format for me using the date from parts. There is also date difference BIC. We have already performed the operation which is date diff. Let's use this date difference. I have provided the year difference between the birth date and the joining date. Let's see the same example and the joining date. While I execute this, it shows 25 years, 31 years and so on. If I provide month, it returns the date. It returns the month. What if I need the date? It returns this. If I need hour, I need to provide hour. While executing this, it returns this. If I need to perform even more smaller thing with a high precision, you can use the BIC, where you can even also provide seconds. This will return how many seconds he took from birth to joining for the company. So the employee 1 took this much seconds from his birth date to the joining date. You can use a date diff BIC for such big difference operations. So these are some date operations you can perform in your table in SQL Server. So those are some built-in functions available for you. And in the aggregation function, you have some average, count, max, min. Let's see this all with some examples. I need the sum of salary. Select sum of salary from the employee. This will returns the overall sum of the salary of all the employees. So this is the total salary of all the employees. We got the sum value. So I need the average value of all the salary. It returns the average value for all the salaries of employees. So I need a count of records in the table. You can use the count function. This will returns the count of records present in the employee table. So this count function is very much useful for you in many scenarios. If you have a table with more records, let's say for example you have millions and millions of records, if you try to find by executing the query, then it takes so much time and even the server will stops while fetching so much records. So if you need to find how many records available in your table, it's easy to find using this count operator. You can even provide a count of anything from this employee table, then it will returns how many rows are found in those tables. So currently I have 26 rows in my employee tables. So count, you can use count function for those operations. You can perform many other operations using the count function. And the max function, already we have seen this. I need the maximum salary of the employees present in this table. So 70,000 is the maximum salary and the min will returns the minimum salary value. So 48,000 is the minimum salary present in this table. So finally we have a cast and convert function. We have two things, cast and convert function to convert our data types. For example, our salary is of decimal type. So if I try to print the salary, say I need the salary select stock from employees. I need the salary. This will returns as a decimal value. If I need this as a integer value, you can use the cast function. I need to specify, I need to cast this as an integer. You need to specify with the alias name, and you have to give for what value you need to convert this. So now it it is returned as an integer value. You can use a integer and cast it as a string value, and you can make the string value as an integer value, and so many things using this cast and convert function. Convert will also perform the same thing, but there is a little bit difference in the syntax. Again is the convert function here, and for this convert function you need to specify the data type in the as a first argument. I need to specify the salary as a second. So we have seen all the built-in operators available for the string function, mathematical function, date function, aggregation and conversion functions. So these are the most commonly used built-in functions available in SQL Server. DDL commands and DML commands in SQL Server. DDL is known as data definition languages, which are used to create the definition for your database. For example, in DDL commands we are going to see about create, alter, drop, truncate, and those are the DDL commands. And in DML we are going to see about the select, update, insert and delete operations. Let's see everything with an example in our SSMS. So I have connected to my SSMS. I am under my training DB. So there is DDL commands in SQL Server, which means data definition language. It has 4 commands, which is a create command, and you can use this create command to create anything. If you need a database, you can use that create command and create the database using create database and your database name. Let's say for sample 1. When I press Ctrl E, it is executing the command, so it is created. Let me refresh this. So I got the sample 1 database under my server, so I can use this and connect to this database. So you can also use this create command to create tables. Say for example create table, and you can use sample table. You can provide ID column, teacher and name column. So I got the sample table under my database. So here is my table, sample table. So we can also create views using this create statement. Let's say for example employee. So we use this in our previous session. So I need the first name, last name and salary of the employees as a view. Let me create a view using the create view command, and the name it as salary. As you can give the select first name, I only need the first name, last name and the salary. So let me create this. If I try to access this view using the select statement, then I got the first name, last name and salary only in this view. A view is a virtual storage where you have the reference for any tables. You can also join multiple tables and create a view which will not incur any storage for you in the database. You can create view using this create command. You can create a stored procedure. Let's say for example create procedure. Let's give us sample procedure, and let's say I need emp id as a integer, and let me use the begin statement. I need to perform a delete operation. Delete from this employee table where the employee id, let's say we have ID column. You can give the ID equal to the employee ID, and you can end this procedure. You need to specify so now the procedure got created. If so, let me select this table. Now I need to delete the employee 20 Lucas Adam. So let me execute this procedure by passing the employee ID. So for example, you can execute the procedure using execute and the procedure name along with the parameter. I need to delete the parameter ID 20. Let me execute this. One row got affected. So now let's select this table. So the employee with the ID 20 has been got deleted using the view. You can using the store procedure. You can create views, store procedures, and functions, tables, anything using this create command. Create is a more powerful command in SQL Server. So next in DDL commands, you can see about alter commands. Alter command is used to modify any names. Let's say for example, I need to modify this table name. You can use this alter command. You can also even rename the columns. You can add columns in the table. Let's say for example, I need a age column in this table. Say alter table name, add. You need to specify the column name, age, and the data type integer. Let me execute this. So commands completed successfully. So if I select this table, so I got the age column in this sample table. So you can use this alter command. Even you can rename the column. You can rename the table name. You can also use the alter command to rename the database and anything using this alter command. And the next thing in DDL command is the drop command. The drop command is used to completely delete the entire records. For example, I need to drop the sample table. So while I try to drop this drop table, you can use this command to drop this table. So when I execute this, the command got executed successfully. When I try to execute this, I cannot access this because the sample table has been dropped. So you can use this drop command to drop tables, drop store procedures, drop views, and drop the databases even. You can also use the drop command to drop your store procedures. You can use drop procedure and your procedure name to drop the procedures. You can drop the procedures using the drop command. So the drop command is very much useful for you to drop anything that you have created in your database. So the last command in DDL is the truncate command. You have already seen this command. Truncate command will delete all the records from the table, and if there is an identity column, it will automatically resets the identity and starts with the new default one. So let's say for example, I have 25 rows in this employee table. Let me use this truncate statement to truncate this table. Let's execute this. The command got executed successfully. Let's select this table now. So there is 0 records. All the rows got deleted using the truncate command. So these all are the DDL commands available in SQL Server. And let's see about what are the DML commands. So for DML commands, we have select command. We can use this to select the records in our table and view this. The select command is very much useful for us in many purposes. We can view every records using the select command. You can also use the select to insert the values too. So the next DML command is the insert command. So let me create this table first. So there is already the table present. We can use the drop command to drop this table. and now we can create this table. Let's create this. So now I need to insert some records inside the table. You can use the insert command. Insert command is a DML command present in SQL Server, with which you can insert the values inside your table. Let's see, we can use the table name and values. I need to specify the ID and the name. And the ID. Let me try to execute this. 3 rows got affected. Let me select this. So there are 3 records inside my table. I need to change the name of the student in ID2. I can use the update command. Update is the third command in DML, which we can use to update the records. You need to specify the table name and set what column you need to update the value. I need to update the name, set to Jason, where the ID is equal to 2. So now when I try to execute this statement, one row got affected. Let us select the sample table. So now the ID2 name has been changed using the update command. So finally, the fourth DML command present in SQL Server is the delete command. So I need to delete this student from my table. So I can use delete from the table name, where I need to specify from the ID2. So the record in the ID2 got deleted. Let us select and see that. So the student with ID2 got been deleted. If I need to delete every rows at once, you can use the DDL command, truncate table and the table name. So now the schema of the table will remains, but all the records will be deleted. If I don't need the table entirely without schema, so I can use the drop command and drop the table. So what all are the TCL and DCL commands in SQL Server? TCL are the transaction control language and DCL is the data control language. Where in TCL we have transaction commands like begin transaction and rollback activities, also committing the transactions. In data control language we have grant and revoke accesses. Already we have seen how to assign users and use them in your database. If you haven't seen that video, please watch that. I will give the link in the description so you can understand better about this DCL command. Let's get into the SSMS and see some live examples. So I have connected to my SSMS. I am under my server. So let's open a new query window. So let me create a table. Create table. Student. ID. Integer. Name. Varchar. So name is a built-in keyword, so it shows us in a blue color. So to avoid this, you can enclose the name into square brackets. And another thing of using the square bracket in a SQL, you can also give the spaces between your names. Let's say for student name. So when I use this within square brackets, it allows me to leave spaces. If I take this square brackets, then it will shows an error that it takes this std as a separate variable and name as a separate thing. So to avoid these things, you can enclose the words inside the square bracket, so it will allows you to execute that statements. You can also enter age, which is again an integer. So let me execute this. So the table has been created. Let us insert some rows. Insert into students, values. We need to supply the value for the ID, name and the age. New one, Anand, whose age is 20, and So you can also add another row. So let me execute this statement. So 4 row got affected into my table. So let's select the table. Now you can see I have 4 students, their ID, their name and the age. So let's say for example I am going to update the age value for the second student as 21. We can use update statement to update the value, update the table name, set for which I am going to update the age column, set age as 21. So in this statement I need to provide the var class where the ID is equal to 2. Then it will update the student with the ID number 2 as 21. So let's say for example I forgot to put the var class in this. Now let me execute this statement. It shows 4 rows got affected. Now when I select this student table, it shows all the student as age 21, but I need a student 1 as 20. So after updating this, we can't able to change this. It will automatically update in the table and it will be committed. So to avoid these things, we can use the transactions, which is TCL commands in SQL. So let's drop this table. Let's recreate this. Let's insert again this. So now see, now I have the age 20, 22, 21 and 21. So now I need to update the value for the ID 3 as 20. Now I am going to give the transaction. You can use begin transaction command to start a transaction. So now when I execute this, it also shows 4 rows got affected, but when I select this, it shows 4 students updated as 21. But we don't need to worry about this because we have created transaction. Now I can use the rollback command to roll back this update statement without committing my data into the table. When I execute this rollback command, you can see command got executed successfully. Now let me select the student table. So none of the rows has been updated because the transaction has been rolled back. So the update statement has not been executed in this situation. So you can use this transaction to roll back the activities if it goes into an error or an unexpected error. So now you can understand why and when we can use this transactions and how it will be useful for us in the database management. So now say for example I provided the var class. I need to update var ID is 3. So now let me execute this. So I have begin a transaction. Now updated a row. The row has been updated in this session. So what if another user in another session will see what the record in age for the ID number 3. Let's say for example, let me open a new session. Let me copy this select statement and paste here. When I try to execute this, it is executing. There is no records shown. It is still executing the statement. So whenever a transaction is taking place in some session, you cannot view the records until the transaction has been committed or rolled back. So now let us stop this. So you need to roll back or you need to commit the statement. Until that, the other users in other sessions cannot see the records for this table. We can view the uncommitted such transactions using a SQL command, which is you can set the isolation level to read the uncommitted data. Let's say for example, you can use the set transaction isolation level to read the uncommitted data. So while I executing this, the command got executed successfully. So still I didn't roll back or commit the begin transaction. When I try to execute this statement, now it's got executed and it displays the records. And you can see the ID number 20 got changed as age 20. Let me roll back this query. So command got executed successfully. You can see now the ID number 3, age is 21. So here it is 20. When I execute this again, it shows 21. So while a transaction is being executed, you can stop the transaction by rollback or commit, or you can use this isolation level to read the uncommitted data while being the transaction is processed. So we have seen how we can use the transaction command and safely roll back the activities. What if I need to commit this? So let me start this transaction, and before rollbacking this, I need this changes. So we can use the commit transaction. This statement will automatically commit the transaction and it will be directly updated into the table. Now let's select the student table. So now the student with the ID 3 is permanently updated as 20. If I need to roll back this, we cannot able to roll back because we have committed the transaction. So it will automatically saved inside the table. So by using this transaction, you can avoid committing the unnecessary transactions directly into your tables. So we have DCL commands, which are used to grant and revoke permissions to the users for particular tables for particular operations. So let me give grant the select privilege on which table you need to specify. So let me give the select on student table to the user 1. So while executing this statement, the user 1 can perform all the select operations on this student table. We can also provide the update access and also the insert access. Any privileges, all the privileges at once for the selected user. So the grant statement will be useful to provide access for certain users on certain tables for certain operations. After giving necessary permissions, you can also revoke the permissions. You can use the revoke. While executing the statement, the select, insert, update operations for the student table to the user 1 will be revoked, and the user 1 no longer will get access to the student table. He cannot able to select or update or insert the statements into it. So these are the two DCL commands, grant and revoke. You can use this to assign the privileges for your users, to the save points in transaction, and how we can execute the try catch statements in those transactions. So let's get into the SSMS and see them with a live example. So I have connected to my SQL Server Management Studio. Let's get into our database, create a new query window. So now let me create a fresh table, create table, employee. I need the ID column integer, name, varchar, and salary column as decimal of 10,2. Okay, now let's create this table. So now let's insert some records inside our employee table. Let's say insert into employee values, comma, name, and then salary. Let's give 50,000 salary, and for the next employee, let's give 65,000. Third employee, let's give 77,000, and another employee, that's 56,000. So now let's execute the statement. 4 rows got affected. Let's select the employees. So in my employee table, I have the ID, name, and salary of the employees. So now I need to update the employee with ID 2, his salary from 65,000 to 70,000. So we can use the transaction to avoid any errors or misvalues in our query while running. So let's begin the transaction. Let us give the update statement. Update employee, set the salary is equal to 70,000. where the ID is 2. So now let me begin this transaction. So there is a command, there is a function in SQL Server which you can use to identify how many transaction is being processed in your current session. You can specify the @tran count to find how many transaction is being processed in your current session. So currently I have one transaction which is in progress. I haven't committed this or even rolled back this. So we can use the save point to save the transaction values up to certain points. Let's say for example I have provided this update command inside this transaction. Now I am going to save this transaction with a name, say for example save point 1. So now let me execute this statement. After executing this, still the transaction is being in process. I am going to update the salary for the employee number 3 as 75,000 for 80,000. So now let's select and see the employees table. The ID number 2 has been updated with the salary 70,000. Still the ID number 3 employee is at 77,000. Now let me execute this update statement. Now one row got affected. Now let's select and see the employees table. You got 70,000 salary for the employee number 2 and 80,000 salary for the employee number 3. So now I have provided these details. I have entered this statement as a wrong one, but I have entered this employee number 2 with the salary 70,000 is the correct one. So now I roll back the transaction. Only the update statement with ID 3 will be rolled back because we have used the save point for this transaction. So let me execute this rollback statement now. So commands executed successfully. Let's check this. Select star from employees. So I have provided simply the rollback. We need to perform let's say rollback transaction to the save point 1. So now let me execute this rollback statement. The commands which are under the save transaction to this rollback statement will got rollback, and these commands will not be updated. Now let's select and see this value. The employee 2 has 70,000 salary and employee 3 with 80,000 salary. When I perform this rollback action, commands executed successfully, you can see the first update statement is being in process and the second statement has been rolled back because we have provided the save point before this update, after this update statement. So we have provided to roll back the transaction until the save point 1. So whatever the query we have written inside after the save point 1 will be rolled back, and still the transaction is in being process. So when I use the commit transaction, this transaction will be committed. So now let's select and see the employees. The employee with ID 2 has got 70,000 salary. So we can use the save point to specify the rollback actions. If you can specify multiple save points and you can perform the rollback action up to that. If you provide the save point transaction level 2 here up to this point, you can give as save point 2. So if you perform any operations after this, let's say you have performed another update statement here for the ID number 4 as 1 lakh, you can use the save point 2, and if you roll back this activity, the transaction until save point 2 will be in progress, and the update or any statements after the save point 2 will be rolled back. So there is also another function in SQL Server which you can use to roll back all the activities when the transaction ends up in an error statement. So if you get a runtime error while executing a transaction, you can set the exact abort on. So if you provide this, whenever a statement inside your transaction has been ended up in some error, so this statement will automatically aborts the transaction and it will roll back to the normal state. and none of the transactions will be committed, everything will be rolled back. So you can use the set exact abort on to perform the rollback action if your transaction will gone through an error. You can use the save point to save certain queries up to a range, and you can roll back by using the save point name. It will be helpful for you in many situations where you can specify the save point name and perform the rollback actions for your transactions. So you can use the try and catch statement to safely execute your transaction process. Let's say, for example, let me give the begin try statement, and let me provide the begin transaction, and let's perform an operation inside this, and let me commit this transaction. Let me provide the n try and complete this try block and begin the catch block. The catch block will be executed if the try block fails. So we can provide the try count greater than 0, then begin rollback transaction, roll back the transaction, and let's end this if statement, and let's end the catch statement. In this I have provided to try this transaction. So I have provided the begin transaction and commit transaction. In this example I have provided only one statement and only one transaction. So what if I provided multiple transactions? So let's have for example, I have provided one transaction here and forget about this try block statement. Without using the commit transaction, I have behind the transaction. This will end up that there is a transaction which is being processed and is not committed. So only these two transactions will be committed, because after executing these two transactions you have performed the commit transaction. So this transaction is being in process, it is neither rollback or not committed. So what if I enclosed all these statements inside a stored procedure and executed this stored procedure activity? So in such cases this try catch will be useful for us. So it will try to execute all the statements, and in the catch block I have provided if the transaction count is greater than 0, begin and end up with a rollback transaction. So now it will check that while executing this transaction it will show a transaction count as 1, and after executing this transaction the transaction count will be 2, and while executing this commit statement the transaction again turns to 0. And we have another transaction command after this commit statement. So after executing this transaction it will be turns to 1. So in the catch block we have provided if the transaction count is greater than 0, begin the rollback. So we have provided the catch statement. This transaction will be automatically rolled back because we have provided if the transaction count greater than 0. So by using this try catch statement you can handle the errors that can be happened in your transactions. So we have seen what is the function to find how many transactions is being processed in your session, and what is the exact abort function, and how you can use the save points to save certain transaction commands and roll back by using the save point name, and how you can avoid errors by handling it with a try and catch statement. What is distinct and what is order by commands in SQL Server? Distinct command is used to filter the rows. It can only display all the unique values in your column, and order by is used to arrange your results in ascending or even in descending order. So let's see both the concepts with some examples in our SSMS. Let us get into that. So now I am inside my SSMS. I have connected to my server. Let's expand the database. Let's create a new query. So let's create a DB. Student. With an ID column. Teacher. The name column. care each integer and department as varchar. So let's execute this table. So now you can see that I have created a table student. So you can see I have an ID column, name, age, and department. Let us insert some records into this. Set into student values. Age and the department. Easy. So let's copy this. So let's say for example see. So let's insert these records. So let's select the values now. You can see I have 5 students who are in different departments. Now let us say I need all the departments. You can use select departments from students. This shows me all the departments where all the students are present. So you can see that we got CSE twice because 2 students are in CSE. I need only the unique values of the department. How many unique departments are available for me? So you can use the distinct command. This keyword is used to filter only the unique values. So now you can see that you can see 4 departments: CSE, ECE, EEE, and mechanical. So you can use the distinct command to filter out the distinct values. You can filter all the values in any data types. If it is a character, it can filter it. Even in an integer, it can filter the value. So now you can see I have 5 students inside my student table. So I need to arrange the students in alphabetical order. So let's say for example, based on the name of the student, I need to arrange this records. You can use the order by command. Order by, you need to specify based on which column you need to order by the value. I need to order by the name column. While I execute this, you can see the table has sorted in ascending order based on the name. If I need to order by the departments, then you need to specify order by department. Then you can order the department value based on the department column. You can specify any column, you can order the values. So now I need to order the names in a descending order, then you can use descending. So without specifying ascending or descending, it will automatically defaultly assign as an ascending order. So you need to specify descending to sort the values in a descending order. So I need to get which student is aged student. So let's replace this with the age column and give the order by condition as descending. We get that the student with ID number 4 is the most aged student in the class, and second and third you can order any column in ascending or descending order by using the order by keyword. So you can filter the records through the distinct command, and you can order the result set by using the order by command. What if I provide distinct star from the students? This will list all the values, because if we provide distinct for the all the records in the table, then if any of the column is not identical, then it will list this entire row if we provide as a star. So if you need to specify only the name or age or department where you need to find the distinct values, you can specify the specific thing and find that. And while you using the order by command in your table, let's say for example we can add some null values inside this department column. 6. Let's add 2 values. Can only change the ID column and leave the department as null. Two rows got affected. So now let's select this. If the value contains null values in the department, let's sort the department. Now select this statement. So it is sorting defaultly null as the last value. You can also provide to specify null as first. You can put case statement, case when the department is null, then return 0, else 1, and you can end this case statement and provide the department. So now while you execute this command, all the null values will be listed first, and then your department will be sorted in which order you are specified. So you can provide multiple sort orders. Now let's say for example, let's take this null value now, order by departments. Now you can see it is ordered the departments in descending order. Now you can see Shahrukh is in the first and Anand in the second. Now I need to order in the same department, I need to order with the name, I mean in the alphabetical order. You can specify. So in such cases you can provide another filter. I need to arrange the name in ascending order. So now while you execute this statement, you can see if the same department, then the name will be sorted in ascending order. So you can use multiple sort orders in this order by statement and having keywords in SQL Server. What is a group by and a having command in SQL Server? Let's say for an example, you have a table of employees. You need to group all the employees based on gender. Let's say for example, you need to group all the males as a separate group and females in a separate group. You can use group by to group these things in categories. So you can use group by in such cases, and the having class is used to filter the values. Like using a where class in your select statement, you can use having class wherever you use a group by condition. So let's say detailed about this group by and having class with examples in our SSMS. Let's get into that. So I am inside my SSMS. I have connected to my database. Here I have my table creation script and some insert statements. So without any delay, let's create this table first, and let's execute all these insert statements. So 14 rows has been inserted into my sales table. So let's select the value. Let us use this select command. So now you can see that I have a sales table with categories, products, amount and sales date column, and we have 14 rows in this table. So I need to show the category wise data. For an example, here I have electronics, clothing, books. So I need to group all this and show the records. You can achieve this by using the group by command. Say for select star from series. Let's say I need the sum of the sales amount. Sum of sales amount from the sales. So this sum aggregation function will return me the sum of all the values present in this table. So it will calculate the sum. It will add up all the amount in this table and returns the value. So I need the sum of the amount based on the categories. So if I provide category over here in the select statement and select this along with this statement, it shows an error. It says sales.category is invalid in the select list because it is not contained in either an aggregate function or in a group by class. It says that if a selection value in your query is in an aggregate function, then the other function need to be an aggregate function or it has to be included in the group by class. So as the category is a string value, we cannot use any aggregation function. So we can group these categories and provide the value. Let's group by the categories. So while executing this statement, you can see all the values in the categories has been grouped based on the category books, clothing and electronics, and the related elements amount has been added up and shown in this column. You can also provide the sum value as with an alias name as total amount. So this will returns the category and total amount in each categories. In books we have 850 and clothing 2000, electronics 2850. So group by is used to group the values based on the condition you have provided. Here I have provided I need to group the values based on the category. So if I provide product in this group by command, what will happen? It shows an error that you have provided the group by in the product in the group by list, but you haven't provided category in the list. So if you need the category, you need to provide this in group by class or you need to use an aggregate function. So now for an example we can use the product. So based on the product it will returns the sum of the amount. As the products are unique, it has provided me the individual elements. So let us stick with the category column. So now you can see the table values has been grouped based on the categories. You can also use order by in this to order the results based on the category. So it has been arranged in order. So you can also provide multiple groupings. For an example, if you have other columns which also allows you to group the values, you can provide a comma and provide the next column value, the next level of hierarchy where you need to perform the group by action. So as of now in this table I have no hierarchy level of grouping. So let's take some other examples. So I need a scenario where I need to display the group category value and its product along with its price. Once all the products in the category has been entered, I need to show a row which displays the total value of the particular group. So we can use the grouping set in such cases. So let's say I need to select the category and product and sum of the amount. I also include the product in the select list. I've included the product from the sales and I need to group by with the category column. So you can use the grouping set. Now you can provide on which basis you need to provide the group by first. I need to group the values based on the category and I need to display the total based on the category and products. Once all the products in this category has been entered, I need to display the total. So I can provide this category and product here and let's close this. So now you can select this query. You can see I got the books category first and all the products listed and their relevant prices, and in the fifth line you can see that I got the books category and here is a null value which gives me a total value of this particular books value. So let's use isNull function to display if the value is null. I need to provide this as total. So now let us execute this. So now you can see that I got all the book categories in this and their products in the next row, their prices. Once all the books all the products in the books category has been entered, the total price has been generated in the next row. So again, just like the books, I have the clothings, and once all the products in the clothing has been entered, it has displayed the total value in the next row. Just like that, we have also provided the total value for the electronics. So you can use the grouping sets to group the values in this order. So also I need another row in this select statement which displays all the grand total. So you can use the roll up function in this group by to get that. Roll up is an inbuilt function which allows you to find such results. Let's group the value by the category and the product. Now let me execute this. Now you can see we got the same result as the previous query. Here we got another extra row which displays the grand total of all the products. So let's again provide isNull. If you don't understand what is this isNull function do, let's watch the previous videos where I have explained all those inbuilt functions in SQL Server. So now you can see at the last row you got the grand total which displays all the total price of the groups category available for me. So you can perform group by action in all these ways to group your values based on the columns. So what is a having statement? Let's say for example you have this select statement, and this too. Let me place here. So while executing this statement, I got all the rows. I just only need the books category. What we can do is we can usually use the var class and provide the category as books. So when I execute this, I can filter out only the books value in this table. So you can use var class in these select statements. So while using this group by, you can also use the var class here before the group by command, var the category equal to books. So this will return only the book category. We can also get the same result by using the having statement. So now let's execute this statement. So this will return the same result as the select statement. Let's see what is the exact difference between this having and the var class. You can use the var class in a select statement, an update or an insert or delete statement, anything, but you can use the having command only in the select statement, because the having command only can be used while you use your group by statement. Usually you will use the group by statement whenever you select a value. So the having class can only be used in a select statement, but you can specify the var class to filter the values for your update or even a delete command in your SQL Server query. And the major difference between the performance related to the var and having is the var. When I execute this statement, the var class will check each row in the table and filters whether the category is books, and it checks each row and then it will return the value for me. So when I using this having statement, it is after the group by statement. So while the query is executing, the group by statement will be got executed. So this statement will be filtered by this group by statement. So the having function will work only in this grouped value. So the filtering will be even more fast when compared to the var class. So your performance of the query will be faster while you use having class instead of using the var class in your group by query. So both of the statement returns the same value. We have only 14 rows, so we don't see much difference in the query execution. If you have a big query dataset, then you will find the major difference between this having and the var class. And again, an important thing and the difference between this having and var class is that you can use the aggregation conditions only in the having class. You cannot provide any aggregation comparisons in your var class to filter your values. Let's take an example. You can select this sales value. So I need to return all the records in the sales table where the average amount of the sales need to be greater than this selected value. Let's say for example where I need to provide the average amount. We can use the AVG function, which is an inbuilt function to find the average. We can provide the amount column where average of amount, where the amount is greater than average of the amount. So when I execute this, it shows an error that an aggregate may not appear in where class unless it is an subquery contained in a having class or a select list. So it says me that you cannot use aggregate functions in where class unless you enclose this aggregation function into a subquery or a select statement, or you can use the having class to achieve this. So you cannot directly access this by using the where class. You can use subqueries instead to achieve this. Select average amount from the sales, and then you can compare this with the values to execute the statement. So you cannot directly compare an aggregated function in your where class unless you use this command inside a subquery. So now apply the same logic in this group by command. Now you got the sales, sum of the amount we have provided in the select statement. Sum of the amount need to be greater than the average of the sales amount. So it says that you cannot use the aggregated function inside your where class unless it is enclosed in a subquery. It shows the same error, but when you use this in a having class, let's provide this here. So you need to provide the having class after this group by. If you need to provide the where class, you need to provide before this group by. So now you can see this statement has been executed. We can use the aggregation function in having class, but you cannot use an aggregate function in your filter command where you use the where command to filter out your values. You can just use your column names, but you cannot provide any aggregated values to filter out your queries. So you have seen what is the use of a group by class in your select query. You can group the result set based on a particular order. We can give multiple grouping values by specifying comma and give the next hierarchy level of grouping, and you can use the grouping sets and roll up to group the values and get the sum of the specific category. And you can use the having class to filter out the values instead of where class where it is quick, and you can and having class is more compatible when you are using group by in your query statement. And fetch next function in SQL Server. We can use the top function to filter out how many rows you need to show in your filtered query, and the fetch next will also work the same thing, but you can specify from which line you can start and we need to end in which line. So let us take some example and see live examples in SQL Server. So I have connected to my SQL Server. So let's get into our training database. So I am inside my training database. Let's create this table. So I have some insert scripts. Let us insert this into our table. So now 7 rows got affected. Let's execute again. So totally 14 rows got affected in my table. Let's use the select statement to view the records. You can specify the table name. So now you can see there are 14 rows in my table. So typically the top and fetch will work in the select statement. You can filter how many rows you need to display in your select statement. Let's say for example, now I have 17 rows in my table, which is displaying because I have wrote to display the 14 rows in the table. Let us use the top function to filter only the top 5 rows. Let us specify top 5 start from the student table. So by using the top function and specify how many rows you need to filter, we can get top 5 students from the student table. So we can use the top function to filter how many number of records you need to show in the select statement. So we can use the fetch next only when you use the order by command in your query. Let's say I need to order by the ID column. So by ordering this table with the ID column, you can see the ID column has been ordered in ascending order. You can even order this in descending using the DESC command. So now you can use the fetch offset 0 rows and fetch next 5 rows only. By using this command, you can fetch the first 5 rows in the ordered list. So you can specify in the offset, you can specify any starting value and any ending value. Let me give, I need to skip the top 2 values. So let's offset 2 rows and fetch the next 4 rows. This will skip the first and second row, and it will fetch the 4th to 6th row. So you can see the ID column with 1 and 1. The top 2 rows has been removed and the next 4 rows has been filtered. So the difference in the top and the fetch 2 rows is that you cannot explicitly specify how many rows from starting to ending. You cannot specify in top. It can just filter how many rows you need in your select query. But in the offset and fetch next row, you can specify from which you need to start and from where you need to end it. So performance wise, there is no difference between these two filter commands. You can simply specify top function to filter your values, and you can use only the fetch next rows only if you have a order by command in your select query. So let's say if you have millions and millions of records, you just need to see the schema, that is the column which are available in the table. You can just specify top 100 rows, which will give you how the schema is in the table. So you don't need to execute all the table values and what all are the null values, and how we can handle this now null values in SQL Server, and how the null values can affect your performance of the query in your tables. So what are the null values? The null values represents the absence of a value in the database column. They are not an empty string, or they are not an zero value. They are significantly unknown or a missing information. If you are a developer, you have a web page which you use to collect the information from the user through your website, or you can also take an example for Microsoft Forms or Google Forms, where there are some optional values field which the users may not fill, and in such cases, those optional values without filling any value may be inserted as a null value. So inserting a null value in your tables, how can affect your performance of the query, and how you can rectify the problems by handling those null values. We can see some live examples in SQL Server about these null values. So now I have connected to my SQL Server. Let's expand our database. So we have a sales table already in our database. Let's just use this table. I am going to edit the top rows to specify some null values in the table. So here I am going to specify some null values. Can provide null for clothing and for headphones, and you can specify null for this jeans, and an electronic item. So I have specified some null values in the product column of my sales table. So let's close this. Now let's select and view this table. Let's drag and drop the table name. Let's execute this. Now you can see that there are some products which are displaying as null, which we have edited in the graphic view. So here are some null values in my table. So there are only 14 rows in my table now. So I can easily find what are the null values in this table. How can I find if my data set is a big one and I have millions and millions of records? So there where we can specify the where class to filter that we have null values in the products. So we can specify the column name, and we can put is null function, which will filter what all are the products that are displaying as null. So you can find you can see 4 products are displaying as a null value. You can also provide is not null. This will give you what all are the products, the rest of the products which are displaying the values for the product. So we have 10 products which have specified the product name, and there are 4 products which are displaying as null. So I have just used this for explanation. In the real case scenarios, you can take like creating a table for user management. Let's give us user table, and can give ID. Mostly the ID will be auto generated, so let's give identity. I am giving the seed value and the increment value as 1, and I want to specify the name. Varchar and the age, integer, email as varchar, and the gender. So varchar, can specify 50. Okay, so I can specify the not null constraint in the table values which are does not allow null values. That is, these columns are required values where you must need to provide any values inside this table. So you can specify the optional fields with a null value, which will allows you to insert null values inside the specific column which you have provided as null. So in this table I have provided gender to be an optional column, so people may insert their gender, may not insert their gender, so I have specified as null. So this gender column will accept null values, rest of all the columns will not allow any null values to be inserted in this table. In the previous table we have seen 4 null values are present in the table. We can filter out by using the is not null function to specify what all are the non null values in the table. So I need to see all the records. Let's take this filter out. Now you can see it is displaying us null values in the product field. I need only all the records. If it is a null, I need to display as no products available for that particular category. So we can use the coels function, which we have seen earlier in our previous videos. So you need to get more familiar with this built-in functions in SQL. I have provided another video where you can understand all the built-in functions in SQL. So let's just provide this as a no products available for this. And we can provide the category name. So now you can see if in the category if there is a product, it will be displayed. If there is no products, it is displayed as no products. So you can use the coels function to replace the null values in your select statements, and you can also use the case statements to avoid this. You can give case when the product is null, then I need to display this as no products, else I need to display the products, end as products. So now let's select this. This will give the same result. If the product is available, it will display the product along with the category. If there is no product, it will be displayed as a no product value. So we have used a case statement, or you can use coels function to avoid displaying the null values in your table. So we have seen like we can have optional columns which can allow null values. How these null values can affect our query performance. So we can see we can have multiple tables which are denormalized, and we can use joins to combine the value and select the desired result. In such cases, when your join condition column contains any null values, it will be affect your join condition, and you cannot get the desired results. So you need to be very careful when your column has a null value. You need to specify the correct join order, that is a left, right, or inner join. So the other query performance issues regarding the null values are when you are having some indexing in your tables. So we can specify explicit indexing values for your tables to fetch the data even more faster. You can use that indexing operations to improve your performance of your query. So if there is a null value, your indexing will be affected. The performance of your indexing will be affected, because as there is a null value, the indexing performance will be very much slower. And regarding the filtering, we have specified where the product is null. So whenever you filter the value, if there is a null value, then the performance of the query will so much reduced, because that the SQL Server needs to identify and take one by one values if it is a null or not null. So using such queries in your solution will reduce your query performance. So you can handle those things in your table itself while you creating a table. If it is an optional value, let's say for example in our case there is a gender, so you can specify a default value using the default constraint which we have seen earlier. You can give default values for the genders. Let's say for example in my case I have just specified as a empty string. Empty string and null are not same, because empty string is a character value, it has a specific value, it is a string. But null is neither a character nor an integer, it is just nothing. What is sequence and what is window function in SQL Server? In SQL, sequence is auto incrementing or automatically generating integer values. Take an example for identity, we can use to increment our ID column or for a primary column to automatically insert values into our ID column without giving an explicit value. So you can use sequence where you cannot use an identity column. So take for an example, in Fabric warehouses you cannot able to use identity column as it doesn't support any identity values in your column. So in such cases you can use sequences alternate for that. And in window functions, most of the ranking functions will use the window functions, basically the row number, rank, dense rank and Ntile. So you will mostly use the windows function in such area, and also you can use window function in some aggregate values. So let's see everything with some live example in our SQL Server. So I have connected to my SQL Server. Let's get into our database. Let's create a new query window. So what is a sequence? Already we have seen, like it is automatically increment or integer value. So to explain this, let me quickly create a table. Create table, my table. So I just specify two columns, an ID column which is a primary key. A primary key is just, we can specify that it will only allows unique values and uniquely identify each rows, but you cannot automatically generate any integer value for your column. So now you can just create this. So if you need to increment this ID value for this table as auto generator, you can create a sequence. You can use the command create sequence and you need to specify a name. Let me give us my sequence, and you need to give the start value. Start with, I need to start with 1, and you need to provide the increment value, increment by 1. So this will perform the same as identity of 1,1. So now let me create this sequence. So the sequence got created successfully. So you can see I have created my table first and I have created the sequence separately, but we can make use of this sequence for this table. So the another use for using a sequence is you can provide the sequence for a number of tables without specifying the identity column which is specific for your specific table. So let me insert some rows into this table. Let's use the command insert into the table name, and you need to specify the column name. Let's put values, and here you are going to insert the value for the sequence. So you can specify next value for, and you need to specify the sequence name. So in my case it is my sequence, and I need to specify the name. And let us copy this and insert some values. So let me try to insert these rows. So 4 rows got affected. Let's select and see how the records got inserted. Let's use the select statement. So now you can see that the ID, I didn't specify any explicit value for the ID column. It is just auto incremented for each value that I have inserted. So you can use the sequence to perform the auto increment for your ID column, and you can pass the next value for the sequence. This will automatically finds the existing value and increment the value by whatever value you have specified. So just like in a identity column, you can specify anything. So I need to start with 2 and skip 2 rows. It can possibly anything. You can just specify your sequence and use it in a number of your tables. So now, what is a window function? A window function can perform calculations of a set of rows that are related to the current row. So you can use this window function in most of your ranking operations. You will use the windows function in the rank function, in the row number function, and we can also use those things for our aggregation values. Let's see them. So let me open my database and see the available tables. So let me take the sales table for this example. Let's select and view the records from here. So now you can see I got 14 rows in my sales table. Now let's see how the windows function is used in the ranking function. So let's copy and paste this. So along with this table data, I need to specify the row number. So there is an built-in function row number in SQL Server, and the over function, which is basically known as window function, and you need to specify partition for this value. Partition by, I need to get the partition by the category, and then I need to order it by the amount and descending. So let's take this as row number. Let's execute this statement. You got the row number for all the values based on the category and ordered by the amount in a descending manner. So you can also sort this based on order by the row number. So it will show you the values based on the row number. So for each category there are one row number for the least amount, and it will be incremented for each category. So you can use the window function in your row number, rank, dense rank, and any other ranking functions in SQL Server. And also, let's see another example. Select category, comma, sum of amount as total amount from the sales table. So let's group by the category. So here you can see the values are grouped based on the category. You can get the same result without grouping the values, but with the help of Windows function. Let's see how we can achieve this. Let's put select and let's copy and paste this from here. So you can use the window function here, put over, and you need to partition by the category value. So the order by is an optional value. Without specifying this, you can achieve that. Let's put distinct value, and now you can see, let me run both the queries at the same time. So both the query returns the same result, but in the second query I have achieved the same desired result without grouping the data. So you can use Windows function for your aggregation operations too. So basically the common Windows functions are the row number, and you can use rank and the dense rank. In aggregation you can use sum, average, and the max-min functions. You can use the window function for all these operations in the SQL Server. So the main thing you need to consider with this windows function and the sequence is that the sequence and window function can impact your query performance, especially when operating systems of your data is a large data set. So you need to carefully handle the indexing and partition for the better query performance when you are handling with the sequence and the window functions. What is union and union all in SQL Server? Basically, we will use the union and union all function to join two or more tables when there is no primary or foreign key referred to the joining tables. But you need to have the same number of columns for the joining tables. But you don't need to have any primary or foreign key references. You don't need any conditions for this to make joins. But there must be equal number of columns in the source and the destination table. You can easily join the tables using this union or union all function in SQL Server. So let us see some live examples how to use this union and union all, how this union and union all differs, and how union differ from the normal join in SQL Server. So let's get into the SSMS and see some live examples. So I have connected to my SQL Server. Let me open a new query window. Okay. Now let's switch to our training DB. So inside our training DB, let's create a table. Create table 1 with an ID column which is an integer. So let's don't provide any primary key constraints. Let's give a name column which is absolutely a varchar, a string column, and the age which is integer, and email as varchar. So let's create this table. So I just going to create another table named as table 2 with the same schema. So two tables got created inside my DB. So let's browse to our training DB. Let's open the tables, and you can see I got table 1 and table 2. Now let's try to insert some values into our table. Set into table 1 values. So let's provide the email. Let's copy this, paste. Let's edit some records. So now let's execute this statement. 4 rows has been inserted into my table 1. Let's see. Now you can see that in my table 1 I got the ID, name, age and the email. So let us insert some value into our table 2. Let's change some names. Let's do this. So we can also add another number. And let's give an email. So now let's execute this. 5 rows got affected. Let's select and see from the table 2. So now you can see here I have 5 values, the ID column, name, age and email address. So now let us execute both of this query. You can see in the table 1 I got 4 rows and in the table 2 I have 5 rows. So in SQL you have concept join, where you can join multiple tables using the join keyword. Let us join both of these tables. Select start from the table 1, join, select, join the table 2 on, let's say as A. This is nothing but the array's name. You can specify without the as, and we can put a.id equal to b.id. This is the normal way where we can perform our join. So I have specified a inner join, so it has filtered only which IDs are equal in the destination table. It has filtered out those records. So if I use outer join, let's see, pull outer join. So now you can see we got all the matching and non-matching rows from both of this table. So both the tables has been combined. I can fetch any of the desired result. So now I need all the members from the A table, that is the table 1. I can specify a.name only. So this will filter only which are available names in the table 1 for this join condition. So we got null values because, let's replace this with star. You can see we have provided as full outer join. Basically full outer join will gets all the rows, all the matching and non-matching rows from both of the table, which let's try using the union function. Let me provide the union all to combine both of this table. You can see I have 4 rows with ID 1, 2, 3 and 1 in my table 1 and 1, 2, 3, 4, 5 IDs in my table 2. When I execute this union all statement, you can see I have got totally 9 rows. That you can see clearly the first 4 rows are from my table 1 and the rest of the 5 rows from the table 2 has got appended with my table 1. So we have got a consolidated table which has both the table 1 rows and also the table 2 rows. So you need to specify the equal number of rows when you have used the union all function. To use union or union all function, the 2 tables must have the same number of rows. So let's say for example I need to select the ID and name from the table 1. I need to provide all the rows into table 2. This will shows the error that all queries combined using union, intersect or except operators must have an equal number of expressions in their targeted items. So if I need to get only the ID and name, then the destination table should have the ID and name alone. So now I have got the ID and name alone by using our union all. So what if I need the age and ID in the table 1 and the ID and name in the table 2. So now I got an expression error like conversion failed when converting the varchar value to data type int. Actually you can select and see this value. Here I got the ID and age column, which is both an integer value. While executing this, I got integer and name, ID and name, which is an integer and a character column. So the data type of the selecting column must need to be same while you are using union or union all. So if I give email address instead of age in this select list, obviously email address is a varchar. So now the query got executed successfully, and you can see in the first 4 rows, which is from the table 1, I got the ID and email, but at the next 5 rows, which is from table 2, I got the ID and the name. So you need to specify the equal number of selections in your source and destination table while you are using a union or union all, and the both order or the data type need to be similar while you are using the union or union all function. So we have seen what is the requirement for this selection. So now what is the difference between the union all and the union function? Now you can see I got 9 rows, which is the 4 rows from the table 1 and the 5 rows from the table 2. Here you can see clearly I have the second member who has id 2, name Anand, age 20 and a@gmail.com. In the 6th row in the table 2 you can see id is 2, Anand 20, a@gmail.com. So this both rows are similar in table 1 and table 2. So while I am using union command to execute these tables, we will get only one rows, that is an identical row. So the main difference between the union and union all is that you will filter all the duplicate values when you are using union, and the result set will be sorted out automatically when you are using an union function. If you are using an union all function, the result set will be in particular order, that is if after completing your table 1, the rest of the table 2 will be appended in the query. But when you are using the union function, the result set will contain only the unique values. Also it will be ordered into ascending order. So in your union all command you can also specify order by value explicitly to order your result set, but in the union statement it will automatically filter out the duplicate values and also order the result set. So while comparing the union and union all, the union has benefits as it will filter out the duplicate and also order the result set in ascending order, but it is very slow while comparing to union all. Absolutely, as it is filtering out the rows and also ordering the values, it is very slower than the union all statement. What is SQL joins? What is the difference between the inner join and full outer join? In SQL, joins are used to combine rows from 2 or more tables based on related columns between them. There are different types of joins like inner join, left out, outer, right outer, and full outer join. So what is an inner join? An inner join selects records that having matching values in both the tables. It retrieves only the rows where there is a match between the columns in the tables that are being joined. So in this example, there is a student table and there is a course table. In the student table, we have student ID and student name. In the course table, we have a course ID, course name, and the respective students who are assigned to the courses. So when we apply inner join to both the tables, the student ID in the student table will join with the student ID in the course table, and we will get the consolidated value as a result set. So this table contains only the students who are assigned to a course. So an outer join retrieves all rows from one table and the matching rows from the other table. If there is no match, the result set will contains null values for the columns from the table with no match rows. So you can see in this example, I have a user table and an order table. The user table contains the user ID, username, and their email, password, and the created date. So the order ID contains the order table contains the order ID, the respective user ID, and the order date. So while applying full outer join to both these tables, I got a consolidated result set which displays all the users who are ordered and who are not ordered. The users who are ordered are displayed with the order ID and the order date. The users who haven't ordered any item are displayed as null. So let us see some examples in SSMS how to use these joins in our query. So here I have connected to my SSMS under my sample DB. Let's create this student DB before we can use the sample DB. Let's execute this. Let me connect the database. So now let's create this table and insert some rows inside the student table and create this course table, and let's insert the statements. So let me query the student table. So you can see I have 5 students, and let's copy this. Courses, let's select this. Totally we have 6 courses and the student ID. So now I need a result set which displays each student with their respective courses name. So we can achieve this by using the join. We can provide the first table. Let us take this as A, and we can use inner join to the table courses, and let's take it as B on which column. So I need to join the student ID column from the student table and the course table. Now let's select and see this. So now both the tables has been combined and the result set contains the student ID and their respective courses. You can select any of the columns from both of these tables. So for example, I just need the student name and their respective course name. So this result will give me what are the students have, what are the courses. So the student with student ID 5 has no courses, so it is not displayed in the table because we have used inner join. We can also simply use the join, which will perform as an inner join. So for outer join, let me take this user table. Let's select and view this records. So I have 7 users, their username, email ID, password, and the created date. And let me select the order table. In this table, you can see the order ID and user ID with the order date. So now I need all the users, all the user details who all placed the order in the orders table, and also the users who haven't placed any orders. So let's use the outer join for this. Let me provide the user table and take it as A, full outer join, and let me provide the orders table, name it as B on. You need to provide the condition. I need to join based on the user ID, a.user ID equal to b.user ID. So now while executing this, I got result with the consolidated result set of both these tables. So now from this query, I just need to display the username, their email address, and their order ID. If their order ID is null, I need to display as no orders. No orders. So now let's try to execute this. So I forgot a parenthesis. Now while executing this, I got a result that the users who have ordered, which are displayed in this column. If there is no order placed by the user, it is displayed as no orders. Let us name it as orders or order ID. So we can use full outer join to display all the records. Even if there is a null value in the A table and B table, all the records will be listed down, and we can use the inner join only if we need only the matching values from both of the tables. What is left join and what is a right join in SQL Server? So a left join is also known as left outer join. Is a type of join operator in SQL that retrieves data from two tables based on related columns between them. This type of join returns all the rows from the left table and the matching row from the right table. So if there is any null values in the right table, it will be included as null in the result set. So what is a right join? In SQL, right join is also known as right outer join. Similar to the left join, this will returns all the rows from the right table and the matching row from the left table. If there is no matching rows in the left table, it will be returned as the null value. So let's say for an example. Here I have an employee table and a department table. The employee table contains employee ID and employee name and employee department ID. In the department table, I have a department ID and department name. So when I perform left join, it has filtered all the employee names and their department names. So Emma has no department in the department table, so it is shown as null value. So in right join, I have a student table and a grade table. In the student table, I have student ID, student name, age, and their grade ID. In the grade table, I have grade ID and the grade. So when I perform right join on this both table, I got a result set with the matching rows from both the table, and the grade ID is the foreign key column. So the column has been excluded from the result set. Let's see some live examples to clearly understand what is a right join and a left join. So let's get into SSMS and see some queries. So I have connected inside my SSMS. Now we are under the training database. Let's create this employee table. Let me insert this records into the employee table. So 5 rows are affected. Let's create this department table and insert these values. Let's select and see both the tables. Select start from the employees. So in the employees table, I have 5 employees, the employee ID, name, and the department ID. And let's select the departments. So in the department tables, I have 3 departments, namely engineering, marketing, and HR. So now let's perform the left join in both these tables. So let me put select start from employees, left join on the departments table, take it as D, and after the on, you have to provide the condition on which column you are performing the join. Say I need to map with the department ID. So when I execute this statement, I got a result that both the tables has been combined, and the employee with ID number 4 has no department, so the values are returned as null. If it is an inner join, then this row has been excluded in the select statement. So left join performs if there is a common records in both the tables, it will be returned, and all the values present in the left table are be returned. So let's create this students table and let's insert these values and create the grade table and insert these values. So now let's select and view these tables. Select start from students table. So here you can see 4 students, their ID, name, age and their grade ID, and let's select the table grades. We have grade ID and the grade. So let's perform right join on this both tables. Take it as yes and let us give right join. You can also provide as right outer join. Anything is fine, and both returns the same result. Let's provide the grades table, and you need to map the ID which you are going to perform the join on s dot grade ID equal to g dot grade ID. So now let's select this. So now you can see that I have a grade D in the grades table. So there is no students with a grade ID 4. So the student ID, name and age are listed as null values. So basically the right join will works if there is a common value in both the tables, it will be returned, and if there is no matching rows in the left table, it will be returned as null, and all the values in the right table has been returned in the result set. So you can provide left join to return all the values in the left side and the matching rows from the right table. If we want to use right join, you can retrieve all the rows from the right table and the common rows from the left table. Cross join. And what is a self join in SQL Server? A cross join is also known as a Cartesian join that returns the Cartesian product of two set of rows from the joining tables. It is similar like combining each rows from the first and the second table. So you can get a consolidated result set from the both tables. And while you look into the self join, it is a join which uses the same table to join itself. It is very useful when you want to combine the rows from the same table based on the related data. So you can see in this example, I have a team name and a match table. So in the team table, I have a team ID and team names. And in the match table, I have a match ID and the team 1, team 2, and the team 1 score and team 2 score, and who is the winner ID. So when I use the cross join to both this table, I get the consolidated Cartesian result of both this table. Typically, I have 4 rows in the teams table and 4 rows from the match table. In the result set, I got 16 rows, which is the product of each rows. That the first row in the table 1 has been matched with all the rows in the table 2 and so on. So when you see the self join, I have a table, only one table, that I have a employee ID, the employee name and the respective manager ID. So here the employee who is also a manager, I need to display the manager names. So we can use self join, which is used to join the employee table itself and find the managers. So let us see some live examples and query our tables and let us know how cross join and self join are used in SQL Server. So here I have connected to my SQL Server. Under my training DB, I have my table creation and insertion script already. So let's first create this teams table. So I have created the teams table which has a primary ID column, and let's create this matches table which have reference to the teams table. So now I have got 2 tables. Let's insert this records into the teams table, and let's insert this records into the match table. So now you can see let's query the teams table and the match table. So in this you can see there is a match team ID and the team name in the teams table, and when you see this match table, you have the match ID and the team 1 ID, team 2 ID, and the team 1 score, team 2 score, and the winning team ID. So this column shows which team won the game. So now I need to show the result only the winning teams and their count how much they had won the match. So let's select the records from the cricket teams table, and you can use cross join on match details table. So the main difference between this cross join and all other joins is that you does not need to provide any on condition to perform this cross join. So as it is performing based on entire row in the first table to the entire row to the second table, you don't need to provide any on conditions. It will map automatically to all the rows from the first table and the second table. So now while I executing this statement, I got 16 rows. So this is a consolidated data set. So I need the team that has 1 matches and their count of winnings. So we can perform this. Let's take this as a C. Let's name this as M. So we can use this with the alias name. I need to provide a where condition where I can give like C dot team ID to the match table winner team ID. So I need the winning count of each team. So I provided a where condition based on the team ID from the teams table and winner ID from the winning match details table. So I need the team ID from the team table and the team name from the team table. Also the count of the winning matches. So let's provide match ID. M dot match ID. Provide that. And as we have provided an aggregation function in the select statement, we need to group the values. So I am going to group the value based on the team ID and team name. So let me copy this and paste it here. And I just need to order the result set by the number of wins. So let's take this counts as wins. So I need to order this by wins descending. So this will result highest winning team to the lowest. So you can see the team ID 3, that is the team C, has won 2 matches, and the team D has won 1 match, and team A win 1 match. So you can use cross join in this manner to get the desired results. So basically there is no need for providing any on condition for performing the cross join, and you can get the Cartesian result of the both tables which you have provided in the cross join. So let's talk about what is self join in SQL Server. For this I am going to create an employee table. Let's create this table and we just insert 5 records into this employee table. So I need to display the employee name along with their manager name. So here let's select and see this table. Select start from employees. You can see I have employee ID, name and the manager ID. So and manager is also an employee, but they are assigned to the employees. In this table, the employee with ID 3 is a manager for 1, 2 and 4, and the employee with ID 4 is a manager for the employee 5. So how we can achieve this? Let's copy the select statement. Let's put it here. Let me name it as E, and let me provide the set join to the employee table. Again the same employee table, let me give it as M. I need to provide the join condition. I need to provide the join condition on the E dot, I'm going to map the manager ID to the M dot employee ID. So this will gives me the manager names. So let me provide E dot name. Let me take this as employee name and M dot name as the manager name. So let's copy this. While executing this, I got the result. John, Alice, David has manager Emily, and Emma has a manager David. So Emily is the manager for David and David is the manager for Emma. So you can perform self join to join the same table itself again to perform these operations. And what is union command in SQL Server? Union is a command in SQL Server which can be used to combine the results of 2 or more select statements of your query. So you can use multiple queries to join the tables using union command. You need to aware that each selected items in the queries need to be constant, and all the selected columns need to be in the same data type. And while merge in SQL Server is a command which is used to perform inserting, updating and deleting operations to the target table based on some conditions in your source table. Merge is also similar to the union function, but you will use union in your select statements, whereas you can use merge to insert and update, delete your records in your table. So here I have an employee table and a consultant table. In the employee table I have employee ID, name, age and their departments. in the consultant table I have a employee ID, name, age in their department. So I need to merge these queries. I need, if there is a employee present in that table, if any of the column has been changed, I need to update that. If none of the query has been found in the source table, I need to insert, and I need to delete all the remaining rows. So I can perform these operations using the merge query. So you can see I have provided the result set where you can find that the employee with ID 2 whose age has been updated as 29, and the employee ID 4 is not present in the source table, which has been inserted into the source table, and the rest of 1 and 3 employees has been deleted. And for union, I have two tables. I have just applied union to merge these two tables into a single table in my select command. Let's see some live examples in SQL Server to understand union and merge in SSMS. So here I have connected to my SSMS. Here under the training database, let's create this employee table. So the table has been created. Also create this new employees table. So now we have two tables. Let's insert the records. 3 rows got affected, and insert these two rows got affected. So now let me select the employee table. So you can see in this employee table I have employee ID and their name, their age, and the department. So let me select the new employee table. In this new employee table I have additional 2 employees, so I need to merge these records into my employee table. If the employee ID present in the source table, that is the employee table, I need to update if there is any changes. If there is the employee ID not present in the source table, I need to insert this. If there is any other rows in the source table present, I need to delete that. So we can use the merge command here. Let me use select star from employees, and let's name it as E, and okay, let me provide it here. We need to provide merge into the source table, which we are going to insert the values as E, using by which table we need to provide, that is the new employee table. Let's rename it as N. So we need to provide the condition on which column you need to perform this. We perform this based on employee ID, e.employee ID to n.employee ID. So after this I can use when matched, then I need to update this. So let me provide the update command. Update set e.name equal to n.name, and the age column e.age equal to n.age. Also the department too, e.department, I need to assign the n.department, and when it is not matched by the target table, then I need to insert the values. To specify target which is not matching to the target, then I need to insert the values. So let me provide insert into this employee table with values of tables of the new employees. Let me provide the entire employees, n.name, n.age, and also n.department. So after this, the last condition, that when not matched by the source, then I need to delete this. And you need to remember that the merge command should be terminated with a semicolon. If you didn't provide semicolon, it shows an error like a merge statement must be terminated by a semicolon. So let's provide semicolon at the end of this query. So now let's execute this query. 4 rows got affected. So now let's select this employee table. You can see there is only 2 rows. So what actually happening in this query is that you can see I have provided the merge command for the employees table from the new employees based on the employee ID. when the employee ID is matched, I need to update the name, age and department from the new employee table. When it is not matched in the target which is the employees table, then I need to insert the ID, name, age, department from the new employee table. When it is not matched in the source, so if there is the record not present in new employees, then I need to delete this. So let us see an example for union. Before creating this, I already have created employee table over here. Let's drop this. Now let's create this employee table. Let's create this consultant table. Insert these records into the employees table and also these records to the consultant table. So now let's select both the tables. Next, start from the employees. You can see the employee ID, name, age and their department. So let me copy this, paste it here, and now let's select this consultants table. This too has the ID, name, age and their specialization. Now I need to join both these tables. So let me provide, I need to join the name, age and the department from the employees table, and the name, age and specialization from the consultant table. I need to provide union. So now both the table has been joined and I have got the result set. The 3 rows comes from the employees table and the rest of 2 rows comes from the consultant table. So if you need a specialization as your column name, you can also provide the array's name as consult specialization. Now when you execute this, you can see the specialization as the column name. So if you don't understand what is the difference between union and union all, I have provided a separate video in the SQL Server playlist. Let me provide that in the description, where you can understand what is the difference between the union and what is lag function in SQL Server. Lead is a Windows function in SQL Server that allows you to access the data from the next row within the same result set. It is often used to retrieve the value of your column from the next row related to the current row based on certain ordering conditions. For an example, if you have a table with a relationship with a column which can be identified in subsequent rows, you can access the next row value for your current row based on the ordering. Just like lead function, there is lag function, which is also a Windows function in SQL Server. You can access the previous row based on certain conditions in your current row through particular orderings that you have specified. So you can get the previous or next row by using this window function. Let us see some real-time examples so you can understand better. Let us get into the SSMS. So here I have got into SSMS. I have connected under my training database. Let me quickly create a table. Let's name it as car data. Let me provide an ID column and the car name, which is a varchar, and the time run. So we can take this as date time. Sorry, I have provided as data time. Okay, and finally the petrol, which we can provide as decimal 10 and 2. So let me create this table. Let us get some insert queries and provide the table name, values of the ID and the car name. Let's take as BMW. Okay, and the runtime you need to provide the date time. So you can provide 2024 03 and 18. Let's say it is 8, and we can provide the letters. So let's copy this and paste this. We provide 6 rows, 2, 3, 4, 5 and 6 rows. So now let's just change the time. You can keep this as 8:30 and then 9 o'clock and now 9:30, 10 and finally 10:30. Let us change the petrol value. If we provide us 51.20 52.80, 52.50, and then 53.75, and finally 53, and let's give us 20. Okay, now let's insert these values. So 6 row got affected. Let's select this table, provide the table name which is called data. So you can see I have an ID column, the name of the car, and the runtime along with the petrol respectively. So now I need to write a query which finds at which time I have run the car and at which time I have provided the petrol. So I need to identify if the row is greater than the petrol value in the current row. I need to identify that as I have filled the petrol. So now we can achieve this by using the lag function. Let's copy this code and paste it here. So from this I need the ID column, the car column, and the time run, also the petrol value. So from here I am going to specify a subquery in which I am going to select these values from the car data. So we can use the lag function over here. Lag and lead function will accept 1 to 3 arguments. So now I need to calculate the petrol. So let me pause this, and you need to provide the over class and provide the order by command based on which column you need to order the value. So I need to order the value based on the time column, and I need to provide the petrol value. So take this as filling. So the next parameter in this lag function is that you can specify which number you need to skip. So I have provided as 1. So it will take the previous value, I mean the one row previous to the current row. If I provide as 2, it will skip one row and take the second previous row for the current row. We can also provide another argument which is the replacement value. If the value is null, I can replace the value with 0. So I have provided as 0. So now just select the inner query statement. You can see the petrol and the fillings. So as we have started with 50, there is no fillings. After that we had filled, so it has fetched the previous value in the filling. So we can now easily compare this value if it has increased or decreased. So you can provide the where class over here, where we provide the filling value where the filling is greater than the petrol value. Provide with an alias name. Let's take it as petrol data. So now let's select this. So I have a provider less than. So now you can see that at first there is 50 liters, so it has been displayed, and it has been increased, so I have filled the petrol, and then I have filled at 9 PM and again at the 10 PM. So you can use the lag function to get the previous row value based on a conditional column. So you can also use the lead function to get the next value of the row. Let's see another example where we can use the lead function. So let me create another table. Name it as sales. Let me provide 2 values, sales date this is a date column, and a revenue column as a decimal value. So it's an app. We can just create the sales table and let us insert few rows inside this table. Insert to the sales table values. We provide the date 2024, 3rd month, and let me provide the sales revenue. And let me copy this and paste it here. So we can change the date and also the revenue 1200, 1500 and 1300. provide 1400. So let's insert these values. Now let's select and see the sales table. You can see the sales date and the revenue for respective date. I need another column along with this revenue, the next day revenue, so I can easily compare the previous day and current day value as the next day revenue. So you can use lead function to take the next row value along with this current row. Let me copy this select statement, paste it here, and in here I need the sales date and the revenue. Sales, revenue, and then I can provide the lead function, lead of the revenue column, and I need to provide over class just like we did in the lag function over the sales date. So I can provide as over ordered by the sales date from this sales table. I forgot the comma. So now let's execute this. Okay, I have listed the sales. Yes. So now let's select this. We got another column. The next value of the revenue has been displayed along with this column. So you can also provide how many rows you need to fetch and also the replacing value. So I have provided 0 instead of null. So we have a null in the 5th row. So let's replace that with 0. So now you can see we have replaced the null value with the 0 and you have renamed the column as next revenue. So if you need to see the difference, you can also just specify the lead of revenue, the same thing over here, and subtract this the revenue column and keep it as difference. So let me provide a comma here. So now select this value. You can see the difference along with the next day revenue in this table. So you can use this lead and lag function to fetch the previous or next row in your table based on subqueries in SQL Server. So a subquery in TSQL is a query nested within another query. So for an example, if you have a query, you need to retrieve data from another query, you can use subqueries to perform such operations. And if your query requires multiple steps, then you can use subqueries to perform the multiple steps operations. You can use subqueries in your select, insert, update, or even a delete statement. So let us see some live examples how we can use this subquery in our tables. Let us get it into a SSMS and walk through some queries. So I have connected inside my SSMS. I am under my training database. So I have the customer table creation script and the orders table creation script. So let's first create both the tables. So I have created the customer table, also the orders table. So now I'm going to insert 7 rows inside my customer table. So 7 rows got affected and 15 rows inside my orders table. So it's around 14. Okay, now let's select and view the records in both this table. Select start from customers. So you can see in the customer table I have a customer ID and the customer name along with their email address. And again we can use this select statement to see the orders table. Let me select the orders table. So in the orders table I have order ID, customer ID, order date, and the total amount for the particular order. So you can see here clearly that the customer ID in the customer table is a primary key and it is referred as a foreign key for the customer ID in order table. So you have also the customer ID as a primary key in the orders table. So there is a reference between the customer table and orders table with the customer ID column. You can also use joins. Instead of joins, there is also subqueries available in TSQL to perform those logics. So let us see for an example. I need to retrieve all the names of the customer who have placed orders totally more than $200. So here there are a total amount for particular order. So based on this customer ID, I need to fetch the customer name who have placed orders greater than $200. So how we can achieve this? We can also achieve this using the joins. So let's see how we can do this using subquery. Select start from the customer name. So select, I need the name of the customers. So I'm going to select the names from the customer. I need to provide the where condition where the customer ID where the customer ID, I can provide the in, and the subquery is usually written inside the circular brackets. Here I can perform another select statement, select start from the orders table. So I need to calculate the order. So let me group by the customer ID, so I can get the sum of the amount for each customer orders. And let me provide the having command and filter the sum of the total amount, the column total amount from the orders table. Sum of the total amount is greater than $200, so let me provide 200. So I need to select the customer ID from this. So now this select query, inside this subquery, let's execute this. This got all the customer ID who has placed orders greater than $200. So I need the customer name, so I have provided the where condition. What all of the customer ID matches with this customer ID, I will get the name of those customers. So I have 7 customers totally in my table. So out of them, 6 customers have placed orders greater than $200. So we can use multiple subqueries to find these logics in SQL Server. Also we can use subqueries in the update and delete commands too. So let us see another example. Like I just know the name of the customer, I don't know what is the ID of the customer. So let's say, for example, out of these customers, I know the name of the Jane Smith. So I need to update the email ID of Jane Smith as janesmith@example.org. Then how can I achieve this? Usually we will update the email ID based on the unique column. In this customer table, the unique column is the customer ID. So I don't know what is the customer ID for Jane Smith. So how can I do this? Let me provide the update statement. Update customers, set the email ID. Set the email is Jane Smith at example.org. So then I can provide the where condition, where usually we will provide the customer ID and we will supply the value for the customer ID, but I don't know what is the customer ID for the Jane Smith. So let me find this using the subquery. In this subquery, I am going to use the select statement. I am going to select the customer ID from the customer table, where I am going to specify the name of the customer is Jane Smith. So I need to retrieve the customer ID for this customer name. So you can select this inner query, you will get the customer ID of Jane Smith is 2. So when I pass this value to my outer query, it will automatically update the statement. So one row got affected. So without knowing what is the customer ID, with the help of a customer name, I have updated the customer email address. So now let's select and view the customers table. You can use the select start from customers, and now you can see that the customer ID has been updated to email.example.org. So we can use the delete statement. Also we can use subqueries in delete statements. So let's take an example. I need to delete all the orders which are placed by the email with the email address ends with example.org. So if there is so many members with example.org, then how can I perform this? Let me provide the delete statement here. Delete from, I need to delete from the orders table, delete from orders. We provide the where condition, where the customer ID need to be in. Let me provide the subquery inside here to retrieve all the customer ID who has email ID ends with example.org. So let me copy this. So I need to include the select statement here. I need to select the customer ID from the customers table, customers, where their email address is like, and we provide the wildcard path with anything before this email example.org. I need to fetch those customers. Now let's select and see this inner query. So Jane Smith, who is the only person with email example.org. So let me fetch the customer ID out of this and pass this to the outer query. So while I execute this, 3 rows got affected. So Jane Smith placed 3 orders in the orders table. So we can use subqueries in this manner to perform our operations. You can also even use subqueries to insert your values based on certain condition retrieved from some inner queries. So it is most likely using a join condition, but you can use complex logics in SQL subqueries than joins. So comparing the joins regarding the performance, if the data set is very small, then there is no difference in the performance between joins and the subqueries. If the query set is large one with a million and billion records, then definitely joins will be very much useful and helpful with the highest query performance for you. And the SQL joins will work perfectly with the indexings, so it will locate the rows very quickly, and the performance of the query will be so strong than the SQL subqueries. So when comparing with the complexities, so it will be easier to write subqueries in some situations where you can find joins to make the query complex. So in such cases you can use subqueries, but most likely you will tend to use the join conditions, which will give you better performance along with your indexings. What is CTE in SQL Server and how to use the CTE in your queries? So CTE is also known as common table expression. You can enclose your table structure, you can join multiple tables and form a table structure. That is a common table expression. So you don't need to create any temporary tables. Without creating any temporary tables, you can store this structure as a table with the help of CTE, and you can access this format, that is the joined query table, in n number of your queries. So let us see the detailed view of common table expression in SQL Server. Let us get into the SSMS and see some live examples. So I have connected inside my SSMS. So I have the queries. So let's create this employee table. The employees table has been created, and let's create this departments table. So now I have employees and departments table. Let's go ahead and insert some rows. 14 rows got affected, and for the departments table, execute this. 5 rows got affected. Let's select the tables. Select the employees table, and also let's copy this, and let's select the departments table. So you can see in my employees table I have an employee ID, employee name, and their respective department ID. In the department table I have department ID and department name. So now I need to select all the department ID and along with the department name, and who are the employee names in the department separated with a comma delimiter. So how can we achieve this? We can get all the employees from the employees table. We can use the join. We can provide inner join with the departments table. Let us take this as alias name E and departments as D. We provide the join condition E.department ID equal to D.department ID. So now you can see we got all the employee IDs, employee name, department ID, and the department names. So now I need to group all the departments and show the department ID, department name, and I need to display the employee names. If there is 2 or more employees in same department, then I need to show those employees with a comma delimiter. So we can first group the value by the department ID. So let me provide D.department ID in the statement, and also I need to group the value based on the department name. So I need to display the department name as well. So D.department ID and D.department name. Along with this, I need to show E.employee names, all the employees' name. So we can use string aggregation function to separate the employee names with a comma delimiter. So in this second argument, we can pass through which delimiter you need to separate the values. I need to provide a comma. So I have provided this as a second argument. Let us name this as employee names. Employee name. So let me now select this. You can see I got this cell set which displays the department ID and the department name along with the employees who are in the department separated with comma. So we can enclose this inside a CTE. So we can use this table structure in anywhere in our session. So how we can use CTE? We can achieve this. We need to provide the width. I need to provide the CTE name. So let's say for example employee department details. So this is the name of the CTE, and you need to provide the as command. So you need to enclose all this inside a circle bracket. So now this is our CTE. The employee department details is our CTE. You can just select the values. You can use the CTE name as a table in your select statement to get this CTE anywhere in your session. So you can only use select statement along with your CTE. You cannot use insert, update, or delete in a CTE. Also you can access the CTE in your select statement alone. you cannot use CTE to access your insert, upsert or delete commands. Let us see one more example to clearly understand the CTE. So here I have an employee table. So in this table I have employee ID, first name, last name, and the title, department ID, and the manager ID. So let us quickly create this table. Also let's insert these values, 9 rows, got a vector. So now I need to select the values from my employees table. So now you can see in this table I have employee ID, their first name, last name, their title, which is their designation, and the department ID, manager ID. So which department they are belonging to and who is their manager. So in this example I need to display the employees along with their designation, and I need the hierarchy level. So the highest hierarchy level goes with the CEO, and I need to display the managers and so on. So how can we achieve this? And after getting this, we need to enclose this in CTE, and how we can use the CTE in our query. So first let me select star from this employee table. Out of this I need the manager ID, I need the employee ID along with the title, and let me provide number 1 as employee level. Let me enclose this inside square bracket. Okay, so let me now select this. You can see all the employee level is assigned as 1. So how we can separate this? I need to provide a var class where I can get the manager ID is null. Let's select this. We got only one row, which is the CEO, the highest level of the hierarchy. So we have find the highest level in the hierarchy. Along with this, I need rest of all the employees. So let me provide the select statement again to find the rest of the employees. Select star from the same employee table. Let me take this as E. So I'm going to join this with a CTE. So let me enclose all these queries inside a CTE. Let me provide this as a direct report. Direct reports, and let me provide this as, so in this direct reports I need the manager ID, employee ID, the title, and the employee level. So this is what I need. So let me form a table format with this, which is actually a CTE. Let me close this and can open the circle bracket again, and in this we are going to union all the records from the select query and this select query. So let me provide the direct reporters table here, and let me take this as D. So I need to join both this table. So let me provide the E dot manager ID equal to D dot manager ID, so employee ID. So in this I have provided I need to join the manager ID with the employee ID, so I can easily fetch the hierarchy level. So in this statement I just need to provide the same query in the direct reporters. So I need this, and in the hierarchy level I just need to add +1. So it will increment the hierarchy level 1 by 1 for each subsequent runs. So I need to specify from which table I am going to fetch these details. So I need from the employees table. So let me provide the alias name first along with the table. So this is going to be my CTE. Let's just first select this, and finally I am going to return the values of my table, which is a common table expression, and I need to order the values based on the hierarchy. So I'm going to order by the manager ID. So I need these inside my select statement. So now let me select this query. So now you can see I got a result with the employee ID, their title, along with the employee level. So here we got CEO as the first hierarchy, who has the employee ID 1, and for the vice president the CEO is the manager, so I have displayed the manager ID as 1 and the vice president is in the second hierarchy level, and the vice president is the top level person for 3 of managers, and so on. I have provided the hierarchy levels. So let us also order the value based on the employee level, so we can easily understand how the hierarchy level works. Ordered by the employee level. Let me execute this. So it's now clearly you have understand how the hierarchy level goes down. So you can use CTE for all these operations in your queries, and you need to remember that a CTE can only be specified in your select statement, and the CTE can only be accessed after the select statement. So after this CTE expression, you can only provide a select query. If I try to provide any update or delete command after this CTE, it throws me an error. So I can only use select statements after the CTE, and if your CTE is used in any of your queries, you need to provide a semicolon at the end of your queries. So you need to provide only the CTE in the first statement, or you need to provide a delimiter. After then you need to specify the command and declare your CTEs. So if you need to specify any queries before the CTE, you need to end up with a semicolon. And regarding the performance of CTE, you can both the CTE subqueries and joins works as same, but there are few limitations and some benefits by using CTEs, where subqueries are really slow and compared to joins. Than using multiple joins in your conditions, you can just declare a table specification in your CTE and use it in multiple statements of your query. So it will allow you to reuse the command without providing the command again and again in your queries. When comparing with the performance speed, the CTE is much better than the subquery. The query execution can easily identify a CTE, and the performance of your query is comparatively higher regarding the subqueries and CTE. So you can use just to specify your table statements inside a named package and select it n number of queries in your session. What is conditional statements in SQL Server? So conditional statement can be used in SQL Server to control the flow of your statement based on certain conditions. You can specify any conditions and you can evaluate the queries based on those conditions. There are basically 3 conditional statements available in SQL Server. They are the case statement, if else statement, and the if statement. The if else statement can be used to evaluate your query based on conditions. If the condition becomes true, the block of the code inside the if statement will be executed. If it fails, then the else part will be executed. And the case statement in SQL Server, it is a conditional logic statement where a list of conditions will be evaluated, and one or more resulting queries can be returned as a output. And the if statement in SQL Server is also named as a single line conditional statement in SQL Server, where you can provide the condition, the true statement and the false statement in a single line query, and you can obtain the result based on your condition satisfied. So let us see some of the live examples in SQL queries. So let's get into SSMS and see some live examples. So here I have connected inside my SSMS. I am under my training DB. So I have the table creation script and the insert statement. So let's create this employees table. So let me insert these statements. So we can now select and view the records in this employees table. You can see in the employees table, I got the employee ID, employee name, their department ID, and their salary. So I need to assign the department name based on this department ID. So we can use conditional statement to achieve this. So let me copy this and paste it here. In this, I am going to take this as E, and let's select E dot the department, the employee ID, and E dot employee name, also E dot department ID, and here I need to display the department name. So I can use the case conditional statement here, and let me provide when. The case statement will always follow with the when command, and you need to provide the condition. Let me provide department ID equal to 1. Then I need to display this as development. and then the department ID is 2. Then I need to display this as marketing. I forgot the comma. And let me copy this. If the department ID is 3, then I need to display this as sales. So here you can also provide the else condition. If none of the above conditions has been satisfied, then you can use this else statement will be executed. So let me provide the when command. So the case statement will follow with the when command, and you need to provide the condition. Then you need to provide the particular value that need to be displayed if the condition satisfies. You can also use the else statement if none of the conditions has been satisfied. The case statement must end with the end command. You can just give alias name as department name. So now let me execute this query. Now you can see I got the employee ID, employee name, department ID, and their respective department name. So we can use case statement in this manner and achieve this. So giving this ID multiple times inside this statement, there is also another option where you can use this department ID in the case statement, case department ID. When the value is 1, then I need to display as development. When the ID is 2, I need to display as marketing. 3, then I need to display as sales. So now when we execute this, we got the same result as the previous one. So you can also use like this without specifying the department ID each time. Let me select the average salary from this employees table. Let me provide this here. So average of the salary let me execute this. So I got the average salary 57,625. So now I need to display the set of employees who are in the average salary rate, which is if the average salary is medium pay or high pay or low pay salary, and based on that condition I need to display the set of employees who are under the category of the average salary. So let me provide the case statement here. Select case of when the average salary is less than 55,000, then I need to display this as low salary, and when the average salary is greater than or equal to 55,000 and also less than 60,000, you can take this as medium salary, and we can provide the else statement. Else I need to display this as high salary. Let me provide the end statement here from the employees table. So now you can select this. We got medium level salary. So the average salary is the medium level salary. So I need to fetch all the employees who are under this medium level salary. To achieve this, let me declare a variable called salary value, and let me take this, declare this variable as a var provide us 10. Let me copy this variable, and I'm going to assign the result of this case statement to this variable. So let me provide a tab so you can understand this easier. So the execution of this statement will be stored in this variable that we have created. So now I'm going to provide the if condition. If the variable has a value low, then I need to provide set of conditions. Let me provide the begin statement. Let me write select and to display the employee name. Let me just provide everything from the employees table so we can get suggestions from the intelligence. So I need the employee name, his salary, from the employees table, where I need to provide the condition as salary, where the salary is less than 55,000. Let me close this and end this. And we can also use else if command and check whether the variable is a medium. So if the value of the variable is medium, then I need to provide another condition where the salary has need to be greater than or equal to 55,000 and the salary need to be less than 60,000. So just like in case statements, we can also provide else statement for this if condition. Else I need to provide a else condition. So let me copy this again and paste it here. Else I need to provide the employees who has the salary greater than or equal to 60,000. So now let me execute this complete query. I got 3 employees who is in the range of average salary. So I got 3 employees who is in the range of 55,000 to 60,000, which is equivalent to the average salary. So this is just an example which explains you how we can use if, else, else if and else command in SQL Server. So let us see an example for the if command. Let me provide the select statement. Select start from the employees table. So here I need another column named as salary range, and if the salary is greater than 55,000, I need to show as high, else I need to show display as low. So you can give the if condition for this. I need to check the salary. If the salary is greater than 55,000, then I need to display this as high, else I need to provide as low. So in this if condition, you can provide your logic in a single line query. So I have provided the condition as the first parameter and the true statement as the second parameter and the false statement as the final parameter. So now before executing, let us provide a valid name as salary range. So now let's select and see this. So I got the employee ID, employee name, department ID, salary and their salary range. If it is less than 55,000, then it is displayed as low, and if it is greater than 55,000, then it is displayed as high. So we can use the conditional statements in SQL Server for these conditional flows, and you can execute your set of queries based on the conditions that you have provided in those. And what is rank function in SQL Server? So rank and row numbers are used to order your values and assign numbers within your result sets. So rank function assigns a unique value for each row in your result set based on the specific ordering that you have provided. The rows with the same value receives same rank number, and the next rank number will be skipped. So if two rows has the same values, same rank will be applied for those rows, and the next row will be skipped in rank function. Whereas in row number, it assigns a number for every unique rows in your result set based on the ordering criteria that you have specified, and it does not skip any row. It just intuitively assigns number for your result set based on the ordering condition that you have provided. So let us understand deeply through live examples inside SSMS. Here I have connected to my SSMS. I am currently under my training database. So now let me create a table. Create table, student table. So let me provide an ID column which is integer and it's a primary key. Let me also provide identity for this column, identity of 1,1, and then let me provide a name column which is a varchar, and finally a score which is an integer. So now let me create this table. The table got created. Let us insert few rows inside this table. Insert into, provide the table name, and we need to update the name and the score. So let's provide those columns in the selecting value and provide the values for that. So first I need to provide the name and the score. So let me insert few rows. So let us give some other names. Bob and 85, Charlie 95, and David, let's give us 85 again, and Eve has 92, Frank has 88. So now let's insert these values inside the table. So 6 rows got affected. Let me select this table, select star from the students table. Now let's select this. You can see we got the ID column and the student's name along with their score. So let us see how the rank and row number function applies on this table. Let me provide the select statement. I need to select the name and then score from the students table. So now you can see I got the name along with their scores. So now I need to arrange the scores descending, so I can get the highest score to the lowest score, and I need to assign rank for those students. So here I can provide the rank function to achieve this. So let me provide the rank function. The rank function should be followed with the over class. In the over class you need to provide the order condition. I need to order the score descending, so I can get highest to the lowest score, and let me name this as score rank. So now when I execute this, you can see I got Charlie first rank and I got the rank for each students. So as Bob and David has the same scores, they have assigned as 5 and 5. So let us provide ascending here, so you can see the difference. Here you can see Bob has been assigned as rank 1, David has been assigned as rank 1, and Frank has been assigned as 3. So the first 2 rows has same value in the scores, so they have assigned as 1 for both the rows, and the rank 2 has been skipped and 3 has been assigned to the next student. So in this rank function, if there is the same value in the column that you have provided in the order class, then the same rank value will be applied to that and the next rank will be skipped. So I don't need like this, I just need to rank the students. I just need to arrange the students in an order, and I need to provide a unique number to those students. So we can use row number for that. Let's select this and paste here. So here you can copy paste this, and here you can provide the rank row number. For this row number you need to again follow with the over class, where you need to provide the order condition, ordered by the score descending, and I need to give this as row score. So now let me select this. Now you can see row score has been updated along with the student name and score. There is a unique value for all the rows in the student table. So row number is always helpful for you in several conditions where you don't have any unique values in your table to identify the rows. So you can provide row number for those cases and uniquely identify the row based on your row number. So now let's just say I don't have this ID column in the student table, then I can use this row number to uniquely identify the student. So just like the rank function, the row number does not skip any rows, it just assigns a unique value for each row based on the ordering condition that we have specified. Here we have specified I need to order the score in descending order. If I ask to order it with ascending order, then it will be ascendingly sorted, and each unique row will be assigned for all the rows in your result.
What is dense rank and what is Ntile in SQL Server? Just like in our previous video, we have learned about rank and row number. Just like the rank and row number, dense rank and Ntile are also a ranking function in SQL Server. Dense rank is a window function in SQL Server that assigns a rank to each row within a partition of our result set. Unlike regular ranking function, dense rank does not have any gaps in the ranking. So in our previous video we have learned about rank, where we seen like if 2 rows has the same rank, then same rank value will be assigned for those things, and the next rank will be skipped, and the next rank has been assigned to the next value. But in dense rank, if 2 more rows have the same rank, dense rank will assign the same rank to each of them without skipping the next rank. It will be assigned, and Ntile is also known as bucketize in SQL Server, which is also a window function in SQL Server used to rank your rows in the result set to specified number of buckets. For example, if you specify Ntile of 4 to your result set, the function will divide the result set into 4 groups, each group containing approximately 1/4 of the total rows in your result set. So I hope just remember that the dense rank and Ntile both are a ranking function. The dense rank assigns the rank just like a rank function, but it does not skip any rows if there is same rank for subsequent rows. And in Ntile, you can use this ranking function to bucketize your value based on the specified number that you have specified for this Ntile function. So let us clearly understand these two functions through live examples in our SSMS. So here I am inside my SSMS. So now I have already have a table creation script along with the insert statements. So now just create these two tables. The students table got created. Let me insert these values into the table. Let us select and view this table. Let's start from the students. So you can see there are 15 rows totally got affected into the students table. I have a student ID and their name along with their scores. So now I need to assign rank for the student's score from the descending to from the grade highest score to the lowest score. How we can assign the rank like this? We just like in the rank function. Let me copy this and paste it here. So just like in our previous example, I am going to use the rank function. I need to select the name of the student and their score. I have selected the name, score of the student. Along with this, I need to provide the rank. So let me provide the rank function, and along with that, let me use the over class where I have provided the order statement. I need to order by the score. Order by the score descending. So this will arrange the value from highest score to the lowest score. So let me take this as score value. So now let me select this. Let us see. Now we got 1, 2 and the 3 has been skipped because the 2 and 3 has the same rank. So to avoid this skipping of value, we can use the dense rank function. So let me copy this query and paste it here. So here instead of rank, let me going to use dense rank function. So let us use this dense rank function. Now let me going to select this statement. So you can see that the student, the 2 and 3 ID has been assigned as rank 2 and the 4th student has been assigned as rank 3. So there is no skipping of values in this dense rank function. You can clearly see that the student 6 and 7 got the same rank, and again in the 8th student got the 6th rank. There is no skipping of values. So 3 students got assigned as rank 6 and then 7, 8, 9 as follows. So the rank will assign the rank value if there is a same value for 2 students, same score, then same rank will be assigned and the next rank will be skipped. But in dense rank, there is no skipping of values in the ranking function. Just like in all rank function, you need to provide this over class because all the ranking function are an window function. So let us also see an example for what is Ntile and how we can use this. Let me first create this orders table. So now the table has been created. Let me execute this insert query and let us select this orders table. Select start from the orders table. So now you can see there are 15 rows totally in this table. We have order ID, the customer ID, order date and the total amount for those orders. So now I need to arrange the total amount in a descending order, and I need to rank it. So in this example, I am going to use the the Ntile function. So what exactly Ntile will do? So let me copy this, paste it here. So here I need to take the order ID, customer ID, order date, along with the total amount. Here after this, let me provide the Ntile function. So Ntile, I need to provide the value I am going to entail with. So I need to divide the result set into 3 buckets. So I need to also provide the var over class over the order by condition, order by the total amount. So let me copy this, provide the total amount, descending, so we can get the highest to the lowest. So now let me execute this. You can see there are totally 3 buckets, so there are totally 15 rows. So assigning this to 3 buckets, the first 5 values will be assigned to the first bucket and the next 5 will be assigned to second bucket. So by providing the bucket value, we can assign the result set to particular buckets. So now let me change the bucket value as 4. So now let me execute this. There are 4 rows in the first bucket. So now 4 rows got assigned as a first bucket, and the next will be the second, and the next will be third. There are finally 3 rows left for the fourth bucket. By changing this Ntile value, you can assign how many buckets that you need to divide the result set. So now I have assigned 5 buckets, so 3 values will be assigned for all the buckets. So you can just provide the Ntile function, which is also known as the bucketize value for SQL Server ranking function, where you can take the result set and divide it into buckets. It will be helpful for you to execute the values based on certain.
We are going to learn about what is trigger in SQL Server. So a trigger in SQL Server is a database object that automatically executes a specified set of SQL statements or procedures in response to certain events occurring in your database. So these events can either be an insert, update, delete, or it can also be a alter or drop commands. So trigger can enforce data integrity in your database operations. You can write a trigger in a table level, and you can fire those triggers either before or after certain event happens. So there are 2 types of triggers, namely the before and after trigger. The before trigger is usually performed when certain operations, that can be an insert, update, delete, alter or drop. So the before trigger will be fired before any event occurring in your database, and the after trigger will be executed only after certain operations has been performed on your table that you have provided the trigger option. So let us see some live examples through SSMS and understand more about the triggers. So mainly today we are covering the on insert trigger, which is when an insert happens inside a table, then how we can use triggers to fire certain operations. So let's get into the SSMS and see some examples. So here I have a employees table creation script and a few inserts records. So let's create this table first. So before executing this insert statement, let me create a trigger. How we can use the trigger when we insert this statements, I need to perform certain operations. So let me create a trigger quickly. You can use the create trigger command to create a trigger. So you can name trigger for the insert for the table name employees, and you can provide on which table for the employees table. So I need to handle the trigger operation for this employees table, and only after the event happens. The event is an insert event, so you can provide the trigger as, and you can begin the trigger, and you need to provide what operation you need to do. Let me just print a statement that new row got affected inside the employees table. So we can use the end command to close this trigger. So now let's create this trigger. So now the trigger got created. So first let me try to insert the single record inside the table. So when I execute this, you can see a statement has been printed in my output as new row got affected inside the employees table that I have provided for the trigger statement. So I need to print a new row got affected into the employees table whenever a row got affected inserted into the employees table. So if let me insert another row inside this table. So let me insert this again, so I can get this statement whenever a row got inserted inside the employees table. So I have provided the after insert, so whenever a row inserted into the table, automatically this print message will be printed in the output window. You can also use this trigger to do several operations. So let me quickly create another audit table. So create table, let me name it as audit table. Let me give just provide two columns, namely the value inserted, which is a varchar, and another row which is a time inserted. I can give this as date time. So let me quickly create this table too, and now I have got a audit table. So now whenever a row got inserted to the employees table, then I need to insert a audit log to this audit table. So I need to automate this this operation by creating a trigger. So whenever a row inserted into the employees table, then I need to fire the trigger operation and execute the statements inside the trigger. So let me quickly create another trigger. You can use the create trigger command, create trigger, and you can name it as trigger log value. Again, you need to provide the on condition for the employees table. So whenever a row got inserted into the employees table, then after inserting the value, I need to provide the condition. Let's use the begin command, and inside this I need to provide an insert statement. So I need to insert a row inside my audit table. So let me insert into the audit table and provide the values as, let's just give a custom message, new employee added, and I need to provide the specific date time. So we can use the get data function to get the current date time which the employee got inserted. So if you don't know what all are the built-in functions available in SQL Server, let me provide a video in the description. So check out the video for all the built-in functions available in SQL Server. Let's just first create this trigger. So now the audit trigger got created. Now I am going to insert another row. So let me cut this and paste it here. So let me change the ID. Now I am going to insert a row inside my employees table. So now I executed only one row, but you can see there are two rows got affected, one for the employees table and another row for the audit table. So as the first trigger is still in alive, you can see the print statement that has also been executed. Now let's just quickly select the audit table. So you can see, select star from the audit table. While executing this statement, you can see a new employee got added with the specified date time. So we can use a trigger to take these log functions and automate these logs. So we can also perform certain other operations, like I need to handle the value got inserted into the table through a trigger. So you can automate the records using a trigger function. So I just need to add a trigger that will help me to insert only the department which is an IT or HR or finance. So if we try to insert any other records that are not in the department IT, HR and finance, then I don't need to insert those records. I need to roll back and send a error message to the user. So for this, let me create another trigger. Let's use a create trigger. Give the trigger name as enforce the department value, enforce department. Here you can provide the on for the employees table. So now let me paste it here, and again you need to provide the after condition. After inserting, this trigger need to be fired. So let me provide the as and begin command. Inside this, I need to check if exits of, if there is a value inserted into the table. So you can select the value from the inserted table. So this inserted table will contains all the rows that are recently inserted into any of the tables that you have executed in the session. So here I need to check whether the department is in a specified value. So I need to check if the department is not in this list. So I can provide the list here. So if it is not a IT department, or it is not a HR department, or else it is not in the finance department, then I need to perform the rollback action. So here I am going to give a begin condition, and here I am going to raise an error. So you can use the raise error function. This raise error function will automatically raise a error that the inserted value is invalid. So we can provide invalid department. So you can print this, and you can provide the code for the error raise command. And also along with this, I need to roll back the value. So the row will not get affected into the employees table. So I have provided the rollback transaction command inside this begin statement. So now after this happens, I need to end the begin statement, and also I need to end the trigger. So now let me just close this. So okay, now let me create this trigger. So now again I have this trigger. Now let me try to insert another value. Let me copy this and paste it there. So instead of IT, HR, finance, I'm going to insert a sales department into the employees table. Before this, let us select and see the records in this employees table. Select star from the employees table. So now you can select this employees table. I have 3 rows, 2 rows in a IT department and one from the HR department. Now I'm going to insert a employee in the sales department. When I execute this statement, automatically I got an error that describes the invalid department ID through the trigger enforce department. So the transaction ended in the trigger, the batch has been aborted. This describes that the value is being inserted into the table has been rolled back. So here when I again select this table, there are only 3 rows, so I can enforce the data integrity through this trigger action. So if I change this as a finance, so let's change this sales as a finance. So when I try to execute this now, so 2 rows got affected, one for the employees table and another which is absolutely the audit table. So now let's select this employees table. You got 4 rows which is the finance data, and also you can see this audit table. New row, new employee has added at the specified time. What is on update trigger in SQL Server? So in our last session we have learned what is insert trigger in SQL Server. So basically the trigger is an database object that can be used to execute set of operations or stored procedures which will be fired when certain events happens on your table that you have provided the trigger condition. So in this example we are going to learn about what is update trigger. So whenever you provide any update command for your table, if you provided any trigger for the particular table, then the trigger will be fired and the certain operations that you have specified inside the trigger will be executed on the basis of before and after. So the before update trigger is just executed before an update statement happens, or you can also specify the update trigger for your after condition in the SQL Server. Let us see some live examples in our SSMS, and we can just create a few triggers for our tables and understand better. So here I have connected to my SSMS. I am under the sample 1 database. So here I have a table creation script for the employees table and also few insert statements for this table. Let me quickly create this employees table. So it is already present in the database. So let us name it as employee. Now let's create this table. So that the table got created. Now I am going to insert these values inside the table. So 4 rows got affected. Now let's select the values from this employee table. Select start from the employee. So you can see there are 4 columns: employee ID, the first name, last name, along with the department of the employees. So now I'm going to create a trigger. Create trigger. You can use the create trigger command to create a trigger. Let's name it as create trigger trg update the employee. So we need to provide the on condition which specifies on which table you are going to create the trigger, on the employee table, and for the after condition, after update happens. So I can provide the as and begin. Inside this I am going to print a statement as the employee updated successfully. So let us give an end command and let's create this trigger. So now the trigger has been created. So let me say once again select this employees table. So here I have employee 3 and employee 4 with the same name and the same department. So I am going to update the name, first name of the employee with the ID 4. So now let me provide the simple update command. Update the table name and set which I am going to update is the first name. Going to assign this as Emma and then I need to provide the where condition, where I need to update the employee with the employee ID equal to 4. So when I execute this statement, you can see I got a message that the employee updated successfully. This is a custom message that we have provided in this trigger. So whenever a value got updated in the employee table, this trigger will automatically generates this custom message that I have provided inside this trigger. So whenever I update a value in this employee table, the employee updated successfully command will be shown for me. So we can also automate certain log functions, like we can also create another table, create table, audit update log, and for this table I am going to provide 2 columns, updated value or updated status, which is a varchar, and also the updated time, which is a date time. So now let's create this table. Now the table got created. Let us select the table, audit update log. So now you can see that there is no records present in this table. So here I have this update command, right? So let me update the last name for this employee with ID 4. So let me provide the last name, and I need to set the name as Watson. So let me now execute this. Before executing this, sorry, I forgot to create a trigger which can automatically update a value inside this audit log whenever I update a value in the employees table. So let me create another trigger. So you can use the create trigger option, and you need to provide the trigger name, trigger update log audit, and you need to provide on condition for which table, for the employee table. And for this again we need to provide the after update condition. I'm going to provide the after update, and we can provide the assign begin. Inside this I'm going to insert values inside this audit update log, and I need to provide the values which is an inbuilt status, like update employee update was successful, employee update was successful. So now let me pass the another argument, which is the getDate function, which will returns the current date time value whenever I update this value. So let me end this. So now let's create this table and create this trigger. So the trigger got created. So now I am going to execute this update employee table. So before this, let us select this. There is no record in the audit update log. Once I execute this, you can see there are 2 rows affected, one inside my employees table and another inside the audit log table. So now you can select the employee table. You can see the employee with the ID 4, the last name has been updated, and also you can see this audit log table. There is a row affected which says the update status as employee status was updated successfully with the current date time that I have executed. So you can use this update trigger option to automate your logging functions. So we can also perform the data integrity with this update trigger options. So let me quickly create another trigger for this to handle the insertion values. We can name it as trigger data integrity update.
So I need to provide the on condition. For which table I am going to provide this? For the employee table, I'm going to specify the employee table, and for after updating a value, I need to provide certain conditions. So we can provide the begin value, and here I'm going to handle the conditions. So let me provide the if condition and exits exist of. I'm going to select the value from the inserted record. We have already seen like this inserted table will contain all the metadata where you have a recently updated value or inserted value, where here I am going to see whether the department are in the specified value or not. So let me provide the not in condition, and I am going to specify what are the departments available. So I need a IT department, and we can just copy this from here, HR and the finance. So let me provide HR here and also the finance value. So if the value is not present in this list, then I need to raise certain errors. So let me provide the begin condition. Here I am going to specify the raise error. In this error function, I am going to give a custom messages invalid update, and I am going to specify the specific number for this error, which is 1, and we are going to roll back the value, roll back the transaction, and after this I am going to end this. After ending this, let me provide another end statement. So I have forgot a bracket here. Here I think I have provided a semicolon here. So now we just create this trigger. So now the trigger got created, and again we are going to update the fourth record value. So this time I am going to update the department value. So I am going to update the department. I am going to set the value as something like sales. So now when I am going to execute this, it shows an error that the trigger data integrity update has raised an invalid update error. We can see the custom error that I have provided in this raise error comment. So it has been displayed as invalid update, and the transaction has ended with the abort statement. So now once again you can select the employees table. So the employee with the ID 4 has still in the finance department, and it has not been updated as a sales department. So if I try to update this as a HR, so this is an allowed department. So we have IT, HR and finance. So now when I execute this update statement, so one row and again one row got affected. This is for the employees table, and this is for the audit, and you can also see the custom message that because we have created a trigger earlier which displays this message. Now let's select this employee table again. So now you can see the employee with the ID 4 has been updated with the HR department. So you can also use this update trigger to handle the validation for your update statements. So you can handle the update values for certain conditions, and you can perform the data integrity for your tables. So you can so while you have created these triggers, what if I have dropped this employee table? So I am going to drop this employee table. So now I have dropped this table. So what about this triggers? So when I try to drop this trigger, now it throws an error that
sorry, when I try to drop this trigger, it shows invalid action because it shows that it does not exist or don't have permission. So whenever you drop a table that has certain triggers, along with the table, the triggers will get dropped. So you need to very clear that using a trigger for a adequate insert or updating table is not a good approach. You can use these triggers for your audit for log purposes whenever an value has been updated in your table, and you can also perform the data integrity operation for your update statement. What is on delete trigger in SQL Server? So if you haven't watched the previous videos in the SQL Server playlist, so trigger is basically a database object which can be used to trigger certain operations based on the events happens on your table that you have provided the trigger condition. So today we are specifically see about what is delete trigger. So on delete trigger is an database object that automatically executes a specified set of SQL statements or certain procedures that you have specified for the on delete trigger. You can basically provide a trigger for your table and fire the trigger based on certain events. So this delete trigger will be fired when a row is deleted from a table. So this can be used to provide the referential integrity operations, and for maintaining audit purpose. When you delete a record, you can audit those logs in another table. So you can do some custom message when you delete some records. So we can see some of the few live examples in our SSMS. So here I have connected to my SSMS under my sample1 database. I have a table creation script and also few insert statements. Let me create this employees table. So there is already a table present in the database. Let's drop the previous table. So the table has been dropped. So now let's create this table. So now the table got created. Let me insert these records inside the table. So 5 rows got affected. Let me select these values. Let me select start from the employees. So you can see in this table I have an employee ID, first name, last name, along with the department for each employees. So in this table I am going to create a trigger. So whenever I delete any employees from this employee table, so it will generate a custom message that I have provided in the output window. So let me quickly create a trigger using that create trigger function, create trigger command, and create trigger delete employee. So here I am going to provide on condition for which table. So all the syntax for this triggers for the on delete, on insert, on or update will be the same. So you need to provide create trigger, and you need to provide on which table, and you need to provide the condition after deleting a value. So let me provide after delete, and as you can create the begin statement and end this statement. So inside this begin and end, let me provide the condition. I just need to print the value. So let me print the employee deleted successfully. So let me now create this trigger. So now the trigger got created. Now I am going to delete the fifth employee. So we can just give delete from the employees table
where the employee ID is equal to 5. So this will delete the employee who is in the 5th ID. So while I have deleted, it prints a message, the employee delete successfully. So you can print such custom messages while you have provided a trigger. So this trigger fires when I try to delete a value from this table. So we can also create a audit table and log those deleted values inside the table. Let me create a table for the logging. So let me create table audit log, audit logging, and inside this in the first column I am going to provide the event value, which is a varchar of 255, and the next column which is a timestamp. So let me provide us time deleted. Here I am going to provide the date value. So now I am going to create this audit table. So now the table has been created. Now I am going to create another trigger that is going to take the log of the deleted employees and going to insert this values inside this audit logging table. So let me create a trigger, create trigger delete log. So let me provide like this, and we can provide the on condition for the employees table, and then we need to provide the after condition after deleting the employee. So after this I need to provide the begin and the end statement. So inside this begin and end I am going to write the condition. So I need to insert the value into audit logging whenever I delete any records from the employees table. So now I need to provide the insert statement, inside this, insert into this audit logging table. So let me provide insert into audit logging and the event value and the time deleted. For these two columns I need to provide the values. So here I am going to select the values from the deleted table. So let me write a function like employee deleted, and I am going to get the employee ID from the table which is named as deleted table. So we can first give and we can just first provide let me provide the table name. So here I am going to select from the deleted table. So there is a inbuilt table which is named as deleted. So this deleted table will contains all the information about the deleted value from any table. So we can get the employee ID from this table. So we need to fetch deleted dot employee ID. So we can copy the employee ID and paste it here. So this employee ID will be a integer. So I need to concat this with this string. So let me provide the cast. So this cast function I need to cast the integer as a string value. So I need to provide as varchar 255. So now I have selected the employee ID from this deleted table. So here after this, along with this, I need to pass the value for the deleted day time. So for this I can provide the getData function. So this inbuilt function selects the current daytime value and provide the current timestamp to the time deleted column. So now let me create this table. So now the table got trigger got created. So now I am going to delete the employee whose ID is 4. So now when I delete this employee, so you can see there are two rows affected, one for the employees table, another for the audit logging. So you can first select the employees table. So there are only 3 employees, so I have deleted 2 employees, the ID 5 and 4. So let me copy this and paste it here, and here instead of employees I am going to select the audit logging. So while selecting this audit logging table, you can see the employee deleted and his ID is 4 and the deleted time. So I have logged which employee ID has been deleted along with the date when it is deleted. So you can perform certain logics for logging your delete activity inside your log tables, and also we can perform data integrity operations in delete on delete triggers. So for this, let me create another trigger. Create trigger validate delete. So I need to provide the on condition on the employees after delete begin. So let me copy this and paste it here. So after this begin, I need to provide the condition. Here I going to check, I need to enforce data integrity. So let me create another table for our reference. Let us create another table, like let us just create a salary table. Create table salary. In this table I am going to specify 2 values, which is the employee ID, and this is an integer, and along with this I need to provide the salary. Salary is also an integer. So let's just create this table. So here I haven't provided any foreign key or primary key constraints. So there is no referential integrity binding of data between both these tables. We can just delete any records, but we can also perform data integrity using the delete trigger functions too. So before that, let me insert some values inside this table salary. Insert into this table salary values 1 with 55,000, and let me copy this. So I have 3 employees as of now. So let me provide the salary for the second employee and third employee. So this is 75,000 and this can be 65,000. So now let's insert these statements. So 3 rows got affected. So I need to check if the employee present is in this salary table, then I don't need to delete that employee from this employees table, and I need to print like the employee has been referred in the salary table. So like that, for this I going to check if the value exists in the salary table. So we can provide exists of we can select the value, select some value from the table salary, and we need to check the condition where the employee ID. Here we have a emp ID, so you can provide this emp ID equals this employee ID. So I need to provide, like here I need to check whether this employee ID present in the employees table. So here I have to select the values from the deleted table. So I am going to perform after the deletion. After deleting the value, the deleted value will be saved inside this deleted table. So I need to find the employee ID present inside this deleted table. Let me copy this employee ID and provide it here. Deleted dot employee ID. So this will returns the deleted employee ID and compares if it is present in the table salary or not. So after this we can also provide a condition, like after this, if condition has been satisfied, you can provide the begin condition, and inside this begin let me provide a raise error function. Inside this I am going to specify like that delete cannot delete this employee, and it is referred or associated with salary table. Like this I need to print the message along with the error number. So after this I am going to roll back the transaction. So once the employee is present in the salary table, then I don't need to perform the delete operation. So I need to roll back the operation, roll back transaction, and after this I need to end the statement, and I need to provide the end statement for the trigger. So now let me create this table, create this trigger. The trigger got created. So now I am going to delete the employee whose ID is 3. Once I delete this, execute this delete statement, you can see it shows the associate that cannot delete this employee, it is associated with salary table. This is the custom message that we have provided inside this trigger. So it has been printed and the error has been raised. Along with this you can see the transaction ended in the trigger, the batch has been aborted. So no values has been deleted, it will be rolled back. Now let me select this employees table again. You can see the employee with ID 3. So as this employee with ID 3 is present inside the salary table, you can enforce this data integrity. So now let me delete the value from this salary table. So we can provide delete from this table salary where the employee ID is equal to 3. So now I have deleted the employee with ID 3. So what happens if I execute this delete statement in the employees table with ID 3? So now that value has been deleted because it is not present in the salary table. So there is no reference in the table, and also you can see the deleted employee will be updated in the log table. You can see the employee with ID 3 has been deleted in this date. So you can just specify your audit logging functions. Also you can perform the custom message for your delete operation. Also you can perform data integrity operation. So when there is a no reference between the foreign key primary key reference in the table, so you can enforce a data integrity without a primary key or foreign key by using this delete trigger.
What is DDL triggers in SQL Server?
So if you haven't watched the previous triggers in the SQL Server playlist, I recommend you to watch those triggers. And today we are going to see what is DDL triggers. So DDL is data definition language in SQL Server. So basically DDL triggers in SQL Server are special types of triggers that are fired in response to the database DDL operations such as create, alter, drop commands. So these database objects can be executed on the table views or stored procedures. So these triggers allows you to capture and respond to the changes to the database schema and providing control and auditing capabilities. So you can use the create, alter and drop commands for your tables, and you can perform data integrity operations, and you can allow the users to control over dropping the tables in your database, and perform some audit operations for the modification of your schema in the database. So let us see some live examples in SSMS. So here I have connected to my SSMS, and currently I am under the sample1 database. So in this sample1 database, I just need to create a trigger that allows users to create tables only if the table name starts with TBL. So I need to restrict all other users creating tables in some other names. So we can use the create table trigger to enforce this. So let me create a trigger. You can use the create trigger command, and you need to provide the valid name for this trigger. Let me give us enforce naming for tables, and after that all the DDL and DML, all these DDL triggers, those are the create, alter and drop triggers, are only created on the database level. So you will provide the on database to all these triggers, and you need to specify for which operation you are going to create these triggers. So now I am going to create for the create table operation. So let me provide for creating table and as. So after begin comment, you need to provide the values for the trigger that are going to be executed when the trigger is fired. So let me provide a declare statement. Declare. Let me declare a variable called table name, and provide it as varchar of 255, and let me set the value for this variable. Set the table name equal to select the event data. So this event data is a built-in function in SQL Server which gets you all the values of the event happens in your database. So in this value I need to get the object name, that is the table which is going to be created. So let me provide the event instance. Event instance slash, and I need to provide the object name. So this will check the value, and from this I need to select the first one, and I need to provide the data type varchar of 255. So after this we close this statement, and after this, so there is value is not a valid function, so let me provide value for this. So let me provide this as value, and after this I need to check if the variable, that is the table name, not like starting with the TBL underscore. So I need to provide the wildcard for percentage. If it is not, then begin, and I need to print this as table must start with the TBL. I need to print this, and then I need to roll back the action, so I don't need to commit the changes. After this, let me provide the end command and end the trigger as well. So now let me execute this trigger. So now that trigger got created. Now let me quickly create a table without the prefix TBL. Let me tend to create a table named sample test, and let me provide simply a ID column which is integer. Let me close this. When I try to create this table now, it shows the error like table must start with TBL. So it must start with the TBL prefix. So this transaction has been aborted. So if I try to create with the prefix TBL, then it allows me to create this table. So now I have created this sample test table. You can select this with the select statement, and you can see there is an ID column. So you can allow users to create only the tables with the prefix TBL in such cases using this create table trigger. So if I don't need this trigger anymore, you can provide the drop command, and you need to provide, normally you will provide the drop command for all the database objects, which is a drop the object name and the exact name that has been provided. So if you need to drop a trigger which is a DDL trigger, you need to provide on database along with this to drop this trigger. So if you let me create this. If you try to drop this trigger without the on database command, it will not be dropped. So it is created on the database level, so you need to execute along with the database command. So now let's remove this. I have dropped the table. So you can see there are so many tables available inside my database. So I need to enforce dropping operations handling for the users. So when a user try to drop a table, I don't want to allow them to drop a table in my database. So I can create another trigger which can handle dropping the tables inside my database. So let me provide a create trigger command, and after this I need to provide a name, which is prevent drop table, and after this all the DDL triggers are created on the database level on database. For I need to provide the drop table command, so to perform when the table is dropped. So as begin, whenever the user try to drop a table, I need to print that dropping table is not allowed, and after I need to roll back the action, and once this has been completed, I need to end this trigger. So now let me create this trigger. So the trigger got created. Now let me try to delete one of the table from this list. So drop table, I need to drop this employees. Now when I execute this, you can see dropping table is not allowed. So this has been printed. So and the transaction has been aborted. So the table has not been dropped. Let me refresh this table folder. You can see the employee table is still available in the database, and you can avoid the users dropping your tables in the database by creating such triggers in your database. So just like in the previous trigger, if you need to drop this trigger, you just need to drop along with the database command. So now the trigger has been dropped. So now when I try to drop any of this table, let me drop this table sample test. Now I can able to drop any of the tables inside my sample1 database. So now let's remove this. So and we have seen the create table trigger and the drop table trigger. So the create table trigger can be triggered or fired when user creates a table inside their database. The drop table trigger will be fired when a user try to drops a table inside the database. So now we are going to write a trigger that can take an audit log for the alteration of schema in the database objects. So whenever a user modifies certain rows or columns in the table, then I need to update log inside the audit table. So now before creating the trigger, let me first quickly create a audit table. So let me create table, name it as DDL audit log. So inside this table I need columns like I need a audit log ID, which is an integer and identity of 1, 1. So let us provide the identity for this and the primary key constraint. And I need a second column which is a event or the object name, which is a varchar of 255, and I need another event log, which is a event DDL, and which is a varchar of 255, which is again varchar. And also I need a XML data of what event has been happened. So event XML. For this I am going to specify the database XML. So finally I am going to provide the event time. In this event time I am going to specify the date time, and I just pass a default value as getDate. So this getDate built-in function will returns the current datetime object a database, that is any altering of the schemas happens inside my database, then I need to take a log of the value in an XML format. So now let me create a trigger, and the trigger name, so let me provide as audit table changes, and we need to create on the database and for the alter table. Whenever a table has been altered, then I need to take log as begin, and inside this begin I need to provide the statements. So let me declare a variable. We declare as a event data, and this event data will be an XML data type, and then I need to set the value for the XML value event data variable. So that set event data variable equal to event data. So you have seen this event data built-in function which returns the event data value inside the database. So now let me insert into this audit log table the values which has been updated, that is the alter functionality that we have provided to change the schema of the database object. So let me insert into this DDL audit log table, and inside this I need to update the object name, just the table name. So let me provide this object name first, and then I need to update the event type, which is the which type of DDL command has been happened, and finally the XML data of the object. And after this I'm going to provide the values for this. So in this values, let me provide the variable which contains the event data. So inside this variable I'm going to take the values of, similar to the previous one, let me provide the dynamic query to fetch the event data, which is the event instance of object name. Then I need to close this and provide the indexing and the data type, which is a varchar of 255. And after this, let me close this and pass the next value, which is again the event data dot value of the same event instance. So let me provide the quotes. So instead of this object name, I need to pass the event DDL, and after this let me provide the final variable which contains the XML information. And after this, let me close this. So after closing this, let me end this trigger. I have created this alter table trigger. So now let me try to alter a table. Let's say, for example, let me take this employee table. Let me select this employee table first, and you can see there are employee ID, first name and last name. So I'm going to drop this last name column inside this employee table. So let me provide the alter script, alter table. Let me provide the table name. Let me provide this table name, and I'm going to drop the column, drop column last name. So let me execute this statement. So command got executed successfully. So now let me select this table. Now let me select and see this audit log, pivot, and what is unpivot in SQL Server. So pivoting in SQL Server is a method to change your rows into columns or columns to rows. So pivoting is used to, if you have a unique rows in your column, then you can change the single column into multiple columns by using pivot function. And unpivot is just opposite to the pivot option, where you can change the multiple columns in your table into a unique single column in your table. So basically the pivot and unpivot can be made in something like a matrix. So you can transpose your table. So the pivot and unpivot is used to change the rows and columns in your table based on certain aggregation or conditions that you have provided for that. Let us see some live examples in SSMS to understand better about this pivot and unpivot. So here I have connected to my SSMS, and I have a table creation script along with the insert statements. So let me create this sales table now. Let me execute this. So the table got created. Let me select this insert statement. Let me execute this. So totally 36 rows got affected. Let us select the table. Select start from sales. So now let me execute this. So you could see there are 36 rows in my sales table. I have a product column which contains the product name and the month and the revenue for each product in each month. So in this you can see there are product and months are unique, and it is repeating itself. So you can see there are multiple months, and you can see the months
are based on these three products. So I need to pivot this month to get the month wise revenue for each product as a result. So for this, let me use the pivot option in SQL Server. So let me write a query. For this, first I need to select the, let me copy this and paste it here. From the sales table, I need the product and month and also the revenue. So now let me execute this. This returns the same value as my table. So from this, take this as source table, and then I going to perform the pivot operation. In this pivot operation, let me provide the condition. Inside this, I need to calculate the sum of the revenue based on the month. So I need to calculate the sum of revenue. I need to provide for which column. I need to calculate for the month column. So I need to select all the months inside this. So let me copy all the months from here. Let me copy this. So I have provided all the months here. So let me take this as pivoted table. So from this, I need to select everything. So now when I execute this query, you can see the result. I have got the products and along with all the months as a column value and sum of the revenue inside each month for the particular product. So for the product A, you can see here the product A has 1000 revenue for the January month and 1500 for February. So for this, you can calculate the sum of the revenue, and you can pivot the months into separate columns. So in this example, you have seen like I have changed this month column into separate columns inside the select statement. So this is known as pivoting the table. So you can separate all the single column to multiple columns in your table. There is also unpivot in SQL Server. So for this, I have another table. Let me create this sales pivot and let me insert these statements. So here, let me select this sales pivot. Let me copy this, paste it here. You can see in this table I have product and a particular month, but I have multiple products A, B, C, particularly two Z values. There are 26 rows and for each month. So here now I am going to unpivot the value, that is I am going to unpivot these 3 months into a single column under month. So for this, let me first select, copy, paste this here. Inside this, I need to select the product January month, February month, and finally the March. So this will give the same result as the select query. So let me take this as source table. And just like in the pivot table example, here we need to provide us unpivot.
So for this you need to provide the condition. Inside this circular brackets I need to unpivot the revenue. So in our previous example we have pivoted for the sum of revenue. Here I am going to unpivot the sum of the revenue based on month. So I have provided for month. Again I need to provide the list of values. So here I am going to pass this 3 months. So there are only 3 columns for the month in the sales pivot, namely the January, February and March. So here I have provided those 3 months in the select, and let me rename this as unpivoted table. And finally I need to select everything from this subquery. So now you can see while I execute this statement I got 78 rows. That is all the 3 months has been unpivoted and joined as a single column in my select query. So you can also see I have 26 rows previously and for 3 months. So all the 26 rows has been for all the 3 months has been multiplied and returned as a single column, that is the month column. What is stored procedure and how we can use stored procedure in our databases? So stored procedures in SQL are a collection of SQL statements. You can enclose in a named package, and you can use those statements by calling the procedure name. So the stored procedure can be invoked by its name, and you can also probably pass some parameters and perform certain operations and returns the result. So stored procedures are mainly used to perform some complex logics, and you can improve performance by enclosing repetitive codes inside a procedure and calling the name. So let us see some few examples to how to create SPs and how we can use those SPs in our table and database to perform logics. So let us get into SSMS. So here I have connected to SSMS. I am under that sample1 database. So for this example, let me create a table first. Create table, product details, and for this table let's provide few columns. Let me provide an ID column which is an integer, and product name which is a string varchar of 255, and another column like product category which is again a string. So let us provide varchar. Now let me create this table. So the table got created. So to insert few values inside this table, we will usually write insert statements. So whenever I need to insert some values, I just need to again write insert into the table name values and pass those values to the columns that I need to insert the value. So what if I can use a store procedure to insert statements into this table? Whenever I need to insert some values, I can just call the SP name and insert values into the table. These SPs are basically very helpful whenever you develop an application. You can write SPs and use those SPs names to insert or update, delete your operations in the web applications. So let us first quickly create a store procedure to insert certain values inside this table. So let me provide create procedure. So to create a procedure, you need to use this create procedure command, and you need to provide the name for the procedure. SP underscore insert product details. So after providing the name, you need to provide as, and you can begin and provide the end. Inside this begin and end, you need to write the logics that you need to perform for this procedure. In this procedure, I need to provide the insert operation. So let me provide the insert into command, insert into the table name and the values. So I don't need to write this as a static one. To make this as a dynamic, we can also pass parameters for this procedure. To pass parameters after this SP name, you need to define those parameters. So I need an ID
parameter, and you need to provide the data type along with the parameter. So these parameters are basically mentioned with this at symbol, and another parameter which is name. Also you need to provide the data type for all the parameters. Finally I need a parameter named as category, which is also a string. So I have provided 3 parameters. So here I am going to pass these parameters for this table. So in this SP you can see that I'm going to get an ID, name, and the category value, which are again going to pass inside this product table, and the value will be got inserted. So now let us create this procedure. So now the procedure got created. To execute this procedure, there are 2 ways. You can use execute, and then you need to provide the procedure name, and if the procedure has any arguments, then you need to pass this. Here I am going to pass the argument for the ID and the name, and for the category. For the name I am going to provide HP, and this is under the category laptop. So now when I execute this line, you can see 1 row got affected. So now let me select this table and show the value which is inserted. So now you can see the HP laptop has been inserted into this product table. So we can also execute the SP without this execute command. Just provide the SP name, and let us insert another row. We can provide Dell laptop. So again 1 row got affected. Now let's select this table. You can see I got 2 rows. So whenever you need to insert any rows, you can just call this SP name and pass the arguments for the parameters. So now we have created an SP to how to insert values inside this table. We can also write SPs for updating values inside this table. So let us see how we can create an update procedure. Again we need to write create procedure, and you need to provide the procedure name. So let me copy this, paste it here. Here I am going to provide SP underscore update product details, and again I need 3 parameters. So here I am going to specify this ID at the last. So now after passing these parameters, let us provide the as command and begin end. So this begin and end specifies that this procedure begins here, and all the comments will be executed, and the procedure ends. So inside this area we can provide the operations. So let me provide the simple update command. Update the table name and set the value for the product name. Let me provide the column name product name equal to. So I need to check whether this first parameter has a value or a null. So if it is a null, I don't need to update the value. If it is a null, if the parameters has a value, I need to update the column. So now let me provide a case statement for this. Case when the name parameter holds this product name. So when this name is not null, then I need to pass the value, else I need to keep the product name itself. So I can end this, and after this I need to pass for this category column as well. So category equal to case when this category parameter is not null, I need to pass the category value, else I just need to keep the same value. And here I need to provide the where condition where, and we need to specify the ID. So we need to specify the particular ID at which ID we need to insert the update the value. So in this id column I need to pass this id parameter. So now let us create this table. So create this procedure. Now the procedure got created. So we can run this procedure either with the name or the execute command. So here we can also have another option, like we can pass the value for the parameters by specifying the exact parameter name and the value. So in this example, let me provide execute the procedure name, and after this I am going to specify that for this name parameter I am going to specify like Lenovo, and for this category parameter I am going to pass this is a laptop. So let me just insert null inside this null value, and finally for the id column in this id parameter I am going to specify id equal to 2. So before executing this, let me select this select statement. For the id with 2, the product name is Dell and the category is laptop. So now I am going to update the name as Lenovo, category as null for the id 2. When I execute this procedure, one row got affected. So now let me select this table again. So you can see the id 2 product name has been updated as Lenovo and the product category is still laptop. So we have performed the case operation, which allows us to keep the specific value if we pass the null for that column, and if it is another value then it will be updated. So now this SP can be used to update the values inside this table. So basically these procedures are mostly used for the CRUD operation. So we can see another example for creating a procedure without any arguments to select certain values based on the id. So let me create another procedure, create procedure, and the procedure name SP square select product, and you can provide the as begin end, and inside this let me give the select statement, select start from the table name, which is the table details. So I just need to select the particular id, so I need to pass the id. Let me create a parameter for this. So the id is an integer value. Let me declare this, and here I am going to specify the where condition, where the column id equal to this id parameter. So now let me create this procedure. The procedure got created. So let me execute and show this procedure. Execute the procedure name, and I need to pass the id. So here I need to select the product with the id 2. So now let me execute this. So it selects the product with the id 2, and now I need the product with the id 1. So now it fits correctly the specified id that we pass. So we can also use this procedures for the select statements too. Here you can provide any complex logics, and you can just pass the id name to fetch those logics in your tables. So we have seen how to select, insert, and update values. Finally, we are going to see how we can delete a row by passing a id from outside the procedure. Let us create a procedure for that. Create procedure, procedure name, delete product, and provide the as condition begin and end. So inside this, let me provide this delete condition, delete from the table name. So again here we need to specify the id. So whenever we provide a delete condition, we need to specify id, otherwise the entire data will be deleted. So here let me again pass this argument id. So we need to delete the value rows based on this id. So here let me copy this where condition and paste it here. So now let's create this delete procedure. The procedure got created. So we have two values in our product details table. Now when I execute this procedure, I need to pass the argument as well. So let me delete the product with the id 2. When I execute this, one row got affected. Now let's select the table and see. So the product with id 2 got deleted successfully. So by this you can understand how procedure works in SQL Server and why we can use these procedures in SQL Server. So here I have explained just a simple insert, update, delete and select statements inside this SP. So we can also perform certain operations and business logics inside this SP as well. So for the basic level, we can use these insert, update, delete SPs to insert values, update the values in a table. So whenever you need to insert, you don't need to specify this insert command again and again, just like for the update and delete operations. Just we can call the SP name and pass the parameter for those SPs, and we can perform all the operations. What is function in SQL Server? So function is a block of reusable codes that can be used to perform certain logics or tasks. You can pass any parameters and perform certain operations and return the result in your functions. So in SQL Server there are mainly two functions, which are a scalar function and a table valued function. So this scalar function usually returns a single value for the parameters that you pass. These scalar functions are basically used in our select, where or order by commands to perform our manipulations before returning the results for the users. So there is also table valued functions. These functions will return a table rather than returning a single value. These table valued functions returns an entire table. So basically table valued functions are used in our select statements for our tables or views. So we cannot perform any DDL or DML operations. So we have seen procedures in our last video. If you haven't seen the procedures, what is store procedure in SQL Server, let me provide the link in the description. Please watch that. And you can perform insert, update, delete all the DML and the DDL operations in the store procedures, but you cannot perform any DDL and DML operations in functions. You can perform operations, calculations for your scalar functions that can return a single value for your calculations, and also table valued function which can perform only in the select statement, and you cannot update or delete. You cannot perform the DDL DML operations in functions. So let us see some live examples and understand the functions better. Let us create some tables and let's see how function works in SQL Server. Let us get into SSMS. So here I have connected inside SSMS. I am under the sample1 database. So let me quickly create a function, a scalar function that can accept two parameters and perform addition operation and returns the value. Let me use the create function command to create a function. So whenever you create a function, you need to start with create function and you need to provide the name for the function. So I'm going to provide as add numbers, and then you need to provide the parameters that are going to be passed to this function. So I need to pass num1, which is an integer, and num2, which is also an integer, and after passing this parameter you need to specify the return type. So in store procedure you must not provide any return type for the procedures, but in functions you need to provide the return type value for your functions. So as this is a scalar function, let me provide the return type as integer. Provide as returns integer, and after this you need to provide as and begin end. So inside this begin and end you need to perform the logics. So to store the added value, sum of the value, let me going to declare another variable. So declare sum, which is also an integer, and after this let me going to perform the addition operation. So let me add the num1 and num2 and store this value inside the sum. So I need to provide set. So we are going to set the value for the sum, and after this you can provide the return statement, which is going to return the sum of the value. So return the sum. So this will actually returns the sum of the value. Let us create this function. So the function got created. Now to execute this function, we can call the function just like in other languages, you need to specify the name in the select statement. Along with this, you need to pass the parameters for the function. So I have passed 10 and 5 as the argument, and I need to print this as sum of values. Sum of values. So now I'm going to execute this. So now the function works fine. The sum of 10 and 5 is returned as 15. So let us give other numbers. Now let me select this. So we can use scalar functions for these type of operations, but in scalar function it can only return a single value. It can be integer, string, or it can be a decimal, anything, but it cannot return a table of results. So if we need to return a table of result, then we need to go with table valued functions, also known as TVF in SQL Server. So let us see another example how we can write a table valued function. So now to explain this table valued function, I am going to take a table from this database. Let us take employees table. So now let me execute the select statement. You can see I have an employee table with ID, first name, last name, and the salary. So now I am going to create a function that is going to accept the ID of the employee and return all the results for the particular employee. So let me provide the create function command. Create function, return mdetails. After this, we need to pass the parameter. Let me provide the parameter as ID, which is an integer, and after this we need to provide the as begin and end. Inside this, let me provide the select statement. Select star from the employees where the ID is equal to this parameter. So here we need to provide the return type as table. So we are going to return the value as a table. So here we need to provide the return type as a table. So instead of begin and end, you need to provide the return value. So you are going to return the select statement. So rather than using begin and end, in this table valued function you are going to provide the return function. So let me execute this. So now we have created this function. To execute this function, let me provide the select statement. Select star from the function name. As it is a table valued function, you can pass the ID and you need to provide star. This will returns all the columns. If you need only the selected columns, you can also aggregate that. So now the employee with the ID 2 has been fetched. I need with the ID 4. Now the employee with the ID 4 has been returned. Here I just need only the salary, then I can provide only salary in the select command, and I can fetch the salary alone in this function. Then we can also see another function that can be used along with our select statements to perform a simple logic. So let me execute this select statement. Here I have a first name and last name. For a simple example, I am going to concat this first name and last name and return a full name column along with this select statement. So for this, let me create another function. Create function dbo dot full name and I need to pass the parameters. I'm going to pass the first name. So first name parameter, which is a character value string, and again the last name parameter. So let me copy this and paste here. Here let me provide the last name. After this, you need to provide returns as a table. After this, as and return the value so here we are going to return only the first name. So this is not a table value function, it is just a scalar function. So I need to return only the string value that I have concatenated. So we can go with the begin and end. So inside this, for this, let me declare another variable to hold this full name value. So let me name it as full name, which is vacare, and here I am going to set the value for the full name. Full name equal to, I just need to add this first name and last name. So as the both are string, we can just use the plus operator to concatenate the value and return the full name, which will gives us the full name. So now let me create this function. So now the function got created. So in this select statement, I have selected all the records from the employees table. So here along with this details, I need to select the full name too. So here I am going to call the function. So let me provide this function name here, and we need to pass the parameters for that. So here I am going to pass the first name and the last name from the table. So here you can see, let me provide this as alias name, full name. So let us select this now. So here I have got the full name by adding the first name and last name. Here I need a space, so let me alter this function. So for a best practice, try always create a function with a create or alter command, so we can edit it anytime. So now let me run this command. So the function got altered. So when I again select this now, you can see I got a full name column with the first name and last name concatenated with the space value. So we can use the functions as a scalar value or a table valued function. What is a view in SQL Server, and what is an indexed view, and schema bounding in the view. So basically a view is a virtual table in SQL Server that can be created based on the result set of a select statement, and it can behave like a table, but it doesn't store any data on its own. Instead it can use the query definition, and whenever the view is queried, the underlying select statement will be executed, and the retrieved result set will be displayed for you as a table. So there are different types of views in SQL Server, that are simple views, complex, and indexed views. So simple view is just you can join multiple tables and restrict certain columns to select particular columns as a table. So a complex view is nothing but which contains certain group by having and other filtering distinct conditions in your views. So indexed views are one that will be stored physically in your disk, but it can give an improved performance for your views. These indexed views are basically used for frequently accessed and highly complex queries. So there are certain other uses for views in SQL that are you can simplify the logics. So when you are going to execute some complex logics, you can write certain logic into a view, and you can use those logics for your complex logic. So this can allows you to simplify your query and enhance your maintainability and readability of your code. And also, comparing to the security, you can just provide access for certain columns and certain rows from the table, regardless of providing the entire access for the table for your users. So this is an additional layer of security for your database. And also for the data abstraction, when you use a view, it can hide the complexity of the underlying data, and it can be used to simplify the logics for your application or for the end users. So also the reusability of the code. So once you create a view based on certain logics, you can use those views in a number of your queries to access it. The main thing, the views are virtual tables that will not occur any space in your database. It will be just referring on top of the query. Whenever the view is called, the query will be executed and the result set will be shown, and you can use those views result set for other operations as well. So let us see the brief example for views inside the SSMS. So here I have connected to my SSMS. I am under the training DB. So under this, let me expand this. So let me select a table first. Let me drag this employees table over here. So let me execute this select statement. You can see in this employees table I have employee ID, employee name, department ID and their respective salary. So that there are totally 8 records in this table. Let us see the department table, which is also available for us here. So rather than creating a new table, let us use these tables to perform the view operations. So I have 2 tables. So whenever you want to find the employees along with their department name, you just need to use the select statement and you will refer the employee table. Let us take this as E and you will perform a join operation to the department table. Let us take this as D and need to provide the join condition, join based on this department ID. So after this you are going to filter the employee name, E.employee name along with the D.department name. So whenever you want to use this, you are just going to write these statements again and again for your logics. So instead of using again and again these queries, you can just create a view and put all these queries inside that view. Whenever you need these logic, you can refer that view and call it in your queries. So let us create a view. You can use the create view command to create a view. So we can use VW as a prefix for views. We can view employee department names. So this is our view. So inside this you can provide us and you can enclose everything inside a settler bracket. And now here our view is ready. Let us execute this. Now the view got created. So you can now just query this with a basic select query, select start from. Without providing the table name, you can provide this view name which contains the information from the employee table and the department table. So now without using these complex logics, you can just provide the view name and access these result set in your queries. And also you can also provide some logics like grouping, aggregation and filtering the values. Let me provide only top 5 employees over here. So you can create a view using the create view command. Also you can alter the views using the alter command. So I have provided alter view, select top 5 employees from this employee and department table. So now the command got executed successfully. Now let us see, only top 5 employees will be returned for me through this view. So this view does not occur any space for me in this database. It just refers to the data available in the employees and the department table. So let me create another view which can perform certain aggregation functions. So view employee count in department. So let me provide as. So inside this, let me give select start from the employees table and join with this department table. So here I need to group the value, group by the department ID. So now I have grouped the value based on the department ID. So let us just select this. So we need to provide any aggregation function. So let me provide the count of the employees. So count of the employees. So we can select the e.employee ID over here. Let me copy this and paste it here. And now let me execute this. So we need to provide based on which table. So you can see, you can also provide the department ID over here, d.department ID. Let me copy this and paste it here. along with the department name. Let me copy this name and paste it here. So now we can see so we need to provide the department name along with this department ID to include in this select statement. So now let me execute this. So let us provide a valid name for this column as employee count. So this can be used to create an aggregated view for me. So let me execute this. As usual, we can select this view with our select statement. Select start from this view and let us execute this view. So now you can see that I got the department ID, department name along with the employee count. So we can perform aggregation and group by logics inside views. There is also schema binding in views. What is schema binding in SQL Server? So while we refer to this employee table and department table, that it is just a reference for this view, then the data will underlay and stay inside the employees and the department tables. What if I am going to alter the table and or else I am going to drop the table, then this view will get affected. So let's say for example I am going to drop the department ID column or department name column from this department table. So this will affect my view. So there is no department name. So this view will run into an error that the table department doesn't contain department name. So to avoid this and perform the data integrity, you can perform schema binding inside your view. This schema binding is helpful for you that if you need to delete or alter any underlying data inside the tables which are referred in the view, you need to first delete the view before modifying the table. Otherwise the SQL Server does not allow it to be modified. So let us see how to create a view with schema binding. So let me provide create view, give a view name, view employees, and provide the as command. Inside this, let me provide the select statement. Here I am going to select everything from both of this table. So to create a schema binded view, we need to specify that with schema binding. So now let us just create this view. So we need to specify the column name. Let me first copy the command from here. So let us select the employee ID, employee name, and the department name. So let us copy this, paste it here, and let us execute this view now. So you can see the view got created. This will returns the same result as of our first view, which is the employee ID, employee name along with the department name. So let me execute this. Now you can see this got created. So when I'm going to drop the employee name column from the employees table. Let me provide the alter command, alter table, employee. Let me provide the table name, drop column. I need to provide the column name. So let me copy this employee name and provide here. So when I try to execute this statement, it shows that the object view employees is dependent on the column employee name. So alter table drop column employee name failed because one or more object access this column. So this specifies that the view that I have created, the employees view, is dependent on this employees table. So there is a binding between the employees table and the view that I have created. So if I need to alter this table to drop this column, first I need to drop this view before modifying this employees table. So this can avoid the data got dropped in tables, and this can helps us to prevent the data integrity in our database. So what is an indexed view? So indexed views are highly useful when the query the result set is a complex one and we need to access it again and again frequently. So let me provide an indexed view. So to create that indexed view, let me copy this view and paste it here. Here let me change the name, employee with index. So to create an indexed view, it is a prerequisite to add schema binding. So if you need to create an indexed view, you must need to provide the schema binding. So now let's create an index for this view. So before creating this, let us change few things. Let's remove this ID column. Let us give this as count big of, provide all the entire rows inside this, and you can give create or alter in any view that you are going to create. So this can be used whenever you want to alter the view. So now let's go ahead and create a index for this view. Let me provide that create index command. So you need to provide which index you are going to create. So you need to clearly specify what type of index you are going to create for this view. So I am going to give the unique clustered index. So if you are not aware about what is index, let me provide another video separately on the index topic. So as for now, let us provide a name for this index. So we can provide this view name along with the column which we are going to provide the index. So this is a naming convention for the index. You can provide the ix and the table or view that you are going to refer and the column name. You need to provide the on condition, and here you need to provide the view, and inside you are going to provide the column which you are going to assign the index. So now let's first create this view, and again we can create this index. So now the index got created. Let us just use the select statement to retrieve the query from this view. So now you can see we just created a view and created an index for the view. So to create an indexed view, the schema binding is a
looping statements in SQL Server. So likewise in other programming languages we have looping in SQL also. So we don't have any for loops in SQL Server. We can either use a while loop or a cursor. So what is a looping statement? A looping statement is basically used to repeat a set of tasks again and again until certain condition is true. So for this there is a while loop and also cursor available in SQL Server to repeat these tasks. So let me explain what is a while loop in SQL Server. So while loop is used to execute a set of SQL codes and whenever the condition is true. So you need to provide a boolean condition until it is true, then the set of codes will be executed. When it becomes false, then the loop will be terminated and ends the process. So we have another looping concept in SQL Server known as cursors. So cursors are database objects that are used in SQL Server to iterate a process of the result set row by row. So when you use a cursor to iterate over a table, then it will returns the value results based on row by row function. So you can get the result set one by one in your cursor. So it will be beneficial for us to perform many operations. You can either use a select statement, update and delete operation through these loops. So it will be really helpful to repeat the task some set of codes in SQL Server. So let us see some live examples and create a few while loops and cursors and understand it better. Let us get inside SSMS. So now I am inside SSMS and I have connected inside my server. Let me create a new query inside my training DB. So here just like in any other programming languages, starting with a while loop, let me print integer values from 1 to 10 so you can understand it better. For this, let me first declare a variable number. So in SQL, if you need to declare a variable, you need to name the variable with the @ prefix. So this will says the SQL Server that you are defining a variable, and you need to use the declare command to declare a variable, and after the variable name you need to provide the data type of the variable. So as this is a number, let me give it as a integer value, and after this I need to pass a initial value for my variable. So I am going to initialize a value for this. Let me give as 1. So now the variable holds a value 1. Now I am going to perform the while loop. I need to run the loop. Let me provide my variable until this is less than or equal to 10, then I need to print this value. So here I am going to give the begin and end command. Inside this begin and end, we need to provide the code which is going to be executed repeatedly until this condition is true. So basically in SQL Server, the while loop has a syntax of you need to provide the while keyword and then followed by the condition. Here I have provided the variable less than or equal to 10. So inside this I am going to print the variable, which is this number variable, and after printing this you need to provide the increment value for this variable. So let me provide the variable name, and I am going to increment this with 1. So now I have declared a variable and set the variable as 1, and inside this while I have provided if the variable less than or equal to 10, then I need to execute these statements, and I am just printing the variable. So I have set the value to increment 1 by 1. So now let me execute this. You can see the value has been printed from 1 to 10. So you can use while loops just like in other programming languages to repeat the set of tasks until the boolean condition is true. So you can handle the loop operations with the help of conditional operators too. For this let me provide a if condition. I need to break the loop once the variable reaches the value 5. So here I am going to provide the if condition. If the number is equal to 5, then I need to break the loop. So here I am going to use the break command. So now let me execute this again. So you can see now my loop has printed 1 to 5. So I have provided if the variable reaches 5, then I need to break this loop. So you can also use conditional statements inside your loop to handle the loop function. So you can use a while loop to repeat set of tasks. So to explain this cursor, let me take a table from this database training DB. Let's expand this table folder. Let me take this employees table for the example. So let me provide the select command. Let me execute this. Now you can see that in this employee table I have employee ID, employee name, their department ID and their respective salary for those employees. So here I am going to declare a cursor that will repeatedly fetch the employee name and print it in the output window. So for this, let me first declare a variable which holds the employee name. For this we need to provide the declare command, and starting with that we need to provide the name. Let me provide as employee name, which is my variable name, and I need to provide the data type for this. Let me provide envarchar 255. So I have declared a variable, and then now I am going to declare the cursor. So let me provide the declare command again. So for this, to declare the cursor, you need to provide the cursor name first, employee name. So I have provided the cursor name as employee name, and followed with the name you need to define as this is a cursor. So give the cursor command, and you need to provide the for condition and for which you are going to declare this cursor. So I am going to declare this cursor to select the values from the employees table. So let me provide the select from the employees table. So I just need to fetch the employee name. So let me provide the employee name in the selection list. So once you type in, you can see the suggestions. You can just select this employee name alone for our example. So after this, you need to open the cursor that you have created recently. If you open the cursor, you just need to provide the open employee name. So this is my cursor name. open employee and then you need to provide the fetch next condition. This is going to fetch the value one by one. So fetch next from the cursor name. So let me provide the cursor name, employee name, and after this you need to provide the declare this inside the variable which you have created here. So into this variable, so this will assign the first value for my variable, and again now I am going to repeat the task with the while loop. Inside this while I am going to provide a condition which is I going to get the status of the run count, and after this when it becomes 0 then I need to break the loop. For this I am going to use a global parameter which is built-in global parameter available in SQL Server. You can start with at and you can see all the global variables available in SQL Server. Here I am going to select this fetch status and I am going to check until it is 0. I need to begin and execute these statements. Inside this begin I am going to print the name of the employee. So I am going to give the print and all the employee names will be stored inside this variable. So I am going to print this variable. So after this I need to provide the fetch next command. This will again fetch the next value from the cursor. Fetch next from the cursor, which is the employee name, and after that I need to provide the into condition and insert this into the variable that we have created. So after this you can end this cursor and then you need to close the cursor. Close the cursor name. Along with this you can also deallocate the cursor. Deallocate and you need to provide the name. So now let me execute this set of codes. So here I have declared a variable which holds the employee name, and I'm declared a cursor to select the employee names from the employee table, and I have opened the cursor and I have inserted the first value inside my name employee name variable, and inside the while loop I have provided my print statement and incremented the value one by one. So now let me execute this. You can see in the output window I got all the employees name one by one. So it has fetched the rows one by one and returned the employee name with the help of this variable which we have created. So rather than using the print statement, if you use the select statement, it will clearly shows how the data will be fetched. So here you can see the data is fetched one by one. So in the output window it is returned one name at one time. So this is the basic difference while we use a cursor. So cursor is used to return the values one by one from the result set. So these are the two available looping statements in SQL Server. You can use a while loop to repeat a set of codes repeatedly until the boolean condition is true, and you can use a cursor to repeat the values index in SQL Server. So just like in a book you have an index to easily access the pages and topics in the book, there is a concept in SQL Server which is index that can be used to quickly identify rows in your table or a view. So basically we will define an index to speed up the query performance of a table or a view. Whenever you use a select statement with a particular column, if we have specified any index value for the column, then the SQL Server will easily fetch the rows based on the index value. So we can have a clustered index, non-clustered index, and unique index in SQL Server. So what is a clustered index? A clustered index will be physically stored in a table, which is the order that we have defined for the column, and it will be easily accessible for the user whenever they query a table. So these clustered index are basically created in a table at only once. So each table or a view contains only one clustered index, and it can have a multiple non-clustered index. So whenever you create a table, if you haven't created any clustered index, the SQL Server itself creates a clustered index, that is the primary ID. So if you have declared a unique ID column, which is a primary column, then SQL Server automatically creates a clustered index for you, and it will be accessed based on the index. So what is a non-clustered index? This is again a indexing method in SQL. So here this does not modifies the actual table. So the value based on the column that you have provided for the clustered index will be mapped with the address bar. So whenever you fetch a row from the table, the address value, which is a hexadecimal value, can be fetched, and based on the value it will filter the table and search in that. So rather than going with the table scan value, which is again comparing the each row for your result set, it will be easily to fetch the rows in your table. So what is a unique index? The unique index is useful for you to have only the unique values in the column which you have provided for the index. So it will enforce the data integrity by allowing only the unique values to be allowed in the column that you have provided for the index. So let us see some live examples for how to create a clustered index, how to create a non-clustered index and a unique index, and how we can use across the tables and views. So let us get into SSMS. So here I have connected inside my SSMS. I am currently under the training DB. So let me take a table for our example. Let us expand this table folder. Let me take this employees table. So let us select this table, the select statement. So when I execute this employee table has employee ID, name, department ID and salary. So I have created this employee table with a primary key as an employee ID. So whenever you create a table with a primary key, the SQL Server automatically creates a clustered index for you. So for this, let me first create a table and show you. So you can see, let me give this as a demo table, and let me provide two columns, one ID column with a primary key and a name column, which is a character string column. Now when I create this table, now the command executed successfully. So let me refresh this tables folder. So now here our demo table. So let us select the table. So let me execute the select statement. You can see in this table we have an ID and a name column. So how we can see what are the index available for us in this table? In this table you can see there is an index folder for you. This index folder contains all the index which have associated with this table or a view. So here it shows there is an index available for me in this table, which is a clustered index. So let me click and open this. So this pop-up shows that for this table, demo table, there is a index which is and the name which is an index type of clustered index, and there is a unique enabled for this index. So this is a unique clustered index which SQL Server itself created for me. So this is a default index that has been created by the SQL Server. So what if I need to create an index for myself? So let me select this employees table again. Here you can see I have a clustered index, unique clustered index for employee ID, because I have provided the employee ID as a primary key column. So there SQL allows only one clustered index in a table, but we can have multiple non-clustered index. So I am going to define a non-clustered index for this salary table, salary column. So to define a cluster, you need to put the create command, create non-clustered index, and then you need to provide the name for the non-clustered index. So basically the naming convention for the indexes are the capital IX followed by the table name which you are going to create the index. Let me give this employee table, and then you need to provide the name of the column which you are going to create the index. So let me provide salary column here, and you need to provide the on condition, on which table you are going to refer. I'm going to provide this employees table, and in this you need to give which column you are going to select. So let me provide the employees column here. So now when I execute this, you can see the command executed successfully. So I have created a non-clustered index for my employee table. To see this, let me expand this employees table. Under this you can see the index folder. Here it shows me the non-clustered index that I have created recently. So it shows the name of the index, and it is a non-unique index, and it is a non-clustered index. So I have created a non-clustered index for my employees table based on this salary column. So whenever I query a result, for an example, let me execute this first. Let me copy this and paste it here. So here I need to filter the employees whose salary are greater than 55,000 and less than 60,000. So let me provide the condition where salary is greater than 55,000 and also their salary less than 60,000. So now when I execute this, you can see it has fetched 2 records from this employees table. So whenever I execute this command, so now we have created a non-clustered index for the salary column. Before creating this, what exactly happens is whenever this query has been executed, the SQL Server checks the first row if it is greater than or 55,000 and the less than or equal to the 60,000 value, and it will be fetched one by one. The column will be scanned one by one. So this is the table scan value which is automatically happen when you execute this query. So what if I created a non-clustered index, then a unique value address will be noted for all these salary values. So whenever I give 55,000, then it will fetch the data based on the address. So it will first order the values, and then it will fetch only the rows which is between this 55,000 and the 60,000. So this is what happens when you create a non-clustered index for a column. So the performance of your query will be faster when it is a big table. So if it has a million and billion rows, then you can see the difference, how easily it fetches the rows based on your filter conditions. So here I have a primary key constraint. So it has created a clustered index for me automatically. So I need to create a clustered index for this salary column. So I don't need to have this clustered index for the employee ID. So what I need to do, first I need to drop this non-clustered index for this salary column, so I can create a clustered index for this salary column. So to drop a index, you need to provide drop index and the index name which you have created, and you need to provide the on condition. So you need to provide the table name in which you have created this non-clustered index. So let me provide this here. So let me execute this. So now the index has dropped successfully. Let's refresh this index folder. So now only the primary key is available for me. So now to drop this automatically generated index, you can just copy this name and paste it here. So now when I try to drop this, it shows an explicit drop index is not allowed on the index, it being a primary constraint enforcement. So rather than going with the code, you can just drop the index with the graphic view. You can just right click this and give delete. This will automatically delete
the index for you. So now the clustered index on the employee ID column has been dropped. So now we can create a clustered index for this salary column. So we can use the same code. We can just create a new one. You can give create clustered index, and the name for the index, which is ix, and the table which we are going to give, and along with the column name. So let me copy this, paste it here, and you need to provide the on condition on the employees and the column name employee salary. So now when I execute this, let me refresh this index folder again. Now under this index, you can see I have created a new index, which is a clustered index in this table. Again, you can now select this table. You can see now the table is ordered based on the salary column. So clearly it shows, if at first it has ordered based on the employee ID because it is a primary column, and unique clustered index has been assigned for this employee ID. So now when I changed the clustered index to the salary column, it has ordered the table based on the ascending order of the salary. You can explicitly also provide the ordering condition for the salary. If you need to have a descending, then you need to specify the ordering condition for your index. So this is helpful for us to easily fetch the data. So as the table has been modified based on the index column, so it is easily fetch the values than the non-clustered index. So non-clustered index basically has the address of the value, then it fetches the data based on the address available for the column. But in the clustered index, you can see just the table has been modified based on the ordering position that you have provided for the index. So now when I execute this statement, it will even more fastly return the value for me. So whenever you have a table with a high complex and big data, then these indexes will highly helpful for you to fetch the data without any delay. So let us see what is a unique index in a SQL Server. When you create a table, you can give a unique constraint for a column. So basically a unique constraint is used to enforce the uniqueness in the column. So whenever you provide a unique constraint for a column, then you can only insert unique values inside the column. If you try to insert duplicates inside the column, then it throws an error. So whenever you create a unique constraint column, then SQL Server automatically creates a unique index for you, and you can also even create a unique index in the code itself. You just need to provide create unique index. Let me provide a unique index for the employee name. So you need to provide create unique index and a name for the index. So let me copy this, and here I am going to provide the index for this employee name column. So let me provide employee name here. This is the name of the index, and you need to provide the on condition and the table name, and you need to pass the column name. Now let me execute this. So here I have created a unique index. So now let me refresh this. You can see here the SQL Server has created a unique non-clustered index for me in this table. So we can have only one clustered index. So it has created a non-clustered index by default when I provided a unique constraint. So this is helpful for me to handle the data integrity in my table. So whenever I insert a duplicate values inside this employee name column, then that can be restricted by this unique constraint. So whenever you explicitly provide a constraint for the table, then automatically an index will be created for you. So let me show that. So here let us select this employee table. So now you can see, let me execute this. So this table contains 10 rows. I have an employee ID, name, salary, and the department ID. So for this, let me going to insert a unique constraint for this employee name. So I am going to provide the alter command, alter table, and the table name. I am going to add a constraint. So add constraint as unique constraint for the name. So let me provide the name here, and let me provide unique command, and after this I need to pass the column inside this. So let me pass the name column. So once I execute this, so now the unique constraint added successfully. Let me refresh this index. So here you can see the SQL Server automatically created a unique index, which is a non-clustered index for me. So rather than creating a unique index with a code, you can also create a unique index whenever you add a unique.
What is variables and what is dynamic queries in SQL Server? So basically we use variables just like in any other programming languages to hold a particular value. The variables can be an integer type, a varchar, or an date time type. You can store any of the values for your variables, and you can use those variables in your SQL commands and execute dynamically. So there is a dynamic query option in SQL Server which can be used to execute your queries dynamically in the runtime. So let us see some live examples in our SQL Server. So how to declare a variable and how we can use those variables with certain data types to achieve certain logics in our dynamic queries. So let us get into SSMS to see some live examples. So here I have connected inside my SSMS. Let's open this training database. Under the tables folder, I have a employee table. So let me take this. So let us select this table, use this select command. So now here you can see I have a employee ID, employee name, department ID, and their salaries. So here I can use variables to hold any of the values. Like if I need to hold a department ID and I need to use that variable to fetch my rows, then I can declare a integer type variables. So if I need to fetch this employee name, so then I can create a variable with a varchar, which is a character data type, and declare the name to the variable and fetch dynamically in my query. So to declare a variable, first we need to use the declare command, declare, and you need to give the name for the variable. So basically a variable which start with the prefix of @simple, and you need to mention the name for the variable. So I'm going to give the employee ID as my variable name. So employee ID, this is an integer type, so I have creating an integer type variable. So I have declared a variable first, and then now I need to set the value for the variable. So you can use the set command to set the value for this variable using the set, and you need to provide the name of the variable, and you can provide the value for the variable. So I'm going to provide 3. So I'm going to select employee with the ID 3. So here I can just select the records from the employees table. Here I am going to apply the filter through where condition, where the employee ID is equal to this employee ID variable. So if you have declared a variable, then you need to run both the declare and the select command. So you need to run each of the queries that you have used declare command. So if you need to execute this variable, you need to select all these, and you can just execute this. Now you can see the select query got fetched the particular employee who is with the ID 3. So you can just say hey, I can just provide the employee ID 3 here itself. So what if you need to make this as a dynamic one? So if you are creating a store procedure or a function, so you need to fetch the data from the output window, which can be a web application or a web page. Then you need to configure your store procedure with a dynamic variable, and you need to fetch the ID from the website, and you need to pass to the SQL Server and fetch the rows. So now let me create a procedure. You need to use the create procedure command, and you need to provide the name for the procedure. Let me give us a get employee details, and here you can pass the parameters, which is the variable that you are going to declare. So I am going to declare an integer variable for this, and here you need to provide the as command and begin and end. Inside this, I am going to provide the select statement, which is select start from the employee table, where the employee ID is equal to whatever the ID I am going to pass to this variable. So now let me create this procedure. So now the procedure got created. So to execute this procedure, you can just provide the execute and the procedure name, or you can just provide the procedure name alone, and you can pass the ID along with this. So here I am going to pass the ID 3. So let us execute this. So now the procedure got executed and fetched only the employee with the ID 3. So let me provide the ID 7. So now it is fetching the employee details with the ID 7. So in such way we can use our variables, and you can pass the value for the variables from outside the procedure, and you can get the details of the table dynamically. So here we can also provide the character variable, which is a employee name. Let me provide this as varchar, and let me provide as create or alter. So I am going to alter this existing procedure, and here I am going to provide and condition, and the employee name must be equal to the employee name variable. So now let me again execute this command to create this procedure. So now the procedure got altered. Here I am going to pass the next parameter, which is the name. So let me select the value. So here I am going to copy this name from here and paste it here. So in this execute statement, I am going to pass two values, which is the employee ID and the employee name. So now when I execute this, you can see that the employee with the ID 3 and the name with Michael Johnson has been filtered out. So you can create any variables with any data types, and you can use that to pass to your queries and fetch the results as well. So you can use variables to hold a value, and you can pass those values to your queries and fetch the details. Then what is a dynamic queries in SQL Server? So let us see with the example. Here I have a sample table which contains a column 1, column 2, column 3 and column 4. So now let me create this first, and you can see in this columns I have special characters. So I have a backslash, circular brackets, asterisk, hyphen. So in SQL Server, whatever with the space or anything enclosed in a square bracket, then the SQL Server accept those values and treat this as a single word. But in certain formats, like in Parquet files, if you try to store these values, the Parquet files does not allows any special characters in their headers. So in such scenarios, or if you using a join union condition to a same table, which is a modified one which contains only the column name without a special character, then in such cases you need to realign this column names. You don't need to modify any column names. You can keep the table as it is, and you can create a dynamic query, and you can map those columns and remove those extra special characters. So this is a wonderful scenario. We are going to implement this with the help of dynamic queries in SQL Server. For this, let me just create a variable. So I'm going to create a variable for the table name. So let me provide as table name. So this variable is a character variable, which is going to hold the name of my table. So here I'm going to provide the set command. Set the table name is equal to the sample table which we have created now, and then I need to provide a variable again which is going to hold all the string values, that is a dynamic expression generated by the loop. So let me declare a variable like yes. So this is going to be a varchar. Let me provide max for this. So this is going to iterate all the columns from the sample table and going to store this with the alias name. So after this I am going to set the value for the variable. Here you can write the set command, set the variable yes equal to, I am going to set this as an empty string. So at first this is an empty string. Here I am going to implement my logic. So I need to first select the columns one by one from the table name, and I need to give a alias name for those columns, and while selecting the table I need to select the table with those alias names. So for this I am going to use a dynamic query. So let us select this variable, and I am going to assign the same variable again to itself, and I need to perform certain logics. That is, I am going to enclose the columns in the square bracket. So before these things, first let me select the columns from the tables. To find the columns from the tables, you can use the sys.allColumns, which is an system table that contains all the information about the columns that you have created in the database for your tables. So here when I select this, select start from sys.columns, you can see it shows all the column names for all the tables that I have created. So I don't need all the columns, I just need only the columns which I have created for this sample table. So again you can use the system table, which is a sys.table, which contains all the information about your tables that you have created under the database. So I am going to join both these values. So let me provide a join condition. Let us take this as a alias name C, and I am going to join this with sys.tables, which is going to fetch the name of the table. So I am going to provide the on condition. In the on condition you can provide the objective name. So here you can find the objective ID. So this objective ID is common for both this sys.tables and sys.columns. With this objective ID we can map both the tables and create a relationship. So let me provide the objective ID here. So now you can see when I select this, the sys.tables and sys.columns has been mapped together, and here is a resulting query set. From this I need only the table which is with the name that holds the table name variable. So here I am going to provide a where condition where the table name is going to be the variable name. So when I execute this entirely, you can see I got all the columns, right? So here I have 4 columns. So I have passed the table name and fetched all the columns from the tables. So from this I need only this name column. So I am going to give c.names alone in this select query. So now again let me run this. You can see I got all the columns one by one. So we have completed the first step. We have filtered all the columns from our table dynamically. So now I am going to execute the replace statements for the columns. So I need to replace all the special characters as an empty string. So for this, let me execute. Let me provide this variable, and again I am going to provide this variable. Let me provide an open bracket in a string format. So this is going to concat all the values that I am going to provide. So this plus is used as a concat operation. So I am going to provide all as a string format. So I need to enclose all the column names with, yeah, after this I am going to provide the close bracket and the as command, which is going to be the alias name, and an open bracket, and after this I am going to provide the replace command. So this replace command is used in SQL Server to replace certain values in your columns. So replace of the column name. So if this column contains a backslash, then I need to replace this with an empty string. So we are going to provide this replace command for all the special characters that are present in our table. So here again I am going to provide, if it contains a open bracket, I need to replace with the empty string, again for a close bracket, and then for asterisk. So finally a hyphen. So I need to replace this with a empty string. And once all the replace command has been completed here, I am going to end this with a close bracket and along with the comma. So this is going to separate all the values for me. So here I have provided the dynamic query, and after this has been selected, I need to remove the final comma so that it will be works fine. For this I am going to provide a if condition. If len, this len command is used to find the length of the string that you have passed. So I am going to pass a variable which holds the string value. If it is greater than 0, then I need to set the value for this variable, which is I am going to use the left function and pass the variable here and provide the length value, length of the variable -1. So this is going to fetch the last comma, and then finally I am going to set this into a result variable. So here again I am going to provide a result variable which is an at result, which is a varchar. We provide as 255, and then here we can use that variable to select the values inside this. So let me provide the set command and provide the value for this result variable. Inside this I am going to pass the value select as the at, yes, and then the n varchar of from, and then again we are using a inbuilt function which is quad name. This is going to quad the table name which I am going to pass in this variable. So let me pass the quad name of my table variable, and once all done I am going to execute this at result. So let me provide the execute command. There is also an inbuilt function which is a execute SP execute SQL, and again you need to pass this variable here. So now I am going to execute all this together. So we provide the variable as a n varchar. So you can just take this as Unicode string. So when I execute this statement, you can see now the table has been selected with the modified column names. So all the special characters has been removed, and in the result set I have achieved the column names without any special characters. Let us insert some values inside this table and show you. Insert into the table name, which is sample table, and let me provide the values, and for 4 columns
So let me provide a few values for this. Let me execute this. So if you just select this table, start from this sample table, you can see the column names contains the special characters. So when I execute this dynamic query, you can see now the table has been selected with the column name, and now here the column name does not contain any special characters. So you can use this dynamic queries to execute certain logics like this.
What is normalization in SQL Server? So normalization and denormalization are a process involved in SQL Server databases to avoid redundancy of the data and manage tables efficiently in your database. So normalization is a process which can be used in your database to reduce the redundancy and dependency of your tables. So it is typically involved in decomposing the tables. So breaking up a large table into smaller tables which ensures that it will not be any dependencies and there won't be any redundant data. Redundant data are the duplicate data which is repeated again and again in a table. So normalization is just breaking down a big table into small, consumable and related tables. So denormalization is combining small tables to improve the query performance of your tables. So let us see a deep analysis of what is normalization and the use of normalization and what are the types of normalization available in SQL Server and how we can use that in live queries. So let us get into SSMS to understand more about database normalization. In SQL Server, the normalization can be defined as 1NF, 2NF, 3NF, up to 6NF. This is nothing but NF is normal form. So we can break down our tables, a large single table, into multiple tables to manage and avoid the redundancy in our data and avoid the duplication. So it will be easy to manage for us. So what is a 1NF? 1NF is also known as a first normal form. So a first normal form is usually known as a table that does not contain any duplicates, and all the values in the table are atomic value. Atomic value is in the sense it cannot be divided further. So the value in the column for the table is unique, and there won't be any repeating groups or array contained in the column. So if a table is in such a way, then it can be said as first normal form. So what is a second normal form? So if a table satisfies a first normal form, then we can also take the table for a second normal form. In the second normal form, we can break down the table entirely into a different table. So we can ensure that all the non-key columns are fully dependent on the primary key. And in the third normal form, we can reduce the transitive dependencies available in your table for the non-key columns. So let us see some examples so you can understand this better. So now I have a table called table with multiple call. So let me first select this. Let me first uncomment this. So now let me execute this. In this table, you can see I have an ID, department name, employee 1, employee 2, employee 3. This table shows that in the department marketing, I have 3 employees, but I have a duplicate column. So if a table need to be in first normal form, you don't have any repeating columns or a duplicate columns. So in this table, you can see the employee column has been duplicated. So this may causes redundancy for our data, or it can allows the table to have anomalies in it. Anomalies is a false value that can be avoided if it is a normalized form. So here is another table which is a table with. So in this table you can see I have an ID, department name and employee name. So this is same like the previous table, but in this table you can see for the employee column I have a employees but an array of employees. So I have 3 employees in the marketing, but I have all the employees in a same row, so separated by a comma. So what causes an anomaly? So if I need to update a single person, let's say for example I need to update the Jane Smith in this marketing table, then it would be so much difficult for me to update such values in this table. So to make these 2 tables as a first normal form, we can create a table like this. So let me show a modified table which we have created. So here we have the same ID, department name and employees, but here you can see there is a marketing row, and the respective employees has been separated into separate rows. So this shows the table cannot be break down further, that is all the columns have unique values, so there is no repetition of duplicate columns, and also the each row contains a single value which can be easily updated. So now if I need to update this Jane Smith, I can use the ID2 and update the value. So while comparing with the above two tables, we can see the third table is in a normalized form. So this is what the first normalization is. The table must not contain any duplicate columns, and all the values in the table must be in an atomic value. So let us see what is 2NF further. So for this, let me create this employee courses. So now let me insert these values inside the table. So 8 rows got affected inside the table. Let me select this table. Select start from the student course. When I execute this, you can see I have a student ID, student name, course ID, course name, instructor. So here you can clearly see I have a student ID and their respective student name and the course that they have enrolled, and for the course ID we have a course name and the respective instructor. So here you can see the course ID 101 for the mathematics, and the head of the instructor is Dr. Smith. So this shows that in this table the course ID, the course name and the instructors are dependent on the course ID column. So all the non-primary key columns are not completely dependent on the primary key column. So when you take this student name, it is completely dependent on the student ID. So this student name is completely dependent on student ID, but the course name is also dependent on course student ID, but it is partially dependent on the course ID, and also the instructor is dependent on student ID but partially dependent on the course ID. So in such situation we can break down the table into two separate tables. Let's say for example I am going to create student data, keep as only, and here I have to give student ID which is a primary key. Let me copy from here. Let me copy this and paste it here, and I can create another table which is course. In this course table I can just provide the course ID, course name and the instructor. So for this table let me provide the course ID as the primary key, and here you can refer foreign key of the course only table and the course ID here. So now when I create both of this table, so I need to create this table before referring it in the foreign key. So now you can see I have separated the single table into two different tables. So here you can see that the course name and instructor are completely dependent on the course ID, and this student name and course ID is completely dependent on student ID. This is what the second normalization form is. So all the non-key columns are completely dependent on the primary key column. None of the column have a partially dependence on any other column. So here you can use any joins relationship based on this primary key and foreign key and establish relationship for your table and get all your queries in a single result set. So what is the use for doing this? So we are separating both table into a separate single table. So by separating this we can actually reduce the space. So if I have created the course table, so I can just insert values to this course table, insert into course and values, here I need to pass the course ID, which is 101, and the course name along with the instructor. So totally I have 4 courses. So I can just insert 4 rows for my courses table. So by inserting these 4 rows, I can avoid using this course name and instructor for again and again in this student table. So in the student table, I can just have the student ID and student name along with the course ID. By referring to the course ID, I can get this course name and the instructor without using this course name and the instructor multiple times in my table. This can reduce the storage space for me, but when I have a million of records repeating itself, so I can just use this course ID and fetch the course name and instructor from the courses table, then using it again and again in the same table. Also, it can be easy for me to edit the values. So let us also see what is third normal form in SQL Server. Here I have an orders table. Let me create this first. So let me take this as order table. So now command executed. Let me copy this name, paste it here. So now let me insert this 3 values inside the table. Now let us select the value in this table. Here you can see I have a order ID, customer name, product name, quantity, unit price and total price. So from this table you can clearly see the customer name is dependent on the customer ID, the product name is dependent on the product ID, and the unit price is dependent on the product ID. So we can just create 3 separate tables, which is a table for order details, where you can have the order ID, and you can have the customer ID, and then you can have the product ID along with the quantity and total price. So again we can have another table for our customers. Let me have as customer only. Here I can have the customer ID, which is a primary key, and I can refer this customer ID as a foreign key based on this primary key. And also we can have customer name here. So this is for the customer table, and again we can create another table for this product details. Here we can have the product ID, which is a primary key, and we can refer this primary key in this table as a foreign key. And here we can have the product name, also the unit price for each product. So now you can see, if I need to add or modify any customer, I can just use this customer table to modify my rows. So I can update the customer value once in this table. So I have a customer ID, I can just update the customer. So if I need to update a customer name in this orders table, then I need to update all the rows where the customer ID is present. So this will dramatically reduces my times to update the values. So breaking down these tables is also, we have seen like this is the second normal form. So here you can see all the columns are completely dependent on the primary key of the table. So but in the orders detail you can see the order, customer ID, product ID, quantity are completely dependent on the order ID. But this total price is also dependent on the order ID, but it is partially dependent on the quantity, which is a non-ID column. So this is not a non-key column. So when a column is dependent on the non-key column, so this total price is dependent on the quantity, also the unit price. So basically a total price is the multiple of the unit price and the quantity. So in the third normal form we can just take the transitive dependencies. So these things are transitive dependencies. We can just remove this, and whenever you need to calculate those columns, you can just add a aggregate functions. So in the select statement you can have select. So you can just join those tables, and in the result set you can just multiply the quantity along with the unit price, and you can take this as total price from the both the joined tables. So the column total price is dependent on the non-key column. So removing such transitive dependencies will also helps us to perform the queries very efficiently, and the data storage will be very much easy for us, and it can be easy to maintain our data without any redundancies and duplications. So we have seen what is a normalization in SQL Server. Okay, we are going to see some few tips and tricks to improve your productivity in SSMS. So there are a few additional things that you can use in SSMS to improve your productivity. So you can import your files into your tables easily from the SSMS itself, and you can even generate queries from SSMS. So let us see some tricks and tips in the which can be used in SSMS for your SQL Server. Let us get into SSMS and see those with live examples. So here I have connected to my SSMS. I have connected my on-prem SQL, and I have connected also Azure SQL. So let us first open my on-prem SQL. Here I have two databases. Let me open this training database. So first thing we are going to see like how to generate a script for a table or for a stored procedure. So let me expand this. Let me expand the tables. Let me show you. I just need to want the script of this consultants table. So we don't need to generate the script by typing the create statement. You can just simply right click on this designer. Once you right click this, you can see there are inbuilt queries. You can select top 1000 rows from this and edit top 200 rows, and you have option to script tables. If you select top 1000 rows, this will give you the select query to select the top 1000 rows from this table. So it automatically generates a query for you, and it will be executed and the result will be shown. So I just need the schema. So let me right click this. Here you have the option as script table as, and you have option to create the table, or you need to want the query of drop the table. So I just need to create a table. You can even have it as a file, or you can copy it to the clipboard and you can paste it anywhere. So there is also another option to generate the query in a new query window. So I'm just giving that I need to get the schema in new query window. So here you can see so here SSMS has automatically generated the table creation script for me based on the table that I have loaded previously. So even with the database name, it has generated a script. So this is an easy way to write scripts. So if you are working in NSQL project, writing queries like with a small case and uppercase is not a good approach. So follow the same pattern as the generated script. So you can see all the inbuilt keywords are in capitalized letters. So it will be easy to understand for the query developer when you work with your organization and collaborate your codes. So if it is a table, it will be better if you can provide a TDL prefix, so the users can easily identify. So it is a table, and from the name you can easily find that it is a table or it is a stored procedure. If it is a stored procedure, you can start with the prefix SP, and if it is a function, you can write so on. If it is a view, you can view VW, and there are so many ways to align your codes. So here you can see the create table script is in the first line, and we have opened a bracket, and with the tab space we have provided the column name along with the data type and the constraints. So enclosing a square bracket is a good approach. If you are providing a name with some spaces, then this square bracket will allows you to execute the query without any errors. So it is a best practice to use those square brackets in your queries. And there is also another option, an if statement. If you are generating a script query to store it anywhere and use it later, then you can better write an if condition at the top of every table creation, which is if object id of, you can pass the table name, which is the consultant, is not null, begin, end, and inside this you can provide the drop command, drop table and the table name. So by providing this, you don't need to write the drop command and then the create command. You can just execute this. So if the table present, it will be automatically dropped and the new table will be created. Just like the same thing you can have for store procedures. You can find the store procedure in the programmabilities, and here I have a one store procedure. You can right click this and script store procedure as, and you can give create to. So here I am copying it to a clipboard, and now I can paste it here. So here you can see I have the create procedure command. So here also you can provide this if condition. So let me just copy this and paste it here. Instead of this table name, you can just provide the procedure name. But you need to remember, if it is a procedure, you need to provide procedure. So the SQL Server will identify that as a procedure. So in this begin and end, you have to provide drop procedure and the procedure name. So maintaining the scripts with these things will eventually help you when you are storing these queries, and some other developers working in the same projects uses this query, then it will be easy for them to identify what all are the tables and procedures used, and it will be easy for you to manage your codes accordingly. So you can also generate the store procedure scripts from the code itself. You can just use SP help text function, which is an inbuilt store procedure to get the procedure in your output. So here I am going to pass the procedure name. When I execute this, you can see in the output window I got the procedure as a script. So I can copy this and paste it here. I got the same procedure script from the output window by using this SP help text. So you can even right click and generate the script like this, or you can generate through the code itself. So here I have provided the table creation script. So here I can get only the schema alone. So let me get back again to the tables. You can see when I right click this, and you can have create to, drop to, and drop and create to. This will only provide you the schema. What if you need to have along with the data and the insert scripts? There is also another option for you. You can just get back to the database. You can right click on the database itself, and here you can see the tasks. In this tasks, you can scroll down. Here you can find the generate scripts. Just click on this generate scripts. You can find a pop-up window. Here you can see they have provided the steps for this wizard. Select the database and specify the scripting option. So you need to provide which object you need to select, and what is the mode you need to retrieve the query, and you can review the selection and generate the scripts. So now first you need to click next, and here you can select any of the objects that you have created in your database. So if you need the entire database script, you can do that. I just click on this specific object, and I'm just giving this consultant table alone. So you can even select multiple objects and click next. Here you can find an advanced button. In this advanced tab, you can find, scroll down this. Here is an option, types of data to script. Here they have provided as schema only. There are three options available for us, which is data only, schema only, and schema and data. The data only will generate only the insert scripts which are available inside the table that I have selected. So schema only will generate the script only the schema of the table. So I need the schema and the data. So I have selected schema and data and click OK. Here are four options: save as a notebook, save as a script file, save to the clipboard, or open in a new query window. I just click open in a new query window and click next. So here you can review what is your selection. So I have it displays the server name, database name, and a selected object. So I have selected the consultant table only, and the destination is a new query window. So let me just click next. So it is generating the script. Let us click finish. So here you can see along with the table creation script, I can have the insert statements. So whatever the insert values I have inside this table, what are the values available inside my table, it will be generated as a insert script for me. So I can take this script and run in any other databases, just like in our Azure SQL database. I can run this query and create the table and insert those values. So this will be another cool function in SSMS. They have provided so many inbuilt functions that will be easily useful for many things. So we have seen how to create a generate script for our tables, store procedures, and you can do that for your functions and views too. And we have seen how we can write the queries, how we can maintain it readable and reusable. So here we can also have other option to transfer the data to another database. So let me open this Azure SQL database. Inside this database you can see I have so many tables. So this consultant table is not available in this Azure SQL database. So I'm not going to generate a script and going to paste there and run the query. I'm just going to migrate the table from this server to my Azure SQL server. So we can perform those operations even in the SSMS. For this you can just right click on the database and you can find the tasks here. In the task you can just scroll down. Here you can find the export data option. Just click on the export data option. In the export data you can find the wizard. So just click next in this. Here you can provide the source for the migration. So it allows me to select what source I am going to migrate from. So I am going to select the OLEDB provider for the SQL server. This will actually connect to my server. So I am inside my on-prem server, so it will be automatically selected. So I have my server and I have it in a Windows authentication, and also the default database that I have been using has been selected. And so now let me click next. So I have selected the source and now I need to select the destination. So again I click this drop down and select the OLEDB provider for SQL Server. Here I am going to provide the server name for my Azure SQL. So let me move it here. Here let me copy this server name. Let me paste it here, and in the Azure SQL I need to use SQL authentication. I have provided SQL authentication, so let me provide the username and password for this. So once I provide the authentication, you can see it lists all the databases available in my Azure SQL. So let me select the database and click next. And I can select any of the tables from the source on-prem SQL and move to this destination Azure SQL. So from this, let me just select this departments table. So here you can find the edit mappings from here. So you can just click this and edit your mappings over here. So if you need to edit the data types, you can edit from here. If you need to increase the size for the character value, you can edit here. And if you need to provide it as an nullable value, you can provide it here. So it will provide you to edit the mappings for your tables here, and you can just click next and you can give run immediately and finish. Once you click finish, it will automatically execute the query and the table will be successfully created in the destination, and it shows how many rows affected. So totally 5 rows got affected in the table. So it is just a small table that has been loaded. So let me select this Azure SQL. From here let me refresh this tables folder. Let me just provide the select statement, and here you can find this department table. So the table has been migrated from the on-prem SQL to the Azure SQL through the wizard helpful in SSMS. So we can easily migrate the tables and views from the one database to another database, even from the SSMS itself. So also we can just not only migrate the tables, we can just load our data into the tables in SSMS. There is also options to load your data from your files. So let us see for an example. I have an CSV file. So here you can see I have a CSV file where I have an ID column, employee name, and a salary column. So I have 7 records totally. So I have saved it in my local folder. So let me first go by step. I am going to load the data into this training DB. So let me right click this. I can just go to the tasks, and here when you scroll down you can find the option import flat file. Let's just click on this. Here you can click next, and here you need to provide the path where your file is located. So let me click browse, and here you can see inside the input data I have this employee.csv. Let me open this. So it automatically suggests a table name for me. So I am going to rename it as table Excel employee or table CSV employee. So I can create it under any of the schema that are available in my database. So let me keep it as DBO and click next. So you need to close the files. If it is open, you cannot perform the migration. So let me just close this file. So now let me click next. So it shows the preview of the data which is available in my CSV. So I have the ID column, employee name, and the salary, and the 7 rows will be has been displayed here. You can review this here and click next. So it automatically suggests the data types for your destination table. So here if you need any other data types, you can select it from this drop down, and you can provide any foreign primary key constraint, and if you need to provide this as a not null value or nullable value, you can edit everything from here, and you can click next, and here you can see the summary. So I'm going to import the CSV to my server and under the database to this table from this file. Let's click finish. So the insert data has been successful. Once I close this, let me scroll down. So let us refresh this table folder. So we can now find the table CSV employee. So let me select this, select start from this table. So here you can see I have loaded the data available in my CSV into the SQL Server without any external tool for migration. You can just load it from SSMS itself, and you can avoid migrations for these things. So I hope this session will be helpful for you to learn some tips and tricks which can be used in SSMS to improve your productivity. We have seen how to generate scripts for our tables, views, and functions, and how we can generate the scripts along with the insert statements that are data available in our tables, and how we can easily manage our codes through if conditions to reusability, use it, and the structured way to write the scripts, and how we can load the data from our files, and how we can transfer the data from one database to another without any external tool, even from the SSMS itself. So we have finally completed the SQL Server playlist. So please watch all the videos in the SQL Server playlist, and further we are going to cover some scenario based SQL Server queries. Along with that, I am going to provide the videos for the Azure Data Factory. So we are going forward combinedly learn both things. So please subscribe to the channel and watch all the videos. Thank you for watching.